concepts covered in these data structures, right? Right. So data structures. What is meant by a data structure? So the name itself indicates data structure. So that means organizing the data in the memory is called a data structure. So there are different ways to organize the data in the structure. So one example we have seen in the C language, that is arrays. So array is also a collection of elements. That means a collection of memory locations. So because in the memory locations we are going to store the values, right? So in that, the structure of data is a sequential. That means one after another, right? So it occupies the continuous memory locations. So it is a collection of elements in that continuous memory locations. So that way the data is organized using the arrays data structure. So finally, the definition of data structure means organizing the data in the memory location. So how many ways we can organize the data in the memory location, right? Now let us see how many types of data structures. So there are two types of data structures. So one is primitive data structure and another one is non-primitive data structure. Primitive data structures and non-primitive data structures. Coming to these primitive data structures, we have already seen those data structures. See, so these primitive data structures are our primitive data types. Yes. So int, float, character, double, and pointer. Okay. So all these comes under primitive data structure. Non-primitive data structure. Now, so these we have studied in C language. These we call them as primitive data types, right? Integer, float, character, double, and pointer. It's a single memory location which can hold the value only, right? Next, coming to this non-primitive, it's again divided into two types, that is linear data structures and non-linear data structures. Linear and non-linear. So linear means a sequential, that is nothing but a sequential. So non-linear, which is not a sequential, that we can call it as a random, right? So this is a sequential. This is random. That means in this all the data will be arranged in sequential manner. Here the data is arranged in random manner. Now what are the types of linear data structure? So first one is arrays, lists, stacks, queues. These four comes under linear data structure. Non-linear data structures, only two categories are there. One is the trees and graphs. Trees and graphs. So again, so this we have seen in C language, arrays, the sequential elements, right? So now we have to see about the list, stack, queue, trees and graphs. So how the data is arranged in list, how the data is arranged in stack, how the data is organized in queues, how the data is organized in trees, and similarly graphs. So these are the different types of data structures, right? So in the list there are a number of categories. So under this, one is single linked list, double linked list, circular linked list. LL means linked list, right? So here in trees we are going to discuss about binary trees, binary search trees, and there are a number of trees, right? So we will discuss in those sessions, right? So finally, the data structure introduction is this thing. So primitive and non-primitive, right? And now there are common operations can be performed on these data structures. Operations. So the major operations which can be done is searching and sorting. So we can search an element in the data structure, right? So in the list, we can sort the elements, and then see, we can insert the new element, right? Insertion. Similarly, deletion. We can delete one element. Next, updation. So we can update the elements. So that means we can replace one element with another element, right? So these are the common operations to be performed in these data structures. So we can search an element in linked list, we can sort the elements of a linked list, we can insert an element into the linked list, we can delete the element from the linked list, and we can update the element in the linked list. So these are the common operations. So I will write here common operations on data structures. So this is the common operations on data structures, right? So we are going to discuss about the list. In the list, we have to apply all these operations, and then we have to see the stacks, and we have to apply all these operations. We have to cover the queues and all these operations. Similarly, trees and graphs, right? So hope you got an idea about these data structures, and definitely I am going to upload the videos on all these concepts, right? So let us stop here. So from the next session we will start with the arrays. So our arrays are already seen in our C sections. So we will see the advantage and disadvantages of arrays, right? And then we will move on to the list. In the list we have to see all these three. So in the coming sessions we will cover all these concepts. To create a class and how to create an object. Right. So a class can be having both the attributes and the behavior. So that we call it as data and functions. So class can have the data and functions. So both the data and functions will be combined and called as a class, and these two are called as class members, right? So how to access these class members? That means either data or a function. So how to access the data or how to access the functions of a class? So that can be done, accessed with the help of object. So if you create an object, with the help of that object, we can access the data and functions of that particular class. So this object is a reference to this class. So once a class is defined with the data and functions, an object is created as a reference to the class, so that object, with the help of this object, we can access the class members, right? Accessed by an object. So let us define here. So let it be a class having So let us take a student as a class. A student class is having R number, name, and a branch. So three attributes, or simply we can call them as three variables, or the data. Okay, the data. And functions, we can use a read function, and the write function. Right? So this is called a class. And for this, in order to access this one, we have to create an object. So how to create a, so these are the data and these are the functions. We know that the functions always starts with the def keyword. The same way here we will write. So a class can be represented in Python as a class. So it should be, the class should be defined by using the class keyword. So class followed by the class name. It's a block of statement. So this is the data and functions, function 1, function 2 and so on. So this is how we can represent a class in Python. So here in Python programming, a class is a block of statement. Class represents a block of statement. So here we should write both the data and functions. Right. See, I will write a student's class. So class student block of statement, so indentation. Then here we can write the data. R number is equal to some 1 2 3, some name is equal to some ABC, some branch is equal to CAC. So whatever the data we can write here. So and then functions. So we know that the functions, it's a user defined functions, but these are implemented in a class. So every function should start with a def keyword. So def, the function name. So read colon, because it's a block. Here just I am writing only the print statement. So I am writing only the print statement. So reading. Right. Similarly, def write function, print writing. Right. So this is how we can create a class. Right. So outside the class, that means after ending the block of statements outside the class, now if you want to access these data or functions, we have to create an object. And see, one more thing should be remembered, that every function, the argument list starts with self. So self is an implicit instance. So self is an implicit instance or implicit reference. So if you know Java, this keyword can be replaced with a self. The working of this is nothing but our self. So always the user defined functions which we are writing inside the class, the argument should be self. So it is a mandatory for every function. So if you are not writing this self as a parameter to the user defined function, definitely you will get an error, because it will treat the first argument as a self and it is a mandatory. So here you have to write it as a self. So if our user defined function doesn't have any arguments, then only one argument will be there, that is self. If our user defined function is having two arguments, then the first argument will be the self and the second argument will be some other variable A and the third argument will be C. Right? So self is a mandatory. Self is a mandatory, and that is that must be the first argument in the argument list. Right? And now this is how we can create a class. This is how we can create a class. Now the question is, how can we access these variables and these functions? And for accessing this one, what we have to do? We have to create an object. So here the syntax for object is So whenever you write this class, the object will not be initialized until you create the object. So object is, the creation syntax is object name is equal to class name parenthesis. Class name parenthesis. So here object name is equal to class name parenthesis. Here the object name is an identifier. So we have to follow the rules of an identifier before giving the name for an object, right? Let it be, I am giving here some ABC is equal to student. ABC is equal to student. So ABC is an object, or simply we can write it as some S1. Okay, S1 is equal to student. S1 is equal to student. That means the student 1. So S1 is an object for student, and similarly some S2 is equal to student. So we in the yesterday session I have said that one class can have multiple instances, number of instances, right? So similarly one student class can have multiple objects. So here I am creating two objects, S1 and S2. So if you want to access this data and functions of a class, simply we have to access with the help of the object name. So S1 dot R number will give the given number. Similarly S1 dot name will give the name which is given in the class. Similarly S1 dot branch will give the branch value here, and these are called instance variables. Instance variables. So if you are creating the variables inside the function, those variables will be called as local variables, right? So here the variables are not a local variables. These variables are defined inside the class but not in the function. So that's the important thing you have to remember. So variables which are declared inside the class but not inside the function, those variables are called as instance variables, and that can be accessed only with the help of object name or the class name. So we can also access with the class name student dot R number. Similarly student dot name. Similarly student dot branch. So in any way we can access the data. Similarly if you want to access the function, we have to write S1 dot read, S1 dot write. So in the function call we need not specify any parameter, but inside the function definition we have to write the self parameter. And similarly here also we can access these functions with the help of student name. So class name. So that is a student dot read, student dot write, or S1 dot read or S1 dot write. So these members can be accessed with the help of object or this class name, right? And if there are local variables, that are variables which are declared inside the function, those variables can be directly accessed. Okay, only the instance variables, that means the variables. So just remember, the variables which are defined inside the class outside the function are called as instance variables. These instance variables can be accessed only with the help of object name or a class name. So this is all about our class and object. So how to create a class and how to create an object. So a class can have a data and a function, both we call it as a class members. So in order to access those members we have to create an object. So object creation syntax is this one, object name is equal to class name parenthesis. So one class can have multiple instances, right? So we'll stop here and we'll see the implementation. So how to create an object and how to create a class and how to access the data members, class members, that is a data and functions. So we'll move on to the interpreter.
Hi friends, so just now we have seen how to create a class and how to create an object for that class and how to create variables and the functions. So we have said that a class can have a data and a functions, right? So how to create that one, let us see this one now. So we have to begin a class with the class keyword. So class followed by the class name. So let us take student as a class name. So a class is a block of statement, so which contains the variables and functions. So student. So here we can give a student variables, different variables. So let us take some branch is equal to CSC, and I am writing the function DEF. So in Python, every function, user defined function, should start with the DEF keyword. So DEF, so read. So I am writing the read function. So a student can read. Okay, a student will be having some branch, roll number, name, and so on. So our number is equal to 1 2 3, and similarly name is equal to some ABC, right? So read function. So read, just I will write a simple thing, print reading, right? So let us close this. So this is a class, so which can have the variables as well as functions. So we can write a multiple functions here. So a class can have a multiple functions and a multiple variables. Now in order to access the function of this class, we need an object. So without creating an object, we can't access these variables or these functions inside the main function. So here I am creating an object, some ABC is equal to. So this is the syntax for creating a object. So ABC is equal to student. Now ABC is an object for the class student. So in order to access the objects or variables of a student, that should be accessed with the help of object name. So print ABC, our number is equal to object name dot r number. So without using the object name, it cannot be printed, right? Similarly print name is equal to name, print branch is equal to branch, right? And if you want to access the function here, that also should be done with the help of ABC dot read. Sorry, here I didn't access these members using the object. So once again I am repeating. So if you want to access the class members, and that should be done with the help of the object created for particular class. So here ABC is an object created for the student class. So in order to access the variables and functions available in that student class, that should be done with the help of this object ABC. And a class can have a multiple objects, right? So I will just save this one. So here I am saving that one. So student class dot py, right? I will run this one. So you can get this R number, ABC, and the branch. And here you can observe that ABC dot read is having an error that read function takes as 0 positional arguments, but 1 was given. So why? Because here if you are writing any function, or if you are defining any function inside the class, one argument is compulsory, that is a self is the first in the argument list. Self represents the reference or the instance of the same class, So we have to pass self as an argument for the function which we are writing in the class itself, right? So the parameter list will start with the self. So if you are writing two parameters, first we have to start with the self comma a comma b, right? So self is mandatory. Now you can observe, if you run this one, so you'll get the result that r number, name, branch and ready. So if you are trying to access without the class name, what happens? See, you will get the error, right? Because name r number is not defined. So here r number is not defined because r number is the variable declared inside the class. So it's an instance variable or a class variable. So every class variable or an instance variable can be accessed only with the help of the object name or a class name. So you can observe, see, r number is equal to 123. So an instance variables can be accessed through the object name or a class name. So once we have to create an object and then we have to access with the object name or a class name, right? Right. And now see, if we are having the same thing 3 4 5, and here if you are trying to print r number, see, so already we know that the user defined function may also have the variables, right? Not only the class, user defined function may also have the variables. So these variables which are declared inside the class and outside the function, those variables we call it as class variables or instance variable. So these variables should be accessed only with the help of function, I mean class name or object name. And whatever the variables we are declaring inside the function of a class, those are called a local variables. So they can be directly used in that function itself. So if you here see, observe, so I am taking a different name. So roll number is equal to 345. That's a variable declared initialized inside the function. So I am printing the same thing, roll number. So you can observe here. So even though we are executing, so we can get that r number is equal to 123, name is equal to ABC, branch is equal to CAC, and 345 here we are getting, right? So right now, if so, these are the instance variables and this is the local variable, right? Now if the local variable and the instance variables are sharing the same name, the first preference will be given to the function. See, so here only the r number. So whatever the variable we are sorry, right, so whatever the variable we are declaring inside the function, that will be displayed here. See, so you can observe here. So r number is equal to 123, name is equal to ABC, branch is equal to CSC, and roll number is equal to 345. This is the thing we have written inside the main function, inside the read function. And if you want to access the instance variable inside the function, then that can be done with the help of self. So r number is equal to self, sorry, here I will write here instance variable is equal to self dot r number. So self is nothing but the implicit reference or implicit instance. So self, without creating an object, we can use the instance variables with the help of self. So self dot r number. So this will give the instance variable. See, here you can observe that. See, roll number is equal to 123, name is equal to ABC, branch is equal to CSC. Here roll number is 345 and instance variable is 123 because here we are giving self dot roll number, which is nothing but 123. Self is an implicit instance variable, implicit instance of a class, right? So all the variables which we are declared inside the class can be used with the help of self inside the function. And outside the function, outside the class, if you want to access the variables and functions, that should be done with the help of the object. So a class can have a multiple objects. So with the help of the object name or a class name, we can access the class members. Here the class members are instance variables and the functions. So a class can have multiple variables or multiple data and also the multiple functions. So we can write a multiple functions, right? See, so I will write one more function, def. And one more thing, every function should have a single parameter, that is a self. Self is an implicit instance. Right. If you want to access this write function, you have to use abc dot write. So with the help of object. So you can observe here reading and writing.
So this is a linear data structure. So here we'll be having a nodes and which is linking with each other. So this is the structure of a single linked list. So every node, so this is a node and every node will be having two fields. One is the data and another one is the link of the next node. That means the address of the next node. So again, it will pointing towards the next node. Again, we are having some data and the link of next node. So this is the structure of a single linked list. That means every node will be having a single link, okay, which is the address of next node. And here, example, we'll take some nodes. So let it be some 10 and the address of this one is some 1100 and it is pointing towards the second node which is of data 20, and this address, this address, let it be some 1200 and this address will be stored here. So current node will be having the data and the address of the next node. Similarly, this node will be pointing towards one more node with a 30 and this node address will be some 1300 and that will be placed here itself. And again we'll take some fourth node with a 40. This is a 1400 is the address and that will be stored here, and this is the last node. So if it is a last node, the address will be null, so there will be no address pointing. Okay, so this is the normal structure for a node. So here this is a single linked list, so every node will be having a single link and here the link is the address of next node. Now, so this will be the head value. This will be the head value. So we should not change the head value. So head is nothing but pointing towards the first element of the single linked list. And here the linked list, we'll see first how to create a linked list. And the next one, how to display the nodes. Display the nodes of a linked list. Display the nodes of a linked list. In the further sessions, we'll go with the insertion and deletions, right? So first we'll create the linked list. For creating this linked list, if you are aware about C language, we have that dynamic memory allocation and we are having some pointers concept. So by applying both things, so every node can be having the two pointers, that is one is data and another one is the pointer variable. But here in Python, so this implementation is in Python, so right? So in Python, So we are not having the concept of pointers. So for that purpose, so we have to go with the object oriented programming. That means we have to create a class. Okay, in order to create a node, we have to create a class with the two variables. Okay, with the two variables, one is data and another one is next. So next is nothing but the address of the next node, right? So here we'll create a class node and we will create two variables for data and next. So that is the first step. That means we have to create a new node. So the syntax for that one is class node colon and use the constructor to initialize these things. Okay, so I will initialize the constructor. So def. So in Python the constructor is double underscore init double underscore self, and also consider the data. So because if you create a node, so we have to give the data, right? So colon, so self dot data will be the data, and similarly the second parameter self dot next will be none, because if you are creating a node, if it is a first node, okay, if it is a first node, so this is a first node 10. So what about this address? So this is nothing but data. Okay, this is nothing but a data, and this is the next. So for the first node, what about the next? So here we are, the linked list is having only one node. That means there will be no data in the next. That means we are not linking with any other node. So that's why here we'll be having none. Initially the first node address, I mean the next value of first node will be none, right? And so now after creating the nodes, we have to link with the another linked list, right? We need to link with one node to another node. For this linking process, we'll create a one more class called a single linked list. So we'll create a one more class called, so class, okay, single linked list. So here I will give some head because the head is the pointing towards the first element of a linked list. So I will go with this again the same constructor. So def init self colon. So for every definition, every user defined function, including the constructor, the first parameter will be the self. Okay. So self dot head is equal to none. So initially there are no elements. So automatically head points to none. After creating one node, the head will be pointing towards this node, right? So the first step, we have created the node, we have created the linked list. Now we'll insert each and every node and we'll link the one node with the another node, right? So for that purpose, so that means just we are creating, okay, we are creating. For this we will create an object, because through the object we have to add the nodes. So I will give some L is equal to SLL. So one linked list is created and it is empty. Now a node is created, N1 is equal to node of, give the 10. So node is created now. Okay, node is created. So there is a node 10, right? Automatically if you create this one, 10 will be moved to the data. So self dot data will be 10 and self dot next will be none. So by default here it will be none, right? Now we need to assign head to this one. So L1 dot L dot sorry, self dot head is equal to n1. The self dot head will be n1. Now what about the next one? Okay, what about the next one? Create one more node. So here it will be pointing head. Now n2 is equal to node of 20. So one more node is created here with the 20, and by default it is a none because self.next is none. Now we have to point this address of this node to previous one. So we can write n1 dot next. So this is the data and this is the next. This is a n1, right? So n1 dot next, that means this part, is equal to, what is this one? n2, right? So we can write here itself, okay, n2. So automatically the link will be obtained here, and here none will be replaced with the address of this one. So let it be some 1200. So 1200 will be here, and immediately create a one more node. n3 is equal to node of 30. So again a node is created, because whenever you are creating the object, so n3 is an object for node class. So we are having two variables. So this will be calling for this one. So 30 will be pointing towards the data, and next will be none. So automatically 30 and none. So let it be 1300 is the address of this node n3. Now what we have to do? n3 address should be copied at n2 dot next. So this is data and this is next. So n2 dot next is equal to n3. So automatically none will be replaced with the address of this one. So automatically link will be established. So like this we can create the nodes. That means creating the linked list, right? So now, so this is the creation of a linked list, and now we have to display. How to display? So in order to display, we'll write one more function called a def display function of self, the first parameter self. Now what we have to do? We have to travel from first node to last node. So for that purpose, and we should not change the head, right? So we will give one temporary variable and we'll assign this head to that temporary variable, and we can travel this temporary variable throughout the all nodes, right? So temp is equal to self dot head. Temp is equal to, I will write here, def display of self, right? Now I will write some temp is equal to self dot head. Now how to travel? So if it is an empty list, we know that if self dot head is none, because if there is no another node, if it is having no nodes, so we have created with a none. So if self dot head is none, simply print empty. So we'll print empty. Otherwise we need to travel from the first node to last node, right? From the first node to last node. So for that purpose we are just assigning the head value to temporary. So while temp, that means it will be moving from first value to last value. So while temp, that means until it reaches to the last element, so we need to move temp is equal to temp dot next. So first, while temp means here the head, right? Here the temp value is 10. Temp is 10, so it is a true. Now temp is equal to temp dot next. Now temp dot next means 1200. So automatically it will be moving towards this one. Okay, again it will check for temp 20. again temp is equal to temp dot next. So again it will move here, again 30, temp is equal to temp dot next, it will move here. So there is no other node, right? It doesn't move there. So automatically temp dot next is none. So if temp is none, automatically the loop will be terminated. So for that, each and every iteration we are going to print temp dot data. So before moving to the next iteration, we'll print the data and then we'll go with the temp is equal to temp dot next. Automatically after printing 10, the temp value will be changed to next node. Okay, so like that we'll use the display function, right? So don't worry, I will execute the program. So still if you are having any doubts, you can the doubts can be clarified here. Okay, don't worry about that. So temp dot data, temp is equal to temp dot next. So this way we can create the list and we can display all the nodes of a single linked list, right? Hope you understood this one, how to create a node. So here we are not having the pointers concept, so we are creating a class node and we are giving some two variables for this one. So for every object of this node we are having some two variables, right? So if you create a node, two variables will be there, one is the data, another one is the next, that means address of the next one, right? So let's stop here. So let us execute the program, so that if you are still having any queries, so definitely all the queries will be clarified after watching the execution. So let's move on to the system. Hello friends, so just now we have seen the single linked list, that means how to create a node and how to insert the elements, right? So how to display the elements of a single linked list. Now I will execute the thing. So first of all, we'll create a node with two elements, that is a data and next, right? So every node will be having two elements, one is for data, another one is for storing the address of the next node. So for that we'll go with the class node. This is for node creation, right? So here we'll go with the constructor, so def underscore underscore init underscore underscore self, and also we'll go with the data. Okay, so we don't go with the next because for the first thing the next will be none, right? So here just initialize self data is equal to data and self dot next is equal to none, so no value. So because for the first node, if you are creating this linked list with one node, the data will be actual data, and the next one, that means self dot next, will be none. That means there is a no connection for the next node because it is having only one node. So next we'll create a one more class. So this is for node creation, right? So next one we'll create a class for single linked list, right? So here we'll define the head. Okay, so the same thing, so we'll go with the constructor in order to initialize the variables. So self, and go with the self dot head is equal to none. Initially we'll take none because after creating the node the head will be pointing to the first node, right? So for this, now we have created a node with the two elements, that is a data and a next, and single linked list. So initially that's an empty list. Now we'll write a one more definition for display. So in order to display the elements of a linked list, the nodes of a linked list, we'll go with the display. So self if self dot head is none. Self dot head is none. That means if this head is none, that implies linked list is empty. So linked list is empty. Right? Now we'll create a object for a single linked list. Okay, so I will go with L is equal to single linked list. So just I have created the object. Now before creating the node, so similar to this L, we have to create an object for node with the two data. Okay, with the data and the next one. Now before creating, we'll call this display function, so it should display empty linked list. If you execute this one, we'll get linked list is empty because we have created the node. That means we have just declared the node, and also we have initialized the head as none, so we are not creating any node. Now we'll create the node. So n is equal to node of 10. So first element I am giving as 10. Then see what about the, so here you can observe n dot data will be 10, right? N dot data will be 10. What about n dot next? So we are not having n dot next, right? So because it is having only a new node, this was no new node. Now consider this as a head because this is the first element. Now we have to initialize the head to this one. Head is equal to so linked list, empty linked list, L dot head is equal to n. Okay, L dot head is equal to n. Now you can observe L dot head is equal to n means the data part is 10 and the next part, so here the next means the address of next node. Okay, this is the address of next node. Address of next node. Okay, so this is the first node. Okay, this is the first node, so automatically the address of next node will be null. Then we'll create a one more node. N1 is equal to, or simply you can display, we'll get only one element. See, so let us create one more element. So N1 is equal to node of 20. Now what about the address of N1? That should be at n dot next. That means L dot head dot next. So you can observe here L dot head dot next will be n1. Okay, so the first node is 10. The first node is 10 and the second node is 20. So the address of 20 should be at this n dot next. So here n is initialized to L dot head. So that's why I have given L dot head dot next is equal to n1. So this is the next node. The address of next node will be linked to the first one. So just see. Now we need to display the elements. If it is a linked list if the linked list is empty, we are getting the linked list as empty. Now we are supposed to display the elements. So how to display the elements? For that we need to write. So else if the linked list is not empty, just go with the temporary, take some temporary variable which is assigned with a head, right? Now while temp, so unless it goes to the end value, it will be iterated. So print temp dot data, and just for representation I am giving some arrow mark, and for every second element it should be printed in the same line, so I am using some AND operator. Right? And immediately after displaying the data, just forward the temp is equal to temp dot next. Automatically it will move to the next one, right? Now if you execute this one, we'll get 10 20. The first node is a 10 and the second node is a 20. Okay, and if you go with the next one, see n2 is equal to node of 30. Now the address of n2 should be at n1 dot next. So n1 dot next
is equal to n2. Okay, and just execute, we'll get a 30. Right, so hope you understood this one. So if it is an empty list, so just create a node with the two elements, two variables, that is a data and next. So initially take the next as none, because for the first node it will be none, and create one more class with a linked list. So for all the elements, I mean inserting the elements that will be linked to this single linked list. So here also I am taking one parameter, that is a head as none. So default there are no elements or there are no nodes, so head will be pointing to nothing. So that's why I have given head as none. So while displaying that, I am writing a one more function called display. So while displaying, so if self.head is none, automatically we can say that linked list is empty. So I am displaying this one. Else if it is not empty, okay, then take one temporary variable and assign the self.head to temporary, because we have to traverse this temp from first element to the last element. Okay, so we should not change the head value. We should not change the head value. So that's why we are just keeping this head value as same, and we are assigning that head value to the temporary variable, and we are just iterating the temporary variable from the starting position to the last position. So and displaying each and every data, and after displaying the data, just we are changing the temporary value. Temp is equal to temp.next. So automatically it will move with the next element, because temp.next will be having the address of next node, right? So node of 10, so 10 will be taken here. So automatically the self.data will be data, that means a 10, and self.next will be none. And then immediately after creating the second one, we have to give the second node address to the first one, right? So that's why we have given some l.head.next is equal to n1, or simply you can go with a n.next. Okay, n.next is equal to next. That's also that's also common thing, right? So same, it will work same, n.next or l.head.next, right? So after creating the n2, we are creating the address of n2 in n1. So that's why n1.next is equal to n2. Immediately n2 value address will be stored in next. So display function, we have to call this with the help of this object, this class object. So we have created the L as a class object. So I am displaying this one, so that we are getting this one. And if you increase the node, n3 is equal to node of some 40, then immediately the n3 address should be at n2.next. n2.next is equal to n3. So if you execute this one again, we'll get a 40, right? So hope you understood this one, how to create the node and a single linked list, how to create the single linked list, and how to display the nodes of single linked list. Okay, so then our next session will be having the insertion. So we can insert the elements at the beginning, at the end, or at the specific position. How to create the linked list and how to display the nodes of a linked list. And in this session we'll see the insertion operation on linked list. That means how many ways we can insert. That means inserting at the beginning, and inserting the element at the end of the linked list, and inserting the element at the desired position, right? So let's start our session. Single linked list. So we'll take one data and then we'll start. So let us say this single linked list, there are only 3 nodes. So the first node will be the 10, 20 and a 30. So in the previous session we have seen we have created a class node which is with the 2 variables, one is a data and another one is a next, right? So first we'll see how to insert
insertion at beginning. So beginning means, so you can, here you can observe this is the head. This is the head. So if you want to insert that one, so first we'll write one definition. Okay, we'll write one definition and we'll take the element. So let it be some new node. New node will be some node of some data. So let us say take some data, and this data will be coming from the function call, right? So let us take this data, and after getting the data, automatically a node will be created here. So in the previous session we have seen, let it be some 5, and initially the next value will be none, right? Now we have to link this one to this one. That means we have to get the address of this one at this position. Okay, so for that purpose what we have to do, so this is a new node. For example, let us consider the shortening NB, new node at beginning. Okay, new node at beginning. So NB dot, right? So NB dot next is equal to, right, here self dot head. So this is the first step we have to do. So NB dot next means new dot next. So this is the thing, is equal to self dot head. What's the address of this one? 1100. So automatically there is a link, and immediately we have to change the head value, because the head is the value pointing to the first element. So automatically now the self dot head will be NB. So automatically this head will be removed here, and that will be associated here, assigned with this one. So let the thing is 1000, address of this one is 1000, right? So hope you understood. So first create one node. So automatically if you create a node, so we'll get the data and none. So a node will be created, and at this position what we have to get, the address of current first node. Okay, so before insertion of this new node, this is the first node. So this node address should be linked to the current node, that means a new node, because we are inserting the node at beginning. So this becomes the first one. So automatically how to get this location? So new node, that means NB dot next is equal to, this is the head position, previously this is the head. So self dot head, automatically the address will be goes to here, placed here. So immediately we need to change the head, because now this is not the head position, because this is the second element. So head should be pointing towards the first position, right? So automatically we are getting self dot head is equal to new node. Automatically head will be pointing towards here, right? A very simple method. So only 3 steps. Sorry, only 2 steps. This is the creation of node, and only 2 steps. We have to establish the connection and we have to change the head. That's it. And now we'll see how to insert the element insertion at end. Insertion at end. So here also, first of all, we need to get the data. That means we have to create a new node. So NE, that is a node at end. Okay, NE is equal to create some data. Some data. Let it be. So here also it will be called from the function call, right? So we'll write each function individually. We'll write a function and we'll call this function with the data, right? So let it be some 40. Immediately after executing this one, we'll get a node, and here we'll get 40, and here we'll get none. Let it be the position, the address is 1400. Address is 1400. Now this 1400 should be linked to the previous node. Okay, this 1400 should be linked to the previous node. So how to get this previous node? For getting this previous node, we need to travel from first element to the last element, because this is the linked list, right? So we have not established the connection from the last node to the new node. So this is the linked list. So we need to travel from first element to the last element. So in order to travel the first element to last element, and one more thing we need to remember is we should not change the head position. We should not change the head position. So I will take some temporary variable and I will store this head here, so that I can change the temp value from the first position to the last position. Okay, I can change the temp value from the first position to the last position. For that purpose, I will go with while loop, while temp dot next. So unless the temp dot next will become none, it will be rotating. That means iterations, right? So I need to change travel. That means temp is equal to temp dot next. See, first temp dot next. So initially the temp value is here. So first temp dot next. Temp dot next is 1100. That is a non-zero. Non-zero means a true. So it will enter into this loop. Temp is equal to temp dot next. So now temp value will be pointing towards here. Temp dot next. Okay. Now temp value is 1200. It's again non-zero. Again this will be moving here in the second iteration. Okay. In the third iteration, it will be moving here because it is again non-zero. Right? Again here, it is a non-zero. Now, temp dot next is none. Here the temp dot next is none. So automatically the control will exit from the loop. It will come out from the loop. So after coming to the loop, now we can write temp dot next, because the temp is at the last position, last node. Temp is pointing towards the last node. Now temp dot next is none, which should be having the position of the new node, that is NE. So automatically the NE address will be stored into temp dot next. So here none will be replaced with 1400. So a link will be established here. Right? So once again I'm saying, so first we need to get the data for the new node, which is to be inserted at the end. So after executing this statement, one node will be created with the data 40 and the next value none. Now we need to travel from first position to the last position. Here in the existing linked list, so after executing this one, we have no connection between the last, that means a new element with the existing element, right? So we need to establish the connection. For establish the connection itself, we need to travel from first element to the last element. So, and one more thing we need to remember is we should not change the head value. So for that purpose, I am taking some temporary value and I am assigning some head to temporary. So I am just keep on iterating the temporary. So while temp dot next, so temp dot next means 1100. So it is a non-zero. If it is non-zero, automatically it will enter into the loop and the temp will be changed to the next. So it will change to the next node. So this will happen till it reaches to the last element. So whenever it reaches to the last element, now you can observe temp dot next is none here. So before establishing the connection, the temp of last element will be the none. So automatically the control will come out from the loop. So now temp dot next will be the current node. That means new node which is to be inserted at the end. So automatically the 1400 address will be stored in the 30 dot next. This and the last element dot next. Okay. So hope you understood this one. So I will execute the program, don't worry. So this is a simple thing. So how can we insert the data? How can we insert the data at the end? Right? Now we'll see the last one, that is how can we insert the node at desired position, at the desired position. Right? Now here also we'll take one position. Okay. So here one thing to be remembered is, I will write here itself, position. Position is index. Consider position as an index and the index starts from 0. Okay, index starts from 0. Now we need to send the data. Okay, so let the index values are 0, 1, 2, 3 and 4. These are the index values, right? Now I need to insert some 25 at index 3. Okay, I need to insert the 25, node 25 at index 3. Index 3 is here, right? Now let us take, so NP, that means a new node at position, is equal to, take the node, some, let it be 25, that is a data. Okay, that is a 25. Now 25 should be placed here. So before placing here, so if you place here after, see, so I will write the index values here, 0, 1, 2, 3 and 4. Now after executing this statement, a node is created here. A node is created here with a 25 and with a none. So this is np.data and this is np.next. Okay, it's clear now. I think it's clear. So after executing this one, 25 and none is created. Now we need to change the links. So here instead of 1300, so let it be some 1250. 1250 should be pointing here and this 1300 should be pointing here, because this connection should be like this. Okay, so this is the connection, right? This is the connection. So in the place of 1300 we should get a 1250 and in place of none we have to get the 1300, right? Now, so after this one, just we need to travel, again we need to travel from 0 to position -1, because we need to change the next value, right? So temp is equal to self.head. So here also we should not change the head position. So we need to place the head as it is and we go with the temporary variable, and this temporary variable will be keep on moving from 0 to position -1. Now I will change that for I in range of position -1. Position -1. What we have to do? We have to keep on moving. So temp is equal to temp.next. See, for first iteration I is equal to 0. I is equal to 0. So I is equal to 0 means index. So temp is equal to temp.next. So here head, here itself a temp. Okay, after executing this statement, the temp will be also pointing towards the first element. Temp is equal to temp.next. So temp is equal to temp.next means this one. After first iteration, the temp will be moving towards the first index. Again, see here the position is 3. So range of 2, because position -1. So that means 0, 1. So the last index, it should be excluded. 0 we have changed it to here, and whenever I is equal to 1, again temp is equal to temp.next. So now again the temp become here, right? So next I becomes 2. So here range of 2, position -1, range of 2. So stop. So it will come out from the loop. It will come out from the loop. Now what we have to do? So np.data is equal to data. So we need to give the data. So here the data means 25, right? So np.data is equal to 25 and np.next is equal to np.next is equal to temp.next, because here instead of none we should get a 1300, right? Instead of none we have to get the 1300 here, right? So now temp is pointing towards position -1. So for temp.next should be assigned to new node. So here it will get a 1300. Now what about this one? This address should be get. Okay. Now temp.next is equal to, what is this node? NP. So this is a NP, right? So NP should be here. that is a 1250, right? So temp is equal to self dot head. So we have to travel from first node to the last node. So for that purpose, so we should not change the head. So that's why we are taking some temporary variable, and we are just traveling from 0th position to position -1, because at that position we have to insert the 25 at that position. So you just remove this link, because 1250 means it will be pointing towards here, and 1300 means this node will be pointing towards here. So there is no link between this 20 and 30, right? So np dot data, so whenever the temp reaches to the position -1, now np dot data is equal to data, that means a 25. Np dot next, in this position what should be there? So this value, okay? So you should not interchange these two statements, because if you interchange these two statements, the link will not be established. So before disconnecting the link, we should copy the address of the next node to the new node. So that's why np.next is equal to temp.next. After that, we can change the temp.next to the new node address, right? So hope you understood this one. So this is a simple process to change the position, right? So insertion at position. Insertion at position. So this is the logic for insertion at position. So I will execute the program implementing all these three. So that means inserting at the beginning, inserting at the ending, and inserting at the desired position, right? So let's move on to the system. So if you are still having any queries, your doubts will be clarified, right? So let's see the execution. Hello friends. So just now we have seen how to insert the elements into the linked list. That means insertion can be possible at the beginning, insertion at the end, and insertion at the specific position. So we'll see the program for insertion. So let us start with the first. We'll create a few elements into the linked list, and then we'll see. So already in the previous session we have created this one. So we have created the code. That means we have created the node, and then we have created one class for single linked list and the display function in order to display the thing. And also we have created an object for single linked list, and we are just creating the nodes, so different values, right? So just I will copy this one so that the time will be saved. See, so till now we have executed this one. So there are some 4 elements here. Okay, so we'll see, we'll see one more element. So n4 is equal to some node of 50, and this address should be placed at n3.next is equal to n4, right? So we'll get a 50. So total 5 elements are there. Now we'll see the functions. So each and everything is a function, right? So we'll create a first function by inserting at the beginning, right? So here we'll write this one. So define, and I will go with the function insert underscore beginning, right? So here we'll go with the self. The first parameter will be the self, and the next one is the data. So which data should be inserted, right? That will be passed from the function itself. We'll pass from the function. Now we'll create we'll take the small variables. NB is a node, a new node. So here we'll go with the data. So data is created for the new node, and that data should be inserted at the beginning. So if the data is to be inserted at the beginning, the head will be changed. Okay, the head will be changed, and this will become the second node. That means the address of this existing node should be assigned to this new node.next, right? So let us take here nb.next is equal to, what is the current node here? This is the head. This is a head. So self.head, self.head, right? Now what is the head now?
after inserting the first element, what is the head now? The first element will be the head. So change it to here. So self dot head is equal to NB. Hope you understood this one. Insertion at the beginning. So I am taking the value here. Okay. So L dot insert underscore beginning of, I just want to add 5. So if I add a 5, this 5 will placed at here. So automatically the 5 we are passing as a parameter, so that will be stored in data, and this data will be giving as a parameter to the node object. So that means NB, that means a new node will be having the data 5. Now see, if it is a 5, automatically we need to change the head, because previously this is the first element, so head is pointing towards 10. Now I have to change the head to 5. That means nb.next is equal to self.head. So whatever the value pointing towards the head, that will be pointing in the new node.next. Now after inserting 5 will be the first node, so we need to change the head also. So that's why self.head is equal to the new node, right? So now just execute this one, you can get right. See, 5 is inserted here, and again go with one more thing, insert underscore beginning of 3, and execute. 3 will be pointing here, right? So automatically first the element should be changed, the present or a current first value address should be placed at the new value next, and the new value must be the head position, only 2 points, right? So this is how we can insert the value at the beginning. Now we will see how can we insert the value at the end. Okay, see, for that we will write the function insert, and the same thing, self and data, will pass the data from the function call. So NE means node at end, node data, this is common. Now what we have to do, so whatever the data we are passing as a parameter, that should be placed here. So now head is at this position. Now the head should be, we have to traverse towards the last one. So that means you can observe, we'll take some temporary value, because the head should not be changed. Okay, we have to travel from the first node to last node. So even though the head should not be changed, the head should be pointing towards the first node. That's why I am taking some temporary value as self.head, right? After taking self.head, so we need to travel from first node to last node. For that I will go with the while temp.next. So for the last node, right, for the last node, temp.next will be none. Okay, so for 40 the temp.next will be the address of 50. For 30 the temp.next will be address of 40. For 20 the temp.next will be address of 30. But for 50 the temp.next will be none. So until it reaches the last element, we need to travel. That means change the temp is equal to temp.next. So for the first iteration, the temp.next will be 5, second iteration 10, third iteration 20, fourth iteration 30, fifth iteration 40, and the sixth iteration 50. And it will come out from the loop, because here the temp.next will be none. So immediately now the position, what is the position here? So temp.next is the last one. Now at that position we need to insert the element. So come out from the loop. So directly go with the temp.next is equal to NE. NE means address of the new node. Address of new node. So automatically the new node will be inserted. So you can observe here after beginning. So L dot insert underscore and we'll go with the 60, right? So execute this one, so we'll get a 60 here. So first the node will be, see, first we are taking the new node and we are taking this temporary variable. So self.head is assigned to temporary variable, so that we need to travel from first node to last node. For that we are writing some while. So while temp dot next, that means unless it reaches to temp dot next, that means a none value, it will be traveling from first index. We are changing the temp is equal to temp dot next in for every iteration. So after completion of this loop, the temp value will be pointing towards this 50 because the 50 temp dot next is empty. So at that point, we are just placing the new value to temp dot next. Automatically we'll get the result. Right? So again, L dot insert underscore end of 70. You'll get a 70, right? So these are the elements now. Right? Hope you understood this insertion at the beginning and insertion at end. Right? Now we'll go with the third one, that is how to insert the element at the desired position. So we need to give the position, and at that position the node should be defined, inserted, right? So we'll go with the same thing. So insert underscore position, here give the self and give the position index value, in which index you have to insert the thing. So let it be, for example, the index value of this one is 0, 1, 2, 3. So here you give the index value where we have to insert the position. So I just want to insert the value at 0, 1, 2, 3, 4, right? So fourth index, I just want to see 0, 1, 2, 3, 4. I just want to give that 25. 25 is the data. Okay, sorry, we have to give position and data, right? Position and data, right? So at the function call we'll write this one. So L dot insert underscore position, what is the thing, 4 comma 25 at the fourth index. Okay, I'm not taking about the position, right? Fourth index, I'm going to insert 25. For that purpose it will call here. So automatically the 4 will be pointing towards this position and 25 will be pointing towards this data. Now take the new node n position, np, that means a new node at a position is equal to node of data. And also we need to travel from first node to that particular position, less than that particular position. So again the same thing, use the temporary variable to store the self dot head. Now we can travel the temp value. So we know the number of iterations, right? So then we'll go with the for loop. For I in range position -1. So until third position we need to travel, because we need to insert the position at fourth one. So we need to travel up to third. So 0, 1, 2, 3 here. So after, for that purpose I am going with the position this one. So just go with the traversal. So temp is equal to temp dot next, temp dot next. So after completion of this loop, the pointer, the temp will be at this position. Now at the next of this 20 should be the address of new node. Okay, now you can observe here. So np dot data is equal to data, and np dot next. Okay, np dot next means the new node dot next should be this one. Okay, that means the temp dot next. Hope you understood this one. So now the temporary value will be here. The temp dot next is at 30. That should be placed at new node. So new node dot next is equal to temp dot next. And now the temp dot next, right? Now the temp dot next must be the new element. Temp dot next must be the new element. So if you first give the temp dot next is equal to new element, then it is not possible to link this 30 value, that means address of this 30 element, right? So that's why we need to follow the same order. First we are just giving the data, and in the next we are getting temp dot next is saved at np dot next. Now the temp dot next will be the np value, the new value, right? So now see, let us see 425. I will execute this one. So let us decrease the size so that, see, you can observe here. So np dot next, right? So fourth position 25. Just execute this one. we'll get, see, 3, 5, 10, 20 and 25. Okay, and now 0, 1, 2, 3, 4 and 5. Fifth position and sixth position I need to insert the element. So L dot insert underscore position sixth index with a 35. Execute. You'll get this one: 3, 5, 10, 20, 25, 30, 35, 40, 50, 60 and 70. So here once again I'm saying, don't get confused. Position means not the position. Position is here. I am considering the position as an index value, whether if you consider the index value from 0. Okay, we'll give the position, that means index value and the value, right? So hope you understood this one. So insertion at the beginning, insertion at the end, insertion at the particular position and at the specific position. And in today's session we'll discuss about the delete operation. So how can we delete the element from the beginning, end and the specific position for the single linked list. So in the previous session we have seen how to create the single linked list. So directly I will draw the diagram. So let us take a few nodes and then we'll write the code. Okay, so after this session, that means after this theoretical session, I will show you the demonstration of all these three concepts, that means deleting at the end, beginning and position, right? So let us take 5 nodes, right? So this is the linked list with the 5 nodes. So let it be 10, 20, 30, 40 and 50, and the address is some 1000, 1100, 1200, 1300, 1400, right? And this 1100 should be here and this 1200 should be here, because this is the link of next node, right? So this 1300 should be here and this 1400 should be here, and finally the last element will be none. So for this purpose we have created 2 different classes. One is a node and another one is for linked list, right? So after creating this one, now how to delete this one, how to delete the element. So this is the head, okay, self dot head. This is pointing towards the first element. Now deletion at beginning, deletion at beginning, right? So in this beginning, deletion in the beginning, that means we have to delete this node. So in order to delete this node, if you disconnect the link between these 2 nodes, automatically the element will be removed, right? So here we are not having any free function, which we have discussed in the C programming, right? So in C programming we are supposed to use a dynamic memory allocation for this linked list and we have to free the element, right? So here we are not having any free functions. So directly we can remove the link between the first node and the last node, and we need to change the head to second node. We need to change the head to second node. For this purpose, what we have to do, and see, go here, temp is equal to self dot head. Temp is equal to self dot head. So automatically the temp will be here, right? Now self dot head is equal to temp dot next. So temp dot next means 1100. Okay, temp dot next means 1100, and at that particular 1100 is assigned to self dot head. So automatically now this self dot head will be assigned to here, self dot head. Now what we have to do, we have to make this as none. So we need to disconnect the link. So just we are moving the head to second position, because after deleting the first element, the second element will be the head, right? So temp dot next is equal to none.
So obviously this 1100 will be removed here and it will be assigned to none, so that automatically the link will be disconnected. So now the self.head is pointing towards 20 and the elements after deleting the first element is 20, 30, 40, 50. This is a simple procedure. So if you draw the diagram, then it would be very easy to write these steps. Okay, just we are moving the head value to the second value, because after deleting the first value, the second value will be the head. So we are just removing the head and just that is assigned to some temporary variable, because we need to disconnect the link. So temp.next is equal to none. That's it. Right? So hope you understood this one. So deletion at beginning. It's a very simple. Right? Now we will see deletion at end. Deletion at end. So let us change it. So this will be the self.head and this is the link, and instead of none there must be the link 1100. Right? Now we need to delete the last element, that means this element. Right? So in order to delete this element, we need to travel from first element to this element. Okay, this element, and we need to change this element as none. We need to change this element as none. So just initialize some temporary variable to head so that we can travel by using the temporary variable. So automatically temp will be at the top position. Now while just a second, yeah, no, while temp.next is not none. So unless it becomes not none, we need to move the temp value to the last. So temp is equal to temp.next. So obviously now for first iteration it will check for temp.next. So 1100, it is not none. So automatically temp is equal to temp.next. Now the temporary variable will move towards here. Okay. Now again, this is the temp. In the second iteration again temp.next is not none. Right. So again change the temp value. Temp is equal to temp.next. Now temp value will be 1200. So obviously it will point in towards here. Right. It will point towards here. Now again temp.next is 1300, it's not none. So again change temp to temp.next. Again temp will be moved towards here. Again not none, it will be moved towards here. Right? Now we need to change the link, that means disconnect the link. We need to change this value. So how to get this temporary back? So that's not possible. So that's why we can create one more variable called previous is equal to self.head. Okay. So automatically this is the previous. This will again refer to previous. And instead of taking temp value, okay, as a self.head, I will go with the self.head.next. Self.head.next. Automatically the temp value will be, temp value will be self.head.next, it means 1100. So this will be the temp value. So I am initializing self.head as a previous, self.head.next as the second element. That means that second elements are temp. So automatically whenever the temp.next is not none, just move the temp value as well as the previous value. So previous also just move previous dot next. So automatically for the first iteration temp will be moving towards here and previous will be moving towards here. Right? So in the second iteration temp will be moving towards here and previous will be moving towards here. And in the third iteration the temp will be moving towards here and the previous will be moving towards here. So automatically the loop will be terminated, because here the temp dot next will be none.
So automatically it will be terminated. Now you can simply use this one to make this link as a none. That means in order to disconnect the link. So what is this value? That is nothing but, so come out from the loop. So previous dot next. So previous is pointing towards 1300. So previous dot next means 1400. Make that value as a none. So automatically this 1400 will be replaced with none, so that the link will be disconnected here. So automatically the 50 will be deleted. The 50 will be deleted. So we are, in our linked list we are having only 4 elements, 10, 20, 30, 40. Right? So hope you understood. In order to get the previous element, in order to disconnect the last and last but one element, we are just initializing one more variable called previous, and we are just traveling from both the temp and previous for each and every iteration. Right? The head value is assigned to previous and head dot next. That means the next value is assigned to the temporary variable. So whenever the temp reaches to last two element, previous will be reaching towards the last but one element. So like that we can change the, we can delete the last element. Okay, so hope you understood this one. Right, next we'll move on with the third one, that is deleting the element at particular position. Right, that's also very simple. The same concept will be done. The same concept. See, I will tell you. Specified position, let it be position. Right, now again the same thing, we need to travel from first element to that particular position, and position but one element should be the link of position previous element should be kept as none, so that the two elements will be disconnected. For example, if you want to delete the third element, the temporary variable will be moving towards this one, and we need to make this element as the value of this one. That means the address of this one should be placed at this place. Okay, so for this purpose also we are just taking temporary as self dot next. So this will be the temp, and previous is equal to self dot head. So this will be the previous. Okay, and next, instead of using the while, I will just move the for loop, because we know the position for I in range of 1 to position minus 1, from 1 to position minus 1. So if position is 3, so the range will be from 1 to position minus 1, 2, 1 to 2. Right? That means, see, for the first iteration, the temp will be self dot next. So when I is equal to 1, so temp is equal to temp dot next. Temp is equal to temp dot next means 1200. So temp now pointing towards 1200. Right? Again, previous is equal to previous dot next. So previous is equal to previous dot next means previous will be assigned to 1100. So here it will be pointing previous. Right? Now again I value becomes 2. Automatically we need to stop here. So just stop here. Now what we have to do? So just we need to remove this element, this node. Okay, we need to remove this node. For removing this node, just disconnect the link between these two. So automatically previous dot next is equal to, and link the next one. So how to get this one? Temp dot next. So 1300 is the address of this node, right? That 1300 should be placed at this position. Instead of 1200, we need to place this one. So I will go with the temp dot next. The code is same, right? So automatically when you assign this one, instead of 1200, we'll get the 1300. Okay, automatically this link will be disconnected. Right? And this link will be established to here, and we need to remove this one. So obviously temp dot next is equal to none. So automatically this link is also removed. So it will be none. So the link will also be removed. Right? So simple steps. So if it is 3, if it is 4, fourth element, in order to remove the fourth element, the temp should be traveled towards 40 and the previous should be traveled towards 30. So automatically the previous next is equal to temp dot next and disconnect the link. Right? So hope you understood this deletion process. So we have seen the 3 things. So how we can delete the element from the starting position, and how we can delete the element from the ending position, and how we can delete the element from the specified position. So we need to give the position, and from that position the element should be deleted. So very simple thing, and for all the data structure problems, just draw the diagram so that definitely you can easily grasp the concept. You can easily write the code. Right? Yeah. Now let us move on to the interpreter, and I will execute all these 3 cases. That means how can we delete from the starting, ending and specified position. Right? So let's move on to the system.
Hello friends. So just now we have seen how can we delete the element in the linked list. That means deletion can be done at the beginning, deletion can be done at the end, or we can specify the position so that the deletion can be done at that particular position. Now let's write a program to demonstrate all these 3 cases. That means deletion at end, start and specified position. So for that, just we'll create a linked list with a few elements and then we'll perform this delete operation. So already in the previous session we have seen how to create the single linked list. So I will repeat that one. So first of all, we need to create a class node with the 2 variables, that is data and next. So I will define the constructor init, okay, and inside that I will go with the self comma data, and which the data will be assigned to self dot data is equal to data, and self dot next is equal to none. So initially there will be no value assigned. Then we'll go with the again we'll go with another class in order to create the linked list. So I will go with the class SLL, right? So here again I will go with the constructor, so init, and I will go with the self, and here I will initialize the head with a none. So initially there will be no element, so none will be there. And now I define display function. So in order to display the elements, go with the display function. And now if self dot head is none, automatically we can say that so empty single linked list, otherwise else. So if else, just loop the thing while temp, okay, print temp dot data, right, and use the arrow marks for representation, and end is equal to, so everything will be displayed in the single line. So next you change the temp value, temp is equal to temp is equal to temp dot next, right? So now we'll create a node. So I will go with a linked list. L is equal to SLL. So L is an object, and now I will create a node. N1 is equal to node of 10, and see n self dot head is equal to n1, right? N1 will be the head. Now create n2 is equal to node of 20, and then n1 dot next is equal to n2. Similarly, n3 is equal to node of 30, and n2 dot next is equal to n3, because the previous node, the next node link will be given to the present node next, right? So let us stop here, and I will go with the display function. So whether it is displaying correct or not, we'll execute this one. So we got some error.
L dot head, sorry, local variable temp reference before assignment. So yeah, temp is equal to self dot head. We can observe 10, 20, 30, and also we can go with the two more elements. So then next we will go with the deletion operation, and 4 is equal to node of 40, and n3 dot next is equal to n4. Similarly, n5 is equal to node of 50, n4 dot next is equal to n5. So if you execute that, so our so I have created the linked list. I have created the linked list, and I am displaying the values. So for that we are getting some 5 values. Now we will write the code for deleting the element from the beginning. So define delete underscore beginning of cell. So here we are not passing any argument here, just we are deleting the element. So if you delete the element, automatically the temp value, just assign the temp to self dot head, so that next, now the new element, so the first element has been deleted, right? So this is the first element, the first element had been deleted, and now the head element will be this one, the head element will be this one. So what is the reference of this one? This is nothing but temp dot next, right? So temp dot next, because temp is head, so temp dot next. So self dot head is equal to temp dot next, right? And now temp dot next must be none, so that, so initially the temp is nothing but the first element dot next, that means we are disconnecting the link, right? So now you can observe L dot delete underscore beginning, right? So hope you understood. We are changing the head position, right? We are changing the head position, and then we are just linking the second head, okay, second element, and we are disconnecting the link from first element to second element, because we are deleting the first element. So just execute this one. You can observe 10 will be deleted. Yeah, see, now 20 will be the starting node, 20 will be the starting node, right? So hope you understood this one. Then so I will just keep hash here, so I will execute. So now 10, 20, 30, 40, 50. Now we will see the code for deleting the element from the end. Okay, see, for this purpose, delete underscore end, here also we give the self parameter only, and now just go with the temp is equal to, sorry, so here we need to travel from first element to the last element, and last element should be deleted. So for that purpose we have to go, that means last but one element next value should be none. Okay, the last but one element next value should be none. Now for that purpose I will go with the previous is equal to self dot next, and temporary variable is equal to self dot, sorry, here not next, it's a head, and this is self dot head dot next. That means the first element is assigned to previous, okay, the first element is assigned to previous, and second element is assigned to temp is assigned to self dot head dot next. So self dot head is this one, dot next means this one. So previous is 10, temp is 20. Now just travel from first element to the last element. For that one purpose, so while temp dot next is not none, so unless it becomes a none, we need to travel both the elements. So temp is equal to temp dot next. Similarly, previous is equal to previous dot next. So at the end of the loop, if the pointer reaches the last element, so automatically the last element next will be none. So automatically temp will be the last element, previous will be the 40, right?
temp will be the last element, previous will be the 40. Now we need to disconnect the link between 40 and 50. That means previous dot next must be none automatically. So this is a previous, right? This is a previous and this is a 50, temp. So we need to disconnect the previous dot next. So automatically after coming out from the loop, previous dot next is equal to none. Automatically the link will be disconnected. Now let us execute the program. You will be getting an idea. See, L dot delete underscore end, right? So you can observe the elements are 10, 20, 30, 40, 50. Now I have kept the comment for delete underscore beginning, so nothing will be executed. And here coming to the next statement, that is a delete underscore end, the 50 should be deleted. Just execute the thing, automatically the 50 will be deleted, right? So we are taking two variables. One is for traveling from first element to last element, and the second variable is to travel from first element to last but one, right? Hope you understood this one, right? Next, the next one is deleting the element at the position. So we need to give the position so that the element at that particular position will be deleted. For this purpose, we'll go with the self and position, two parameters. Now again, just assign the same thing here. Previous is equal to self dot head. So this is for traveling. So temp is equal to self dot head dot next, right? So if the position is 2, or if the position is 3, here the 30 should be deleted. So just I will go with this one and execute. So there are 5 elements now again. Now if I want to delete the 30, we need to travel from 10 to 30, and we need to disconnect the connection between 20 and 30, and we have to establish the connection between 20 and 40. So for this purpose, again we'll go take the previous as a head and the temp as second element. Now we need to travel from first to a position. So for I in range of 1 to position minus 1, right? So travel the temp is equal to temp dot next. Obviously previous is equal to previous dot next, right? Now simply give previous dot next is equal to, so automatically if you give 3, right, so it will move up to 20, right, and it will be deleted, and now the link will be established from previous dot next is equal to, that means 20 to next is equal to temp dot next. Here temp is 30 now, right? So after executing this for loop, the temp will be moving towards the 30, right? And next previous will be moving towards 20. Now previous dot next is equal to temp dot next. So temp is 30, temp dot next means the link of 40. So here we can go with the temp dot next, right? So hope you understood this one. So in this case we are taking two variables, one is for temporary, another one is for previous, in order to travel to that particular point, and in order to disconnect the link we need to use the second variable, that is a previous, right? So if you execute this one, so just call the function L dot delete underscore position of 3. If you execute this one, sorry, we got some error. Let us check. Position is not defined. Position, yeah. Self dot next. Just a second. I'll give you. Sorry, here we have given the wrong indentation. For that purpose we are getting some error, right? Now you can observe here.
See, the third element has been deleted. So if you keep the comment here, if you execute, this is our linked list 10, 20, 30, 40, 50, and if you delete the position 3, that means 1, 2, 3, right? 1, 2, 3. So if you are not giving here 1, we can consider as a index values. We can consider as a index values, right? So here I am considering from 1, so 1, 2 and a 3. That means 30 will be deleted. So if you execute this one, 30 will be deleted. If you execute some 4, 40 will be deleted, 10, 20, 30, 50. And if you execute 2, 20 will be deleted, 10, 30, 40, 50. Right? So hope you understood this one. So deleting from the beginning, deleting from the end, and deleting from the position. So just to draw the diagram on a paper so that these points, that means these steps will be easily understand, right? So it will be very easy to trace this one, as I have mentioned in the whiteboard. So if you draw the elements, and that would be very easy to grasp the concept, particularly in the data structure.
Hello friends, welcome back to our session. So in today's session we'll see about the double linked list. So how can we create the double linked list and how can we display the nodes of a double linked list. So in the further sessions we'll cover about the insertion and deletion concept. So let's start the session about a double linked list. So in the previous session we have covered about the single linked list where every node will be having two fields, one is data and another one is a reference to the next node. But here in the name itself indicates as a double linked list, every node will be having two links, one is for the previous node and one is for the next node. So if you consider a node, so let us consider this as a node. Okay, so it will be having three fields. This is the actual data. This is the actual data, and this is the previous, which is a link to previous node. Previous node, the address of previous node, and this is the next, and this is the next. That is next node address. The address of next node. Okay, so here it refers the address of previous node, and this is the address of next node. So every node will be having these three fields. So we have to create a node with three default parameters, right? So with three variables. One is for data, another one is for previous, another one is for next. So if it is a first node, automatically there will be a data and the previous is none because there is no previous node, and here it is a none, which is the next is also a none, right? So this is the first one, first node. If it is a second node, if you insert one more node, for example, let it be some 10, right? So n1 is a 10. So this is the first node, so there will be no reference to the previous node and there is no reference to the next node. So that's why we have kept as a none. So previous and next as a none. And if you consider, if you create one more node, that is n2, so here what? The 20 is the data. Now 20 is the data, is a second node, and this node previous should be address of n1. Okay, this node address should be previous, this previous should be address of previous node. So what is the address of previous node? Let it be some 1000, and here we need to give the 1000 here. And here in the first node, the next reference to be n2, let it be some 1100. So 1100 should be placed here, right? That means n2 dot previous should be n1 and n1 dot next should be n2. n1 dot next should be n2. n2 dot previous should be n1, and this will be automatically none. This will be automatically none. If you insert the third node, then the third node address should be placed here. So that's why n2 dot next will be n3, and n3 dot previous is equal to n2. So like this we have to create the multiple nodes, right? So let's see. I will give you a small overview and then we'll move with the program. I will demonstrate the program. First we need to create a node. So in order to create a node, we will go with a class node. So similar to our single linked list. So here I am just defining three variables. I am initializing three variables. So I am writing some constructor here. So init, so self and data, right? And so self dot data will be data and self dot next will be none. So initially self dot previous is equal to none. So this is the creation of node. This is a creation of node. If you create an object for this class, automatically the data will be placed in self dot data and the remaining will be none. And then we need to give the links, right? So after this one, we need to create one double linked list so that we have to insert the data into that particular double linked list. So for that purpose, I will go with one more class called class DLL, and here I will give the instructor. So init, and I will initialize the head. So we know that head is a pointer pointing towards the first node. So head will always point to the first node. Now here initially it will be none because there are no elements. So that's why I have placed here none. Right? Now as I have said that if you create n1, so this is the object creation for node. For example, it's 10. Now n1 is 10. Automatically this will be created. So a node will be created here. I will erase this one. I will just give the heading, right? So a node will be created with a 10, and here it is none, and here it is none, because we have already seen the class of node, right? So we have defined the data, this parameter to the data, and the previous and next will be initialized to none. So this, after executing this statement, a node will be created like this. Then this is the first node. Okay, this is the first node. So we need to initialize it. L dot, so L will be the object for double linked list. So L dot head is equal to n1. So automatically it will be pointing as head, right? Next, if you create n2 is equal to node 20. So one more node is created here. So obviously it will be 20, and it is none, and it is none based upon the class node. Okay, now we need to link here. So how to link? So the address of this one, the address of second node should be placed at head.next, right? So here n1.next is equal to, that means this position is equal to, this is n2, right? So this is n2 and this is n1. So n2 automatically, immediately it replaces none with some 1100, and next here in this position, okay, a link is established. Again a previous, okay, here for node 2 the previous should be linked to the previous node. That's why n2.previous, so obviously this is a n2.previous, and this is n2.next. So n2.previous is equal to, what address should be here? n1 address should be here. So n1. So automatically none will be replaced with, so let it be, the address is 1000, so 1000 will be placed here. Automatically one more link is established here, right? So this is called a double linked list. So every node will be having the link to previous node and the next node. And again, if you create n3 is equal to node of 30. So one more node will be created here. See, one more node will be created here, so 30, and this is none, and also this is none. Right, now we need to establish the connection between this second node and the third node. So this is n3. Now n2 dot next, so this should not be none, right? This should not be none. So n3 dot next is equal to, sorry, n2 dot next. n2 dot next is equal to n3. Automatically none will be replaced with the address of node, that let it be some 1200. So automatically a link is established to here. And now n3 dot previous, it should be n2. So there must be a link between n3 and n2. So this will be replaced with 1100, and automatically it will be none. Right? So this is how we can create the double linked list. Okay. Now how to display it? So in order to display it, first we'll see whether the double linked list is empty or not. So how to know that? So if self.head, because immediately after inserting one node, we are assigning the head to that particular first node. So self.head is none. Automatically we can say empty double linked list. Else, if it is not none, that means there are some nodes. So just in order to travel from the first node to the last node, just assign the head to some temporary variable. So because we should not move the head, right? Self.head. Now we can move the temporary. So while temp, that means unless the temp is having the value, the loop will be repeated, right? So what we have to do, just we need to print temp.data. Okay, so just for representation I am taking all these parts, right? Temp.data, and immediately after displaying that, we need to move the temp to next one. So temp is equal to temp.next. So automatically first it will be displayed, and immediately temp.next means it will move to the 1100, this position. So again it will check for the value. So yes, it is having the value, so this value will be displayed, and again temp is equal to temp.next. So here temp.next is 1200, it will be moving here. So again here 30 is a value, 30 will be displayed, again temp is equal to temp.next. So here none. So automatically here none means, so this condition fails, a temp is not having the value, that means false. So automatically it will come out from the loop and it will display as 10, 20 and 30, right? So complete, you keep all these things in the function called display function, right? Inside the display function we can write all these code, right? So hope you understood this one, double linked list. So creation of double linked list and display the nodes of a double linked list. So here every node will be having three fields. One is a data, one is a reference to the previous node, another one is a reference to the next node, right? So in order to display, we need to check whether the double linked list is empty. Otherwise we need to travel from the first node to the last node by using some simple while loop, right? So hope you understood this one. So let us demonstrate these two functions, that means a create and display, by executing a small program. So let's move on to the system. Hello friends. So just now we have seen about the double linked list. So how can we create the nodes and how can we display the nodes of a double linked list. So in the previous session we have seen about the single linked list. The similar way we will create a node, but here we are having an extra variable called previous. So because it is a double linked list, every node will be having the previous link and the next link, right? So let's demonstrate the create and display. So first of all, create a node. So in this node I will go with the constructor. So in this constructor I am defining the three parameters, so three variables, right? So one is self.data, obviously. The second one is self.previous. So for every node there will be
three different fields: previous, data, and next. So previous is the address of the previous node, and next will having the address of the next node. So initially I will go with a none for previous and also next for none, right? Now I will create one more class for double linked list, and here I am creating one constructor. So for head, so self, so here I am taking some self dot head is equal to none. So initially there is no elements, so there is no nodes, so that's why none. If you insert any node, the self dot head will be pointing towards the first element, right? Now we will create the linked list object for double linked list, right? Now we will write the display function. We'll write the display function in order to display all the nodes, right? So display, and if self dot head is none, that implies it's an empty double linked list. Empty double linked list, right? So here you have done here, and if you call this display function we'll get empty double linked list because we are not creating any node, right? And now after that I will create one node, n1 is equal to node of 10, and this should be initialized to head, right? So self dot head is equal to n1, and obviously n1 dot previous, because this is the first element, n1 dot previous must be empty, and n2 dot previous and n1 dot next should also be none. So just we'll display the thing. So here we have to write the else part, because now self dot head is not a none, right? Self dot head is not none. Now just take the temp variable and assign the head to temp, so that we need to travel the temp from first element to the last element, that means first node to last node. So just while temp, so this loop ends whenever the temp becomes none, okay? So unless the temp is having the value, automatically it will be moving on. So just print the data. So we are having some temp dot data, and give the representation, and also display each and every node in the single line, and move the temp to the next one, temp dot next, right? So sorry, here it is a L is a linked list, right? So L dot N. So only one element is displayed here. Hope you understood this one. Only one element is inserted, so one element has been displayed. Now if you go with the second element, n2 is equal to node of 20, and then so now node 2 is there, n2 dot previous must be n1, and n1 dot next should be n2. So for the first node, the next element will be n2, and for the current node, the previous should be previous node. So if you execute this one, we'll get up to second value, so 10, 20. And if you go with the third value, n3 is equal to node of 30, and similarly the third node, so n3 dot previous will be n2, and n2 dot next value will be n3. Similarly n4 is equal to node of 40. Similarly n4 dot previous will be n3, and n3 dot next will be n4. So if you execute this one, we are getting some nodes 10, 20, 30, 40. So for 20 the previous will be 10, the next will be 30. For 30 the previous will be 20, the next will be 40. For 40 the previous will be 30, and the next will be none, right? So this is how we can create and display. So in the next session we will see the insertion, so inserting a node at the beginning or end or in the specified position.
Create the double linked list, and how we will display all the nodes of double linked list. Now in this session we will see the insertion operation. Double linked list, right? So first let us consider some elements, then we'll apply the insertion operation. So how we can insert the element or a node at the beginning or at the end or in the specific position, right? So first let us take 4 nodes and then we'll see. So name itself indicates every node will be having 2 references. One is to the previous node and another is to with the next node. So in the previous session we have already seen how to create the node, right? So we have taken some 3 variables in the node class, right? So this is n1, n2, n3 and n4. Let it be 10, 20, 30 and 40. The address is some 1000, some 2000 and 3000 and 4000. Now this is none because this is the first element, there is a no previous. This is none and it stores the address of next one, 2000, and this is 1000, 3000 and again 2000 and 4000 and here 3000 and none because this is the last element, right? So there will be 2 links, right? Now so let us assume these are the 4 elements now. So we need to insert the element first at the beginning. Insert at beginning. So if you insert the element at the beginning, so this will be the head, right? Head. This will be the head. Now if you insert the node at the beginning, what we have to do? So in order to insert the node, the n is equal to some node of 5. So if you give this one, automatically one node will be created here with a 5 and this is a none and this is a none. Okay, so initially none and 5. Now we need to link these two. So if you insert this node as in the first one, we need to change the head. We need to change the head. So before changing the head, we need to make the link between the first node and the second node. So this becomes the second node, right? Now see, let us take some temporary variable and initialize the head to temporary variable. So the head will not be changed. Now see, then after executing this one, this becomes the temp. This becomes temp. Now temp dot previous. Temp dot previous. So what is the value of temp dot previous? That means this position. This position must be this one, right? This position must be this one. So sorry, yeah, n. So automatically let it be some 500. Okay, 500. So here none will be replaced with 500. Automatically a link will be established from n1, and that means our present head to new node. Now we need to change this one. So because we have to produce a link between first node and second node also. Now n dot next which will be temporary. So automatically this none value will be replaced with 1000, right? So link will be generated. Now we need to change the head value. So head position should be changed to here. Head position should be changed to here. So self dot head is equal to this value. That means n, because n is a node, right? Hope you understood. Only few steps. So first we are creating one node and we need to insert that node at the starting position. So after inserting the node, this will becomes like this with 2 references as none. So we need to establish a link between the first node, the previous first node and the current node. So for that purpose we are using these 2 steps, and after that we are just changing the head position to the current node, right? So hope you understood this one. Insert at beginning, right? Now, so I will demonstrate this by executing a program, don't worry. The next one is insert at end. At the end we need to insert it, right? So let us take some n is equal to a node of, so it's 40, so I will take 50. So I need to insert some 50 element at the end. So after executing this statement, automatically a node will be created, with 50 with both the none values, both reference as none. So we need to link up with the last element with the present last element with the new node, because new node will be the last element now, right? For that purpose we need to travel from first element to the last element. So in order to travel, just I am taking some temporary variable and I am initializing the head value to the temporary variable, and I am just traveling from first element to the last element. So while temp.next means, see, so after insertion the head, so this is the head row, right? And also temp. Now temp.next is not none. So unless the temp.next is none, it will repeat the loop. So what we have to do, we have to change the temp is equal to temp.next. See, temp.next is not none, true. So automatically temp will be temp.next. So temp value will be at 1000 now. Now again temp.next is not none, right? Again temp will be moved to here. Again temp is equal to temp.next. So temp.next is not none. Again change temp to temp.next. So 3000. So here it will be. So like this it will travel from first element to last element. Now the temporary variable is at here, right? And this is nothing but n. So new node. Now what we have to do? We need to change this one. We need to establish a link between the temporary variable, present temp value to the new node. For that purpose, go with the temp.next. Temp.next is equal to, here we need to give the address of n. So let it be some 5000, right? So temp.next is equal to n. So automatically none will be replaced with 5000. So automatically a link is established here. Again, the new node previous should also be changed, because for every node we have to link with the previous node and the next node. So obviously n is the last element, so n.next will be none and n.previous will be the address of previous one. So for that purpose n.previous is equal to, so replace this with this value temp. So that means 4000, right? 4000. So this is how we can insert the element at the end, right? So first we are traveling from first element to last element, and then we are establishing the link between the temp and the new node, right? For every node there must be a reference to the previous node and the next node. So if you draw this diagram, these lines will be very easy to write, okay? Unless you draw the diagram, so it is somewhat difficult to write the nodes, right? So you have to imagine, if you draw this diagram or if you draw these nodes, it would be very simple to write these steps, right? Hope you understood this insertion at beginning and insertion at ending. Now we'll go with the third case, that is insertion at specific position. We need to insert the element at specific position, right? Now, so I need to insert the position at 1, 2, 3, 4, and data will be fourth position, that is a 25. I need to add a 25, right? Position 4 and 25. I will write here. Position is equal to 4, 1, 2, 3, 4, and data is equal to 25. So automatically first we need to, so I will write the heading, okay? Insert at position. Now take the data, node of, let it be some 4, let it be some 4. So just we need to change the temporary variable, okay? Sorry, we need to travel from first node to just position -1, that means 3, up to 3 it should be traveled. So now what we have to do, so take the temporary variable and assign the head position. So automatically now this is the temp. Now what we have to do, we have to travel. So for I in range 1 to position minus 1, 1 to position minus 1. So automatically change the temporary variable. Temp is equal to temp dot next. So I ranges from 1 to position minus 1 means 3. That means I is equal to 1, I is equal to 2. Right? So after first iteration, the temp becomes here. Right? Because first iteration temp is equal to temp dot next. Temp is equal to temp dot next means 1000. So it points to the 1000. So here the temp will be at 1000. Now here again, where I is equal to 2 within the range. So automatically the temp is equal to temp dot next. Temp is equal to temp dot next means 2000. So here the temp will be pointing. So now the temp will be at 2000. And I is equal to 3. It doesn't happen because the range of 1 comma 3 means it will iterate up to 1 and 2. So now the temp value is here. Now the temp value is here. And a node is created here. A node has been created here with a 25, and this is a none and this is a none. So we need to link these two. We need to link these two, right? So now n dot previous is equal to n dot previous means this one. So this is the previous and this is the next, right? So n dot previous is equal to what we have to get here, this value. Okay, this value, temporary. Okay, because we are inserting this element here. So we are just removing this link and we are inserting the link here, right? So here n dot previous, this is the n value, n dot previous must be this one, 2000, right? What about n dot next? This one, 3000. 3000 means temp dot next. Temp dot next. So automatically we'll get 3000. So is this sufficient? No, because again this temp value is pointing at 3000. So we need to change this and also this one, right? So we need to change this one. We need to change this one. So how to get this position? How to get this position? Simply temp dot next. Temp dot next means 3000. Okay, this field dot previous, automatically this one. And what is the address here? It should be new node, that is let it be 2500. So this 2500 should be here, that means n. Okay, so I hope you understood this one, because we need to link here and this to here. So automatically n address should be placed at previous node, right? So to get this one, temp dot next, that means 3000 dot previous, this position. So we are changing to n. And what about this one? This should be changed. 3000 should be changed to address of this one, 2500, right? That means temp dot next is equal to 2500 means again n. So this is the code we need to write in order to insert the value at particular position, right? So this is very easy. If you draw this example, if you draw some nodes, it would be very easy to write the content. Okay, so first we need to insert the node. We have created one node, so then we have traveled from first element to the position -1, so that we need to establish a link between the position -1 to new node and new node to next node. So for that purpose we are taking some n dot previous and n dot next. So n dot previous, it should be the temporary, and n dot next should be the temp dot next. So because initially the temp dot next is here itself, right? So then we need to change the positions of temp.next and the next node.previous. So for that purpose I am taking temp.next.previous is equal to n, so that it will be changed, and temp.next equal to n, this will be changed. So if you write this statement in the first line, automatically again the code will be different. We need not write this one, so this statement will be wrong. So just you need to follow the order. So what we have to do first and what we have to do next. So that should be important, right? So hope you understood this one. So this is how we can insert the node at end, beginning and specific position, right? So now I will execute a program demonstrating all these three functions. Inserting a node, how to insert a node at the end, beginning, ending and specific position, right? So let's move on to the system.
Hello friends, so just now we have seen how can we insert the nodes into a double linked list. So in the previous session we have covered how to create the double linked list and how can we display the nodes of double linked list. So now in this session we will see the demonstration of insertion method. So in order to reduce the time, I just copy the code. So in the previous session we have written some code for creation and display. I will copy the same code here and directly we'll move with the insertion, right? See, this is the code which we have written in the previous session. So we have inserted some 5 nodes. So if you execute this one, we'll get some 5 nodes, 10, 20, 30, 40 and 50. So as the name itself indicates, it's a double linked list. So every node will be pointing to the previous node and the next node. So every node will be having the reference to the previous node and the next node. So now we'll write the insertion. So first we'll see the insertion at the beginning, right? So insertion at the beginning. So I'll write the method define insert underscore beginning, right? So we need to pass the data here. So after that create a node. So n is equal to some node of data. So now the node will be created with both the references none. That means here if after executing this one, n dot data will be data, n dot previous will be none, n dot next will be none. Now we have to link up. So we are inserting this node at the beginning itself. That means we need to change the self dot head. So initially the first element will be having pointing to the self dot head. So now the self dot head should be changed to this new node because this node is inserting at the beginning. For that, just we'll take a temporary variable and we'll assign the self dot head. And then next we need to give the links. So temp dot previous. So temp is nothing but our second node. After inserting the first node, this new node, the temp will be pointing towards the second node because temp is equal to self dot head. So temp dot previous. So what about the reference to the second node? It must be a first node. Now first node is n, right? And similarly n dot next. So current node dot next should be temp, right? And change the self dot head. Change the self dot head to n. So simple steps. It's a simple steps. So we are just creating a node. So with the 2 references with none. So the second node, if you insert this as a first node, the second node must be, current head must be pointing towards the second node. So we need to change the head. So that's why we are giving some temp value for the head position. So temp dot previous must be the first node, that is n, and n dot next should be the second element, that is the temp, and self dot head is equal to none. So we'll create the node, right? So after that l dot insert underscore beginning of let it be some 5 execute. So you can observe here 5 is appended here, right? So again if you execute the same method once again with a new data, let it be 7, execute. So 7 will be inserted at the beginning, right? If you execute 5, 7, 10, 20, 30, 40 and 50. So this is how we can insert at the beginning. Now what about the ending? So how to insert the element or a node at the ending. So write down the function, so self comma data. So we need to create the node. So here also I will go with a n dot node of data. So last, so we need to travel from first element to last element. For that I am taking the temporary variable and I am just assigning the self dot head to temp, and I am just giving the loop to travel from first node to the last node. So while temp dot next is not none, so automatically after executing this one, so we need keep on changing the temp, right? Temp dot next, after executing this loop, so whenever the loop comes, I mean the control comes out from the loop, the temp will be pointing towards the last element. Now we need to change the last element next to new node, because the last element next will be pointing towards none, because that is the last element. Now here we are inserting a new node at the end. So that means the temp dot next, so whenever it comes out from the loop, it is the last element. So temp dot next will be pointing towards n, and automatically n dot previous must be temp. N dot previous must be temp. So we are moving from first element to the last element, and we are changing the references. Now we'll see. I will give some comment here, and let us take L dot insert underscore end 60. Now after executing that, we need to get a 60 as the last element. See here, 60 is the last element. So before applying this line, the output will be 10, 20, 30, 40, 50, and here whenever you are inserting some element at the end, automatically the next element will be pointing at 60, right? And again, if you insert one more element, that will also be pointing at last, that means that will be added at end element, right? 70. So you can observe 10, 20, 30, 40, 50, 60 and 70, right? So hope you understood this one, beginning and end. So very simple methods. Next means if you want to insert the element at particular position, what we need to do? So we need to pass the position and the data. Position and data. So create a new node. So that node should be inserted at the given position. So in the position, first we need to travel from first element to the position value, position but one. So for that we'll assign some head value to temp, self dot head, right? Now we need to go from first element to the position. So for that, for I in range of 1 comma position minus 1, and keep on change the temporary variable. So up to the position minus 1 it will be pointing. Now just change the previous, n dot previous is equal to temporary, and similarly n dot next is equal to temp dot next, and then temp dot next dot previous. So before changing the temp value, we need to assign the temp dot next dot previous element to the n, because we are inserting the new node in between the different nodes, right? So that's why just go with this one, and next temp dot next is equal to n. Now you can observe here. So let us put the comment here for these two lines. So L dot insert underscore position, let it be 3 comma 25, and if you execute this one, you can observe 10, 20, 25. So at the third position we are getting some 25, the value 25, right? So at the third position we are getting the value 25. Hope you understood this one, right? So in order to change the, in order to insert the element at required position, we need to change the head. That means we are assigning some head value to the temporary variable, and we are just keep on moving the temporary variable to the position minus 1, and there we need to give the reference for previous and next, and then we have to change the value of temporary, right? So hope you understood this one. And again, one more method we'll call, I will show you. Insert position, let us take fifth position, so 1 2 3 4 fifth position with a 35. Execute this one, so you'll get fifth position, the 35 will be inserted. So 10 20 25 30 35 40 and 50, right? So hope you understood these three functions: insert at the beginning, insert at end, insert at the specific position, or beginning or any specific position. Similarly, in this session we'll see the deletion. So how can we delete a node of at the beginning, a node at end, or node at from the specific location, right? So double linked list. So before starting this session, so how to delete the nodes, so we'll draw the nodes. So unless you draw the nodes in the data structure, it would be somewhat difficult to write the statements, right? So if you draw the nodes, so what are the nodes available in this double linked list, then it would be very easy to write the statements, right? So let us draw the nodes. So let us take some 4 nodes. So 4 nodes. So second node, it's a third node. So this is a double linked list. Every node will be having 3 fields. One is the link to the previous one, and the data field, and link to the next one. So let it be 10, 20, 30 and 40. So the address is some 1000, some 2000, some 3000, some 4000, right? So here the previous, there is a no previous node, this is the first node, so that's why we have to give the none, and this is a link to the next node, that is a 2000, and this is a link to the previous one, that is a 1000, and link to the next one, that is 3000, and this is a link to the previous one, that is a 2000, a link to the next one, that is a 4000, and this is a link to the previous one, 3000, and the next, this is the last node, there is a no node after this one, so that's why we have given some none. So automatically there will be a link between these 2 nodes. So double link, that means next and previous, right? So this is the double linked list. Now we need to give the deletion. Okay, if you want to delete the node at the beginning, delete at beginning, delete at beginning. So here, if you delete the node at beginning, so first initially this is the head position, this is the head position. If you delete this one, so first we need to change the head position to the next one, the head to the next one. So first let us take the temporary variable and initialize the head to that particular temporary variable, right? So this is a temp also, this is a temp also. Now the self.head is equal to temp.next. So automatically the temp.next is assigned to self.head. What is the temporary value? This one. Temp.next means 2000. So 2000 will be applied, assigned to self.head. Now the head will be moved to the second one, that means a 2000, location 2000. So this is the head position, right? Now what we have to do, we need to disconnect the link. So this is the head now. So we need to disconnect the link between the first node and the second node. So for that purpose, this is a temp value. So temp dot previous is equal to, that means this one. Okay, so automatically it was none, so we need not go with this one. So temp dot next, this one. So temp dot next will be none. Temp dot next will be none. So automatically there is a disconnection, so it becomes none. So there is a disconnection, but there is again a link from head to previous node. So head dot previous should be none, because if it is a first node, previous there will be no node, so the previous address should be none. For that purpose we can go self dot head dot previous.
is equal to none. So self dot head means this one, self dot head dot previous means this one. So this will becomes none now. So automatically this link will also be deleted. So automatically the link has been deleted. So now the double linked list consists of only 3 nodes, that is 20, 30 and 40, because so there is no reference to the previous node here. So that means this will be the first node, right? So these are the few steps in order to delete at the beginning, right? So hope you understood this one, right? Next, deletion at ending. Okay, delete at end, delete at end. So we'll go back with the normal double linked list. So remove the head here. So I will go with 2000 here and 1000 here. So automatically link will be established here, and this will be the head. Alright, so this is a node. Now we need to delete the last node, this one. So if you want to delete this node, we need to disconnect a link between the last node and last but one node, right? So for that purpose, I will go with a temporary variable. So we need to travel the temp from first node to last node. So temp is equal to, I will assign self dot head dot next. Okay, self dot head dot next. That means self dot head means 1000, self dot head dot next means 2000. So this will be the temp value. This will be the temp value, right? So if you go to the, if you travel to the temp to the last node, so what about this node? So for that purpose, I will give the one more variable called before. Before is equal to self dot head. Self dot head. So automatically this will becomes before. I'm taking before. So we need to travel both the things from first node to the last node. So whenever the temp becomes last node, the before becomes last but one node. So we can disconnect the link between temp and before, right? For that purpose we have given some before. Now we need to travel. So while temp dot next is not none, so unless it becomes none, it will just keep on moving. So in order to keep on moving, change the temp value for every iteration to the next. So temp dot next. Similarly, we need to travel this before also along with the temp. So before is equal to before dot next. So automatically after executing this loop, so after end of this loop, this becomes the temp, because temp dot next is none, right? So this will becomes the temp and this will becomes before. This will become before. This becomes temp and this becomes before. Now we need to disconnect a link between before and temp. Now see what we have to get it. So we need to remove this one. That means before dot next is equal to none. So before dot next means this one. This one becomes none. So automatically a link is disconnected. And again there is a link between temp and this node, right? Temp dot previous. So also give the none here. Temp dot previous. Temp dot previous is equal to none. Again just remove this 3000 and it becomes none. So obviously a link will be disconnected, right? Now there is no link between temp and before, right? So here before is the last element. So 10, 20 and 30 will be the elements or nodes in double linked list after deleting the element at the end. So as I have said that if you draw the linked list, so it would be very easy to write these statements, right? Yeah. So hope you understood these two procedures, deletion at beginning and deletion at end. Now we'll go with the third one, that is how can we delete the node at specific position. So we need to give the position and we need to delete the element at that particular position. So let's start that one. That's also very simple thing. So I'm just erasing all the headers. So just point the same. So 4000 is the location here and 3000 is location here, reference here, right? So this is a position 1 2, 3 and a 4, right? Now deletion at position, at specific position, deletion at specific position. So here we need to give the position value. We need to give the position value. So similar to our previous function, that means deletion at the end, we need to take two variables. We need to travel those two variables and we need to disconnect the link between those two variables, right? See, so let us consider the same thing. Temp is equal to self dot head dot next. So this is the location of head, right? And see, let us take the position 3. Position 3. So if it is a position 3, we need to disconnect the link from position 3rd node to 2nd node. So in order to set that, temp is equal to self dot head dot next. So automatically here it will be temp value. Here it will be temp. And then, sorry, before is equal to self dot head. So this will be the before. So we need to change both one. We need to change both, right? So see, now for I in range 1 to position -1. So we need to change the temp value. Temp is equal to temp dot next, and similarly before is equal to before dot next. So we are just moving that one. So that we'll see here. So I value will be 1. Okay. So here position is equal to position -1. So that means I should be in range of 1, 3. So that means 1 and 2. So for I is equal to 1, temp is equal to temp dot next. Automatically this temp will be moved to here. And before is equal to before dot next. So this before will becomes here. That's good. Next, I is equal to 2. Again, that is within the range. Again, temp is equal to temp dot next means this moves here. And before is equal to before dot next. So this will move here. Before, right? Okay, hope you understood. Now I is equal to 3. So 3 is a upper boundary. That means end position. So we should not include that 3. So just stop here. Now what we have to do, we have to delete this one. Okay, the position at sorry, here the position is 3. Now the range will become 2. Okay, the range will become 2, and see, position -1, so 1 to 2. That means I is equal to 1. Only one iteration will be there, and this becomes the temporary and extremely sorry. So this becomes before. Okay, only one iteration will be there, because after first iteration, the next iteration I will be 2, and 2 will be the last boundary, right? Because position is 3, we have to use the loop from 1 to position -1. That means 1 to 2. Right? So now we need to change we need to delete this one, third link. We need to delete the third link. So if you delete this third link, so here before dot next should be what value? So here it should have the link of 4th element. Okay, it should have the link of 4th element. Right? It should have the link of 4th element, that is 4000. That means temp dot next. Okay, hope you understood. So we need to change the before dot next. If you delete this node, that before dot next should be pointing towards this node. This node address is 4000. So in order to that, before dot next is equal to, so I am giving 4000, that is temp dot next. Temp dot next. So obviously now it becomes 4000. So this link is disconnected and this link will be directed towards here. And again here this position should be changed. Okay, this position should be changed, right? How to get this position? How to get this position? So temp dot next dot previous. Temp dot next dot previous. So temp dot next means 4000. 4000 dot previous means 3000. Okay, and that should be the address of this one. Okay, that should be the address of this one. So this is before. So automatically we can go with the before. So automatically 3000 will be removed and here it will be placed 2000 and this link will be disconnected. This link will be disconnected. Right? So hope you understood. So automatically there will be a link between here. Okay, and there are two more connections here. So we need to give the none values. So for that purpose, what is this one? So temp dot previous is equal to none. Temp dot previous is equal to none means this will becomes none. Automatically this link will be disconnected. What about this one? Temp dot next becomes none. So automatically this becomes none. So this link will also be disconnected. So now we have disconnected this element. So automatically before, this is the second element, this will be the third element. So we have established the link between the before and the last element. Okay, so once again I'm saying, so before dot next, here we have to store the address of last one. So in order to get that, we need to go with temp dot next. So temp dot next is nothing but this one. So this value will be stored at here. And similarly here we need to change the link. So this link should be before. So automatically in order to get this one, temp dot next means this one, temp dot next dot previous, automatically before. Then it will be 2000. Now we need to disconnect these two links. So temp dot next, temp dot previous. So that we have done. Okay, a very simple thing. So in order to delete the node. Right, so hope you understood this one. So let's stop here. So I will demonstrate these three functions. That means how can we delete the node at the end or beginning or at the specific position by executing a small program. Right, so let's move on to the system.
Hello friends. So just now we have seen the deletion operation on double linked list. That means how can we delete a node at the beginning or at the end or at specific position. Now let us execute those three cases. So writing the function. So I will show you by executing the program. So first, in order to reduce the time, so in the previous session we have seen already how to create and how to display the nodes of double linked list. I am using the same program here. So I am copying that one and I am using the same thing. So if you execute this one, we are having some nodes 10, 20, 30, 40 and 50. Now in this program, we'll write the functions to delete the node at the beginning, delete the node at end and delete the node at position, specific position, right? So let us start writing the function. First we will write the function for deletion at beginning, right? So first parameter will be the self. So just go with this one. Initialize the self.head to temp. So self.head is assigned to temporary variable and now we need to change the head value. So initially the head value will be pointing towards the first element. Now we are deleting the first node, so automatically the self.head should be point to towards second node. So self.head is equal to temp.next. Automatically the temp.next is assigned to self.head. That means the next node, the second node, it will be pointing to the head. Right, now we need to disconnect the link. We need to disconnect the link of the first node. So what is the first node address? The first node is nothing but temp.next. Temp.next, because temp is the first node, right? Temp.next. So what is the previous of the second node? What is the second node? So self.head is pointing towards the second node. So dot previous, because every node will be having the previous and next. So head, if it is a first node, the self.head is pointing towards the first node and the first node previous must be none. So that's why we are changing it to none, right? So first we have changed the head position and we are just disconnecting the links from the first node to second node. So for first node, the next address should be none and the next node, the previous address should be none. So then the second node will become first, and that will be assigned to self.head. So if you execute this one, so write the method L dot delete underscore beginning, right? So if you execute this one, we can observe here 10 has been deleted. 10 has been deleted, right? So these are simple steps. See, these are the simple steps in order to delete the node from the beginning. Now we'll go with the delete the node from ending. So that's also very simple thing. So just we'll write the method. So here also we need to assign the self.head to temporary, because we need to travel from first node to last node, right? So I am assigning some self.head to temporary, and again we'll use another variable called before, right? So in order to disconnect the links, we'll use this one. Just now I have shown you how we can delete, right? So before is equal to, give the self.head, right, and here assign the self.head.next. That means, so by executing these two things, before points to the first position, temp points to the next node. So if the before points to the first node, temp will be pointing towards the second node. Now we need to change the temp to the last node. So while temp.next is not none, that means until the temp.next becomes none, so we need to change the temp value. So temp is equal to temp.next. So after executing this loop, the temp value will be pointing towards the last node. So automatically again just change the before value also. Before is equal to before.next. So whenever the temp is pointing towards the last node, before will be pointing towards the last but one node, because we need to disconnect the link between last but one and last nodes, right? Now temp is pointing towards the last node and before is pointing towards the last but one node. Now what we have to do, we need to disconnect. That means last but one node next should be none. That means before dot next should be none. Similarly, the last node previous should be none. Okay, for the last node, the previous will be the link of last but one node. So that's why the temp dot previous is equal to none. So that's all. So automatically link will be disconnected and the last node will be deleted, right? So let us execute this one. So delete underscore end, and if you can observe, so I will just put the comment for the first time and I will execute. So these are the nodes available in the double linked list. So I'm just taking the comment and executing. So automatically the 50 is deleted. So previously you have observed that 5 nodes, 10, 20, 30, 40 and 50, and after executing this statement, so L dot delete underscore end, that means this function will be executed so that the last node will be deleted, right? So simply we are passing the temporary variable from the second node to last node, and similarly we are assigning some head to some before, and we are just passing that before to last but one node, right? So after executing of this while loop, the temp will be pointing towards the last element, before will be pointing towards the last but one element. So because we need to disconnect between the last but one element and last element. So this is a very simple method, right? So unless you draw the diagram and if you analyze, so you can easily write these statements. Okay, and now we'll see the third case, that is deleting at the specific position. So we need to give some position. So we have to delete the node at that particular position, right? So first one is self and another one is a position. Now the same process, assign some self.head.next to temp and before to self.head, right? And now we need to change the temporary value from the current position to the position minus 1. Okay, position minus 1, because we need to delete the element, we need to disconnect the link between position and position minus 1. So for I in range, so we need to travel from first position to position minus 1. So range of 1 comma position minus 1. So automatically we'll get temp is equal to temp dot next, and similarly before is equal to before dot next, right? So now we need to change the values, we need to disconnect the values. So for that purpose, before dot next, before dot next should be temp dot next. Okay, before dot next should be temp dot next. That means we are disconnecting the middle node, okay, at that particular position node. So we need to change the previous positions and next positions. Now temp dot, just now I have shown you, right? So temp dot next dot previous is equal to before, right? So previous we need to give the before value, and now just give the none as temp dot next is equal to none, so that it will be disconnected, and temp dot previous is equal to none. So this gives the disconnection of the particular node. Now I will show you delete at the position. Delete at the position. So I am giving some hash, that means comment. I am keeping the comment execute. So there are some 10, 20, 30, 40 and 50. 5 elements are there. Now execute this one. I need to delete the position 3. The value at position 3. So that means 1, 2, 3. 30 must be deleted. If you execute this one, you can get the 30 is deleted and the 40 is linked to the 20. Right? Now the 40, the 20, the next of 20 will be address of 40 and the 40 of previous will be address of 20. So that's the code we have written for these two statements in order to provide the links between the nodes. Okay, so this is nothing but disconnecting the node. So if you keep the none, automatically the node will be disconnected. Right? That's why we are getting some 10, 20, 40 and 50. We are removing the 30. And if you go with some 4, that means a 40, you'll delete the 40. If you delete second, automatically second element will be deleted. Right? So this is how we can execute the deletion operation. So delete at beginning, delete at the end, and delete at specific position. Right? So unless you draw the diagram, you can't write the code. Right? So if you draw the diagram with all the nodes and previous and next, it would be very easy to write these statements. Right? So hope you understood this one.
Linked list. Circular linked list. So this is similar to our single linked list. So here also we are going to use the single linked list. So single linked list. So everything is common, but only one difference is, so last node will have address of first node. That means a collection of nodes connected in circular fashion. So circular fashion means the last node will be connected to the first node. For example, if you take 10 and the second node is 20, 30, 40. So this is a circular. Okay. So 10, the address of this 10 will be holding of next node, right? So see, simply we can say here the node will be having two parts. One is a data. I take 10. I'll take another node with a value 20. I'll take another node with a value of 30. So the address of this one is 1000, it is 2000, and it's 3000. Right? Now see, the address of next node will be stored in the present, right? So 10 and this part, so this part is a next part, right? So which holds the address of next node. So here the address of next node is 2000. So 2000 will be stored here. So there will be a connection, right? There will be a connection. Now here 20, then in this node the next will be having the address of the next node, right? So that means it will hold 3000. And so the connection will be established. Now 30, and here again we will be having the second part, that is next. Usually if you are using the single linked list, this will become null. Okay, usually the last node will hold the null in that particular address field. But here this particular last node will be pointing towards the first node. So last node will have the address of first node. So what is the address of first node? 1000. So this is 1000. So immediately a link will be established from here to here. So the nodes are connected in a circular fashion, right? So this is called as a circular linked list, right? So I will tell you the theoretical part here, and I will execute the program in our in the further time, right? See, here mainly we are going to use two different classes. Okay, we are implementing this data structures concept in Python, so we are going to use them object oriented programming. That means with the help of classes and objects we are going to implement this circular linked list, similar to our single linked list and double linked list. So here we use a class node. So this is for each and every node. So a node will be having two parts, one is the data and another one is the next. So where we have to initialize, so all the variables should be initialized in the constructor in the object oriented concept, right? So before watching this one, so just make sure you are aware about the object oriented programming in the Python, right? So already we have recorded the sessions, so just go through that so that this will be very easy for you. So whatever the variables inside the class should be initialized with the help of constructor. So here the constructor will be in format $init and for every function including the constructor, the first parameter will be the self, right? And the data, we need to give the input for the data, right? We need to give the input. Here in our example we have seen some 10, 20, 30. So 10 is the first node data, 20 is the second node data, 30 is the third node data. So we have to pass the data itself, right? So what is this one? So self dot data is equal to data. So this variable will be coming to this self dot data, right? Class variables. Similarly, what is the second part? Self dot next. Self dot next is equal to, initially let us take it as a none. That means a null value. Similar to our null value, here we will call it as a none. Initially, okay, this is an initial. So whenever we are creating a node, the node will be, so after executing this code, a node will be created, and if you pass some data as some 100, so 100 will be stored here, and here it will be none. Okay, immediately after completion of this code, after executing this code, that means this four lines of code. So 100, if you pass the data as 100, 100 will be here and none will be here. And this is the next part, this is the data part, and let it be n1. N1 is a node, right? So if you want to access 100, it will be n1 dot data, and if you want to access this one, n1 dot next, right? Yes. Next, after that we need to create one more class for the circular linked list. So in that circular linked list we are having a different operations. We can use different operations, right? So that means we can insert the data, we can delete the data, okay, we can display the data. So all these are the operations done on the circular linked list. So in order to implement all these operations, that means insert, delete, display, searching, etc., etc., so we can create a one more class here, right? So I will create here class some circular linked list, right? Circular linked list. So all the operations should be performed in the form of functions here, right? So class, inside the class, again, first of all, take the constructor, because here we need to initialize two things. One is a head and tail, because in order to process the data from starting node to ending node, we need to give the labels like a head and tail. So head points at the first node and tail points towards the last node in the circular linked list. So here usually the head and tail will be same. Okay, head and tail will be same. But with in order to avoid the confusion, we will simply go with the head and tail. So without the tail also we can implement that, right? but without any confusion. So in order to avoid the confusion, just we'll go with the head and tail. It would be very simple, right? Now initialize the thing using the constructor init, and here self, and see self dot head is equal to none. So initially the head is not pointing towards any other node. Similarly, self dot tail is equal to none. So here the tail is also not pointing towards any node because it is an empty circular linked list. Okay, this is a constructor, right? So empty circular linked list. If you insert any node, we need to change the head and tail. So if you insert 10, and this will be a none, so this will be head and tail. Head and tail. And similarly, if you insert one more thing, 20, so here we need to replace this one with the address of second node 2000. Okay, and tail, head will be remain same because this is the first element. Tail will be moved to here. So this is the second element. And what we have done, so last node we have the address of first node. So what is the address of first node here? 1000. So 1000 should be placed here. 1000 should be placed here, right? So like that, some head and tail should be used in order to do the processing, right? So how can we display the data? Okay, how can we display? So first, in this session, we'll see the two things. One is create and display. How to create a linked list and how to display the nodes of a linked list. So this is the creation. So we have created one node, class for one node, and one class for circular linked list. Now display. How to display the data? See. So I'll write the complete program. I'll execute the complete program for this create and display. So without using any special methods like insertion. Okay, insertion at the beginning or ending. I'm not using any sort of functions. So directly we'll write a few lines of code to insert the data and to display the data. Mainly we'll see for display function. So display function. So in this display function, what we have to do? So we have to start from head to tail. Okay, we need to start displaying the data from head to tail. So in order to display the data, what we have to do? So print. Okay, so here head should not be moved. Okay, head should not be moved. I'll take one example so that you can observe. See, I'll take 3 nodes. I'll take 3 nodes. So one is 10, 20, 30, right? So here it is 1000, 2000, 3000, and it holds the address of the next one. So 2000, it holds the address of next one, that is this one, and it holds the address of the first node because this is a 10, right? See, right? Yes. So this is a head and this will be the tail. So what we have to do? We have to display the complete nodes of this particular circular linked list. So in that, what we have to do? We have to start from head and we need to display each and every data up to tail. So what we have to display? We have to display this 10, 20, 30. So see, this is the data and this is the next. This is the data, this is the next. This is the data and this one is the next. So what we have to do, if we want to display this one, simply we can write it as head.data. Head.data, right? So how to move this one? How to move this head to this one, right? So simply we can use head is equal to head.next. So here, what is the head.next? Head.next is 2000. Now head is equal to 2000. Head is equal to 2000. That means the head will be pointing towards here. So one thing we should be careful, head should not be moved. Okay, head should be placed right to the first node. So that's why what we have to do, we have to take one temporary variable and store this head. So we can travel through each and individual nodes through this temporary variable. So instead of writing this one, simply print the temp.data, okay, and up to where we have to travel, up to tail. So how can we confirm this one? So simply temp.next is equal to, okay, simply self.head. So you can observe here, so head points 1000 and see temp.next is 1000. So then we have to stop because the last address of the last node will be having the first one. The last node will be having the address of first node. So the same thing, we are traveling this temp, we are traversing this temp from one node to another node, and we have to repeat the same process. Okay, we have to repeat the same process until this condition. Okay, until this condition. That means, so temp.next not equal to self.head until this condition is true. So let us move on to the system. I'll execute the code. So for creation and display of circular linked list. So let's move on to the system.
Hello friends. So just now we have seen the theoretical part of circular linked list creation and display. So we'll write some code for this circular linked list, right? So circular linked list, particularly create and display. So in our further sessions we will see the next part, right? So first we need to create a class for node. So I'll create a class for node which will be having a two variables, that is a data and the next. So I'll use a constructor def init double underscore. The first parameter will be self and the second one is the data which we need to pass. So self dot data is equal to some data. So next, similarly self dot next. So two fields, next will be none, initialized to none. Now create one more class for circular linked list, and here again initialize the two parameters. So one is head and tail. Okay, in order to travel from one node to our last node, so we need to give some headings like self.head is equal to none. Initially it will be initialized to none initially, right? So if there is no node, the head and tail will be none, right? So that's why I'm initializing this both of these with a none. Now write down the display function. So def display. So the one parameter is the default parameter will be the self, and here first one, if it is an empty list, automatically the head will be none. So if you want to create a linked list, automatically the head will be initialized and immediately the tail will be initialized. So if you create one node, so the same node will be pointing for head and tail, right? So here if the self dot head is none, that implies, so it's an empty circular linked list. So simply you can write here empty circular linked list, right? And else, that means if it is not none, so obviously that implies at least one node is available in the circular linked list. What we have to do, so we need to travel from first node to last node. So in order to travel from first node to last node, just initialize a temporary variable, because we should not move the head, right? The head should always point towards the first node and tail should always point towards the last node. So just take one more variable in order to travel from first node to the last node. So temp is equal to self.head, so that here the temp will be pointing towards the first node itself. Now what we have to do, first print the data. So the data will be at temp.data. So in order to represent this one, I'll use arrows.
Okay, there is no logic, just an arrow will be displayed here, right? And I will use a end parameter which will insert the node, which will display the next nodes on the same line. Okay, in order to avoid the multiple lines, so in order to print the output in the same line, I am simply using the end, right? So now what we have to do, we have to travel from first node to last node. That means we need to move the temp from first node to the next node. So how we have to move that one? So where we have to stop? So where we have to stop means in the circular linked list, the last node will be holding the address of the first node. Last node means while temp dot next. So we need to move the temp from one node to another node. So whenever the temp dot next is not equal to, okay, actually if whenever the temp dot next is equal to head value, because the last node address will be starting node, right? First node. So whenever this condition becomes true, we have to stop. Okay, whenever this condition means the temp dot next is equal to self dot head. If it is a single node, the head and the tail will be pointing towards the same thing, right? So here temp dot next is equal to self dot head means the node consists of the address of first node, right? So that's why we need to write the condition here. So until this condition becomes true, we need to travel, right? See, so that's why I'm using not equal to. So whenever these are not equal, then immediately the control will enter into the loop. Now simply travel, move this temp to temp dot next. So immediately, initially the temp is holding pointing towards the first node. After executing of this one, the temp will be pointing towards the node which is available at the address present in the current node, right? That means next node. Now just print the data. We need to print the data, right? Print the data, again use the same representations, arrow mark, and print the same thing in the single line, right? After that, see, yes, this is a display. So this will end whenever the temp dot next value is head value, right? Now what we have to do, create one object for the circular linked list, because we need to call these things with the help of this object itself, right? With the help of this object only we need to call the things, right? So insert one node. Okay, I'm not using any function, directly I'm writing the code, right? So we'll see the insertion at the ending, insertion at the beginning in our next sessions, right? So here I will go with the n1 is equal to node of, I'll take 10, directly I'm taking a 10, right? So if you take this 10, consider this 10, what we have to do, we need to point, so one node will be inserted, right? One node will be inserted, and this node will be pointing for head and tail, because initially head and tail are none. If you insert one node, then simply L dot head will be n1 and L dot tail will be n1. So head and tail both are pointing towards the n1. And what about the next? That means the node address. What about the next address? So here L dot tail dot next will be right L dot head, because if it is a single node, the address of the same node must be present in the address itself, right? So that's why L dot tail dot next, that means the address of this tail must be having the head. Then if you insert the second node, some n2 is equal to node of 20, right? So that means we are taking the second node. So I'm not writing any function, directly I'm using this one, right? So I have taken the second node. Now what we have to do? We have to change the tail. We need to change the tail because the head will be pointing towards the starting one and tail will be pointing towards the second node. See. So here what we have done, we have created n1 is equal to node of 10. So that implies 10 will be here and here it is next. Okay, initially it is none. So here the head will be pointing towards this one, so it is n1, right? And the tail is pointing towards this one. Now what about this place? Initially it is none, but if it is a single linked list, what we have done, so last node should have the address of first node. So let us, the address of this node is 1000, so only one node is itself here. So what we have to do, we have to place this 1000 in this next. So simply we can write it as tail dot next will be n1 or head dot next will be n1. So both the things are same. So you can write any one step, right? So because both are pointing towards a single node, right? Head dot next is equal to 1000. Automatically this none will be replaced with 1000, right? Now n2 is equal to node of 20, right? n2 is equal to node of 20. So what we have to do? So if it is a yes, so node of 20 means again one more node will be created here, 20. So what we have to do? So node of 20 means 20 is created and here initially it is none. Now what we have to place? So in this position, right? In this position, the address of this one should be saved, right? So what is this position here? So tail dot next. So tail is pointing towards first node, right? So tail dot next is equal to, okay, this is n2, right? Simply we can write it as n2. Now we need to move this tail towards this one because tail should point towards last node, right? So tail is equal to n2. So automatically the tail will be replaced here. That means it will be moved to the last node. Now what about this position? Now the tail dot next should be address of first node. What is the address of first node? You should not use n1, right? Head points towards the first node, right? So simply you can use head, right? So obviously a link will be created and the none will be replaced with 1000 and here the 1000 will be replaced with 2000 because this step replaces this 1000 with 2000 and this step will be changing the tail from first node to next node and this step will be placing the address of head at the end of the node, right? So hope you understood this concept. See n2, if you create n2, so that's why we have written this one, tail dot next is equal to head. So this is a single node, so I'll execute this one. So we need to execute display function. So l dot display. So we have created one object. So l dot, this one is 10. And then if you create one more node, so n2 is equal to node of 20. So what we have to do? So first we need to place the address of new node at the current node, right? So that's why what we have to do. So tail dot next is equal to some n2, and we need to move the tail is equal to n2, and tail dot next is equal to head. So here we need to call everything with the object, because head and tail are the variables, right? So L dot head, L dot tail, L dot tail, right? So after the first node display, after the second node display, I'll show you this one. Sorry. See, after the first node, after second node. So just for understanding, right? After first node, and after the second node. So if you insert the third node, the same process, n3 is equal to node of 30, right? n3 is equal to node of 30. See, I'll erase all these things. Simply I'll write here so I'll write here the first node, second node, third node. So it is n3, n2, n1, and the address is 1000, 2000, and 3000, and the address of second node is presented here, and here the address of the first node. So till now this is the address, this is the diagram. So this is the head and this will be the tail. Now if you insert n3 is equal to node of 30, so 30 is created, and initially it will be none. Okay, what we have to do, this 3000 should be placed in this position. This 3000 should be placed in this position because n3 is the node just after the n2. So what we have to do, the tail is pointing towards the last node. So simply repeat the same process. Tail dot next is equal to n3. So tail dot next means this one, this position. In this position, what we have to do, n3, the address of n3 should be placed. So 1000 will be replaced with 3000. Everything is fine. Now tail should be moved to this one. So whenever this address 3000 is stored here, a connection will be established. And now this tail should be moved here because n3 is the last node. So tail is equal to n3. So obviously this will be moved here, tail. Now here it is none. So this should be last node. This is a last node. So this should hold the address of first node. So again you can write the same thing, tail dot next is equal to, what is the address of first node? So that is nothing but head. So head. So the same step we are repeating. The same steps we are repeating. So simply you can use the same steps. So just change this one, n3, and this is also n3, and after third node. See, after first node, second node, third node. And in order to display the thing, so 10, 20, 30 are in the list. So last node is again 10, right? So here simply you can use, so here the temp dot data is a 30, right? So simply you can write it here outside the loop. Whenever the condition becomes false, it comes out of the loop. So immediately we can simply write temp dot next dot data, so that, see, the first node and the last node. So that means the circle has been completed. So 10, 20, again 10. So 10 points to 20, 20 points to again 10. 10 points to 20, 20 points to 30, 30 again points to 10. Right? So this is a simple code for circular linked list in order to create and display. So anything for particularly this particular data structures, if you draw this diagram and trace this one, simply the code will be very easy, right? So hope you understood this one. And today's session will go with the another function called insertion, right? So how can we insert an element or a node into a circular linked list? So we have to write a function for this insertion. So our topic is insertion operation. Simply we can write it as insertion operation in circular linked list, CLL. And this insertion can be done in three categories. So the first one, insertion at beginning. Second one, insertion at end. Insertion at specific position. So we need to give a position, so we need to insert the particular element at that particular position. So we'll see these three categories now, right? So anyway, so if you want to insert an element at the beginning, ending, or a specific position. Now, so I'm not moving towards the previous session, so I'll post the link in the description box. Just go through the previous session, that means introduction to the circular linked list. So how we can create a node or circular linked list class, and how can we write the display function, that means how can we display all the elements of circular linked list. Now see, first one, whatever it may be, insertion at end, beginning, or specific position, right? At end, begin, or position. So in these three categories, one thing is common. That means here the case is if circular linked list is empty. That means there are no nodes. Okay, there are no nodes. So we need to insert the node. So the insertion of node can be begin, end, or position, whatever it may be. Because the CLL is empty, the circular linked list is empty. So for this, just we will use, so we need to check if head is none, right? So we are creating two classes, one is a node, so which is having two things, one is a data, another one is a next, which are initialized to none, initially which are initialized to none. And CLL class, here we are using head, tail. Initially these will be none. That means an empty circular linked list, there will be no head or no tail. So if head is none, okay, if head is none, then we need to insert the node. What we have to do? Simply initialize head is equal to new. Okay, let it be, new is nothing but a node, a new node. New is an object for node 10, right? So head is equal to new, tail is equal to new. So that one node will be created. Okay, one node will be created with a 10. Okay, initially it will be none, right? So after executing these two statements, so the pointer points towards this one, the head points towards the starting one, similarly tail points towards the starting one. So we know that the circular linked list, the last node will holds the address of the first node. So here what happens? So tail dot next is equal to head. So simply the tail dot next means this part. So this address will hold the head address. So let it be node address is 1000. So this 1000 will be here. So you can write this statement or head dot next is equal to head, because tail and head points towards the same element. So this is the first case. If CLL is empty, so case 1, if CLL is empty. So this is a common case for all these three categories. That means if you are trying to insert the element on beginning, ending, or position. So this is a common code we have to write in all these three cases. And now the second case. Hope you understood this one. So if head is none, that implies the CLL is empty. So if the CLL is empty, we need to create one node, right? So whatever the node we are inserting, that will be the first node. So if it is a first node, the head and tail will point towards the same node. And as the definition from the CLL, that means circular linked list, the address of the last node will hold the address of the first node. So the node itself is the first node and the last node. The same address will be stored in that particular address file, right? So the case 2. What is the case 2? If CLL is not empty, that means the head is not null. That means the false case. So we need to write the code in the else part. Right? What happens? See, just for any operation, just imagine a linked list with some 3 elements or 4 elements. So definitely you can write a code on yourself, right? So I'm writing a code. I'm drawing the linked list, circular linked list with 4 nodes. So you need not mug up all the code, right? So if you draw the diagram, easily you can write the code on your own, right? See. So let it be N1, N2, N3 and N4, right? Now let it be 10, 20, 30, 40. So let us take this one. Okay. So some 2000, some 3000, some 4000. So the first node links to the next node. So that means it will hold the address of the next node. So it will be 3000, the address of this one. And this holds the address of the next one. That means 4000. So then only the link will be established between 2 different nodes. And here, as this is the last node, so it holds the address of the first one. So that means 2000. So obviously a link will be established between the last node and the first node. And head points to the first node and here tail points to the last node. So this is the existing linked list. Assume that. Okay. So here it is clear that the CLL is not empty. So now we are trying to insert the element. First, insert the element at beginning. So insertion at beginning. Let it be. So what is the new node? Let us take some new is equal to a node of 5. So 5 should be inserted, or 10. Let us take 10. Any element, that doesn't matter. Node. So immediately what happens? So 10 and none. Let it be the address is 1000. And this one is new. And see, this one is new dot next. Right? So there is no link between this newly created node and this existing circular linked list. So we need, so immediately after executing this single line, so this node will be created. Okay, because we have written 2 variables in the node class. So that's why, so if you create this one object, immediately this node will be created. Now what we have to do? So we know that this is the node we are inserting at the beginning. Okay, so what is the address of this one? Obviously, whatever the first node in the existing circular linked list will become the second node, right? So the address of existing first node should be available here. That means this 2000 should be placed here. So you can observe head points to the first node. That means this is existing, right? Now simply what you can write, see, new dot next is equal to, see, head. If you execute this one, simply this 2000, so head means 2000, right? This 2000 will be stored here. So immediately a link will be established here, right? So let us write here. Okay, this is the existing, right? a link is established. One link is established. So is it completed? No. So the last node should hold the address of first node. So no, the first node has been changed. The first node has been changed. So what happens? The first node address should be stored in the last node, right? So what is this one? In this position, if it is 2000, link is established to 2000. Now this 2000 should be replaced with 1000. Okay, this 2000 should be replaced with 1000, right? Then the last element is a tail, right? Tail dot next is equal to what we have to do? Tail dot next. So here we need to get this address 1000. So what is the 1000 address? New. So simply you can write it new. Then what happens? So this 2000 will be replaced with this 1000. Then see, the link will be established to here. Okay, the link will be established to here, right? So is it completed? No, because in this, after inserting the element, the first node is 10 and the second node is 20, but head points to the 20. Okay, head points to 20, so that's not correct. Head always points to the first node. So what we have to do? So head is equal to this position, that means new. So automatically the head will be pointing towards this position. Completed. So whenever you want to insert an element at the beginning, so simply these 3 steps are enough. Okay, anywhere, right? So don't worry, I will execute a program and I will show you. Okay, so this is the second case in the beginning. Now we have seen in the beginning itself. Hope you understood. Now see the same thing, small changes. We'll go with the second case, second category. So insertion at end. So let us take all these things. Okay, so here instead of 4000, let us take a 2000, and this is a head and this is a tail, and this is not a new dot next, and here, right? So one thing, just remember, this is a 10, head dot data means 10, head dot next means address, head means 1000. So if you consider one node, if you consider this node, so head is nothing but the address of that node 1000. Head dot data is nothing but the data available, and head dot next means the address of the next node, that means 2000. So remember, for any node we can write these 3: the current address, data, and the next address. Right. See, here the new node we are going to insert is 40, and the address is some 4000 and none. Okay, so here let us take 40. Okay, so this is a new, and this one is new dot next. Right. Now our problem is inserting an element at the end. What happens here? See, the tail should point to the last element, and the last element should hold the address of first element. Right. See, this is a new. Okay, this is a new. Simply go with the tail dot next. So first there should be a link established between these two nodes. How the link will be established? Tail dot next. That means the address of this tail, the next of this tail should hold the address of the next node, right? So tail of next is equal to new. So obviously tail of next is nothing but this one. This holds the 4000. So this will be replaced and 4000. So a link will be established here. Now, is it correct? No. So the tail should point toward the last element. So simply you can change tail is equal to new. So immediately after executing this one, the tail will be pointing here. So is it over? No. So the address of first element should be at the last element. But here the last element is 40, but there is a link between 30 and 10. So we need to change the link. So in order to change the link, that means this we need to change. How we can change? So tail dot next. Tail dot next is equal to, tail dot next means this position. This position is equal to head. Head. So obviously now what happens? See, whenever this 4000 is there, the link will be disconnected. Okay, the link will be disconnected, and whenever it is initialized here, so 1000 will be here, and a link will be established in this way. Now it was completed. So insertion of an element at the end. So you can write this code. So not only this code, so you can change the order and you can check. Okay, you can change the order and you can check. No issue, right? So that's what I'm saying. If you draw a diagram, simply you can easily write the code. Okay, then the next category, at a position. At a position, right? So let us assume the 4 nodes. So I need to insert a node at third position. So in this position, right? In this position. So I need to insert here 25 and none. So as usual, so create an object with 25. So immediately this one will be created. Let us assume that 2500 is the address of this node, and a new we have created, right? New, and this should be added. So that means the link should be in this way, and from here we should move to this particular position, right? Just right in the middle, so it will be easy for us. 25, and initially it is none. Some 2500 is the address, and a new in this position, third position. That means see, position is equal to 3. So what we have to do? First we have to traverse the head from starting position to that particular position -1. That means to this position. To this position. So for that we'll travel. Okay, or traverse from 1 to position -1. 1 to position -1. So simply you can write it here, some range of 1 to position -1. Right? So we should not move the head. Okay, we should not move the head. So that's why what we have to do, we have to create a temporary variable. So first step, so initialize this head to a temporary variable. Initialize head to the temporary variable. Now we can traverse this temp from the starting position to position -1. So up to here we can simply use temp is equal to temp dot next. That means just we are traversing. We are just moving on. So first range of, if it is 3, okay, if position is equal to 3, then range of 1 comma 3 minus 1, it is 2. That means it will traverse only one time, because we know already the range function. So it will start from the starting point and it doesn't include the end point. So here there is only one difference, 1 and 2. So only one iteration will be done. So temp is equal to temp dot next. So initially the temp is head, right? So here the position temp. Now we are just traversing. Temp is equal to temp dot next. So temp is equal to temp dot next means this one 2000. So immediately after this line executed, so this temp will be moved to this position. temp will be moved to this position. Now what we have to do, we need to change the things. So see, new dot next should be this one. Okay, so the link should be in this way. The link should be in this way. So that means this address, okay, position 3 address, that means 3000 should be here. So we can simply write this position, right? This 3000 should be here and this 2500 should be in this place. Okay, this 3000 should be here, this 2500 should be in this place. For that, what we have to do, simply see, new dot next is equal to, so this position, okay, new dot next is equal to, what's the thing, this one, 3000. What is the 3000? Temp dot next. Okay, don't get confused. So if it is 3000, then the next node will be at the 3000, right? Now we have to change this one, right? What is this one? Temp dot next is equal to this one, new. So obviously this 3000 will be replaced with 2500. So this link will not be there. So this position, this path will be inserted, this node will be inserted. So here we need to take care about the points, that means order. So first of all, if before executing this one, if you execute this one, temp dot next is equal to new. So this will become 2500, right? So after that, the temp dot next will be 2500. So here that doesn't work. So here we should be very careful while writing the statements, the execution of statements. So first we need to assign the temp dot next to new dot next, then only the temp dot next should be changed to new. So then only this link will be disconnected and a new link will be established and the new node will be included here, right? So hope you understood this one. So these are the three categories, that means inserting a node at the beginning, at the end and at the specific position. So in all these three cases, one thing is common, the case one, if the CLL, that means the circular linked list is empty, then we have to insert a node and the head and tail will point to the same node and the last address will be the same for the particular node, right? So let's stop here and I'll execute this code in the Jupyter so that if you are still having any doubts, you can be clarified, right? So let's move on to the compiler.
Hello friends. So just now we have seen the theoretical part of insertion operation in the circular linked list. Now I'll execute the code. So this is the code which we have written in the previous session. So that means creating and display. So here simply I'll insert one methods. So first let us display the linked list. So we know that we have not inserted any element. So obviously the circular list is empty. If you call this display function, so here the self dot head is none because there is no node inserted. So that's why we got this circular linked list is empty. So we'll write a function here. Okay. So let us write a function. The first function, what is the first function? So define, definition. Okay, function definition. So add begin. So let us take some x. Okay, so the first one will be the self and the second parameter is the value. Sorry, self, right? So we have, first we need to create a node. So new node of x. So immediately a node will be created with the data x and address next one is none. Now the first case, that means if self dot head is none, that means empty. Okay, now whatever the node we are inserting, that will be assigned to head and tail because the same node will act as a head and tail because only one node is there. So self dot head is equal to new and self dot tail is equal to new. And because this is a circular linked list, the address should be
the first address. The last element should hold the address of the first node, right? So the node itself is the first and last. So the same thing. So you can write it here. Self.tail.next. The last node is equal to, so simply self.head, right? So if it is a single element, there is an empty circular linked list. If it is not empty, that means a else part. So what we have done, so we need to change the new.next value. So whatever the code we have seen just now, I am writing that thing, right? So we need to assign the head to the new.next, because a node should be inserted at the beginning itself, right? So self.tail.next is equal to new, and self.head should be moved to new, right? So let us check. So this is the only code we have written, right? So this is the case, the first case, that's a common for all the three categories, and this is the second case for this begin, right? So we'll display L dot, what is the function we have written, add underscore begin. So I'll go with a 10 and call the display function. See, the first node and the last node points the same thing. Okay, now if you insert L dot add begin 20, add a begin 20, and L dot display, see, 20 is inserted at the beginning, because we are inserting the element at the beginning. Now 10 will move to the second position, and the last node is a 10, which holds the address of the first one. So again it points to 20. So 20, 10, 20. And similarly we will insert one more element. So add begin 30, and see, L dot display. See, 30 will be the first one, and 20, 10 becomes second and third elements. And as the 30 is the first element, the last node will point to the first element. So 30 here. So this is how we have written the beginning, right? Now we'll see how to insert an element at the ending now. Okay, so I'll write one more function here. So define add end, same thing, the self is the parameter, first parameter. So go through the object oriented programming, then you will be knowing why we are writing this self here and why we are calling this head and tail as self.head and self.tail, right? So I'll post the links in the description, so go through that one. And again, take the X, and same thing, new is equal to node of X, so it will create a new node with the data and next. And the common thing is the same thing, the first case, if it is an empty, then obviously it will be added, and else if it is not empty, now the case happens here. So whatever the code we have written just now, so tail.next is equal to new, and self.tail should be assigned to new, and now self.tail.next, that means it will be connected towards the first element. So self.head, that's it, the 3 lines of code. Now you can observe, so we have executed till now, it was done, right? Now what happens? So L dot add end, so I'll go with the 5, and L dot display. So now the values are 30, 20, 10. So here the last element is 10, right? Last element is 10. Now we are inserting 5 at the end. So if you execute this one, see, 30, 20, 10 and 5. And again the 5 will be pointing towards the first element. Okay, so if you again insert L dot add end some 6, so 1, and L dot display. So after 5, the 1 should be added. See, again 1, and which points towards the first element. So this is the end. Okay, This is the add. Now we'll see the third category. So how to insert an element at position. So add at position. So here we need to take the two different parameters. So the first one will be self, the second one will be a position, and the third one will be ex. So because here we are supposed to give the position where we are going to insert. So here the code is common. If it is a empty, then obviously we need to create that code, create that node and just assign that node as a head and tail, right? Else, and here if the position is equal to 1, that means if you want to insert an element at the position 1, that implies simply it is a begin. So I'll just call it as a add underscore begin of ex. So simply I'll call that function, right? I'm not writing any code. If position is 1, simply it will call that particular function add underscore begin, and rest of the thing will be executed. And if it is not position value is not equal to 1, then what we have to do, we have to travel from first position to position minus 1, right? So for that we are just assigning some temporary variable. Okay, so we are assigning some head to temporary variable because we should not change the head position, right? So for I in range from first position to position minus 1. So what we have to do, we need to change the temp value. So it will be traversing. So this statement will traverse from the first node to the position minus 1 node, right? Then after getting to the position minus 1, now we need to change the addresses. New.next is equal to temp.next. So this already we have explained in the board, right? So once go through that one. I think it's clear, right? There is no confusion. Temp.next is equal to new. That's it. That's it. Now let us check. So now see, I'll take all these display functions, okay, because we have already, yes, we have added some elements, and also I'll take out this one, right? Now the linked list is this one, right? 10 at the beginning, 20 at the beginning, 30 at the beginning, 5 at the end, 1 at the end, right? Now we need to insert, let us insert at the third position, in this position. Okay, insert the position, right? Insertion of 15 at position 3, right? For that, just add that one, L dot add underscore position. So we need to give two parameters. One is the position first and element next. So what is the position here? Third position. I need to insert at the third position. The element is a 15. So simply after executing that, just go with the display function. See, so 15 is inserted at the third position. So just if you want to understand this one, just draw a linked list with these elements and trace this part, and simply with an easy way you can understand everything, right? So next, let us try with one more, add underscore position, and I just want to add 40 at a first position, 40 at a first position, and just go with this one. So display, just a second. Okay, so this should be called with this one, L dot add begin, right? Because this is a function, so that should be called with the object. Now, yes, so you can observe here 40, and this is the first element, so obviously the last element should point to this first element. Hope you understood. So if you are using the position 1, simply it will execute this add underscore begin. So hope you understood the error. So previously we are not calling this function with the object. So this is an object, this is a method, right? This is a method. Add underscore begin is a method. See, this is a method which is available in CLL. So all the methods of a class should be called with only with the help of object. So here L is an object for CLL. So we are calling all the functions with L, right? So once again, L dot add underscore position. So let us take 1, 2, 3, 4. So in the fourth, I'll add some 18. Okay. In the fourth position, I'll add some 18 node. See, 40, 30, 20. The fourth position we are adding 18, and followed by 15, and so on, so on. Right. So hope you understood this one. So very simple code. So if you count the number of lines, it may be a lot, but the logic is very simple. So if you draw a linked list and if you trace the thing, if you understand the concept, then it will be very easy for you to write the code. Hello friends, welcome back to our channel. So in today's session, we'll see one more operation in circular linked list, that is a deletion operation. So circular linked list. So already we have seen different operations, that means how to create a circular linked list, how to display the nodes of a circular linked list, and in our previous session we have already seen how to insert the element into a circular linked list. In that we have seen the three categories. So insertion at the beginning, insertion at the ending, and insertion at a specific position. So similarly we'll see the deletion operation in this session. So deleting an element from the beginning, deleting the element from the ending, and deleting the element from a specific position. So before that, I'll just give 4 nodes. I'll write a 4 nodes and directly we'll go with the deletion. So I'll post the links in the description regarding this create, display, and insertion. So go through that and just follow this one. So after completion of the theoretical part, I will explain, I will write the code and I will implement that code. Right? Now let us take the 4 nodes and then I'll start explaining how to delete the node from the beginning, ending, and at a specific position. So particularly in the data structures, so if you won't draw this diagram, it would be very difficult to write the code. So just you need to imagine more, right? So rather than that, just write down the code, draw the diagrams. Simply you can write the code. You need not mug up, right? So the address of first node 1000, address of second node is 2000, address of third node is 3000 and a 4000. And in order to get the link, the address of second node should be here. So that is 1000. And address of third node should be in second node. So there will be link. There will be established a link here. So this is a 4000. And the last node this is a circular linked list. So the last node should hold the address of first node. So there will be a link from last node to first node. And this will be head and this node will be a tail. Right? So now our circular linked list is having 4 different elements. Right? Now we'll see deletion at the beginning. So we need to delete the element from the beginning. That means the first position. Delete at beginning. So whatever it may be, deletion at beginning, ending, or specific position, one thing we need to check whether the circular linked list is empty or not. Right? So delete at beginning, delete at end, delete at some position. For all these 3 cases, the first case, the case 1 is CLL is empty. We need to check for CLL is empty. For that, simply go if self.head is none. So if self.head is none, that implies there is no node in circular linked list. Simply we can write it as an empty. And coming to the second case, So if the circular linked list is having more than, one element, if it is having one element, simply we need to delete that particular element. If it is having one element, simply we can check self.head is equal to self.tail. If it is having only one element, this is the case. So simply you can write here, so self.head, it can be assigned to none. That's the second case. So first case, 0 nodes. So if it is 0 nodes, so we can't perform this deletion operation. So when it will be an empty, self.head is none. So that we need to check first. Second thing, self.head is equal to self.tail. That means there are nodes in circular linked list but only one node. So if there is only one node, the head and tail will be pointing towards the same node. So that's why we have to check this one. Self.head is equal to self.tail. Right? So if there is only one node, whether it can be deletion at beginning, deletion at end, or deletion at position, simply you can go with the self.head is equal to none. So you need not go with any other code, right? Simply self.head is equal to none, so that will be deleted. And coming to the third case, that means if the circular linked list is having more than one element, more than one node. So in case 1 is nodes, 0 nodes. Case 2 is only one node. Only one node. And case 3 is having more than one node. So we need to check, or we need to write the code for the third case. That means more than one node. Okay. So don't worry, I'll execute the code. So we'll see all these three cases were during the execution. I'll write everything. I'll execute the code and I will show you. Okay. So deletion at the beginning. Consider this example. So this is the third case. That means having more than one node. So it can be 2 nodes, 3 nodes, 4 nodes, 5 nodes, 10, 100, etc. etc. Okay, not equal to 1, more than 1. So simply what we have to do, so we need to delete this one. Okay, consider this example. Delete this one. So if you delete this one, what will be the head? Head will be this one. So consider a temporary variable which is equal to head. Temporary is equal to head. That means assign the head value to the temporary, because so we need to traverse the head from one node to another node. So in order to maintain the problem perfect, so just assign one temporary variable. So head to some temporary variable. Now what we have to do, just move the head. So here after executing this one, the temp will also be pointing towards this node. So move the head towards the next one. So how the head can be moved to here? So head is equal to temp dot next. So temp dot next means 2000. So 2000 will be assigned to head. So obviously after executing this one, this head will be pointing here. Head will be pointing here, right? So now what we have to do, we need to discard this one. Okay, we need to discard this one. So, or before discarding, simply change the address of tail, because the tail will hold the address of first element. Now the first element will be head, right? So simply you can use tail.next. Tail.next means this value is equal to head. So what is the head value? 2000. So here 2000 will be replaced with 2000. So here the connection will be in this way. There is no connection for the first node. And here simply delete that one. Temp is equal to none. So obviously this will be deleted. This node will be deleted. This node will be deleted. So this is a small code to delete a node from the beginning. Okay, simply we are assigning head to temp and we are moving head to the next node because we are deleting the first node, right? So head is equal to temp.next, and then we need to change the tail because the tail will be holding the address of first element. Now after deleting the first element, the tail should hold the address of the second element, because second element becomes the first element. So that's why tail dot next is equal to head. So there will be a connection towards here. Then temp is equal to none, this element will be get deleted. Okay, the address will be deleted. Right. So that is the deletion at the beginning. Now we'll go with the deletion at end. So this is the head as usual, and this is the tail, and this will pointing at 1000. Now deletion at end. So this is also more than one node. So if it is more than one node, we need to delete the tail. Okay, we need to delete the tail. So we need to move the tail to previous node. Tail to previous node. So that means we can't change the tail to previous node in a simple way. So we need to traverse from first node to last but one node. First node to last but one node. Right? So for that purpose, we are just taking a temporary variable and assigning the head value to the temporary. So this will be the temporary. Now we need to traverse this temporary variable from first node to last but one. So how can we move this one? Right? So we can simply move with a instruction temp is equal to temp dot next. So in the first iteration, the temp value will be 1000. In the next, first iteration, temp is equal to temp dot next. So temp dot next. What is a temp dot next? So temp dot next is 2000. So here it will be 2000. Now the temp will be pointing towards the 2000. Okay. So temp will be at 2000. Next, again, temp is equal to temp dot next. Now temp is equal to 2000 to temp dot next means 3000. So now the temp will be at 3000. So we need to repeat that process until, see, you can observe temp dot next is 4000 and the tail is also 4000. So repeat these steps. So while temp dot next not equal to tail. Okay, so when we have to stop, whenever the temp dot next is equal to tail. So in this case, you can observe after two iterations, so temp dot next is 4000, which is equal to tail. So it will stop here. It will stop here. So we need to traverse the temporary variable from first node to last but one node. Okay, last but one node. So for that purpose, we are just writing here temp dot next until, repeat the process. So just move the temporary variable from one node to another node until the temp dot next not equal to tail. So whenever the temp dot next is equal to tail, simply stop the procedure. So stop the procedure. Now the temporary variable is in this position here and tail is here. So what we have to do, we need to remove the tail. We need to remove the tail. So simply you can see temp dot next is equal to, so instead of 4000, if you delete the last node, this will be the last node. So last node should hold the address of first node. So temp dot next is equal to head. Simply the 4000 will be removed and here there will be 1000. So this link will be disconnected here and it will be to the first node. Now what we have to do? We need to change the tail. Okay. So simply you can observe the tail is equal to none. So whatever the tail pointing to the node, that will be none. And assign the tail to temp. So tail is equal to temp. So now the tail will be pointing towards the temporary, that which is a last node. Right? So this is a small code need to follow in order to delete the element or a node from the beginning, at the beginning, ending. ending, right? Simply if you draw the diagrams, it will be very easy for you. So just traverse the temporary variable from first node to the last but one, and simply disconnect the link and connect it towards the first node. That's it. Very simple. Right. Next, the third one, which is nothing but a position. We want to delete from the position. Okay. See. Take the 1000, which will be last one. So it is 4000 to establish the link, and this is the head and this is the tail. Now we are deleting at particular position. So here we need to give a parameter that is a position from where we need to delete. So just give the position as a parameter here. Okay, one parameter, that is a position. So what we have to do, we need to traverse, similar to our deletion process at the end, from the ending, we need to traverse the temporary variable from first element towards the last but one. And also here we need to travel two different temporary variables. See, for example, if position is equal to 3, if position is equal to 3, so what's the third element? 1, 2, 3. So this element should be removed. If we want to delete this element, okay, so we need to modify these two nodes. We need to modify these two nodes. So here we need to give the address of this node, which is available in this node, right? So we need the control of these two nodes. That means if the position is 3, we should be having a control of node 2, node 3, node 2 and node 3, right? And if a position is equal to 4, if we want to delete this fourth element, the control should be on node 3 and node 4. Then only we can modify the things. Then only we can modify. See, for that purpose, simple. Take the two variables. One is a temporary one, which points to the head, and another one temporary 2, which points at head dot next. So simply you can observe this is temp 1 and this will be temp 2. Okay, temp 1 is head, temp 2 is head dot next, this one. So just move till a position -1, till position -1. So this move means simply you can go with the temp 1 is equal to a temp 1 dot next, temp 2 is equal to temp 2 dot next. So this should be repeated until position -1. So that means, so range of 1 to position -1. For example, if the position is equal to 3, if the position is equal to 3, so here it will be range of 1 to 3 minus 1, 2. 1 to 2. That means only one iteration will be there. One iteration. So initially you can observe temp 1 holds the 1000 and temp 2 holds the 2000. Now only one iteration. One iteration, temp 1 is equal to temp 1 dot next. That means temp 1 dot next means 2000. Temp 1 will be 2000 and temp 2 is equal to temp 2 dot next. That means 3000. After first iteration, the temporary variables in this way. So temp 1 points here and temp 2 points here. So what we have to see, if we want to delete the third one, we need a control of 2 and 3. So 2 T1, 3 T2. So simply after moving this one, what we have to do? So temp 1 dot next should be this value. That means the address of next node. So simply you can write, so temp 1 dot next is equal to temp 2 dot next. So temp1 dot next means 3000, right? So in that particular position, just give temp2 dot next. What's the temp2 dot next? 4000. So give 4000. So obviously this will be disconnected and it will be connected to this way. Okay, and again this connection is available, still available. So simply you can go with the temp2 is equal to none. So this element will be deleted. This element will be deleted and automatically the node will be connected. Right? So here one more case, that means if the position, if we are deleting the last element, what happens? The tail will also be deleted. So this is the code until we delete the element which is not equal to the last element. Okay, the position. If the position, now in this case, if the position is 4, what happens? So we are deleting the fourth. We are deleting the fourth position. But still the tail has been deleted, right? The tail should be moved to previous thing. So that's why we have to write the case. After this one, we need to write the case if temp2 dot next is equal to tail. Temp2 dot next is equal to tail. That means the last node is the tail. Okay. Then simply see, if the position is 4, this will be the temp1 and this will be the temp2. Okay. So simply what we have to do, see, temp1 dot next is equal to temp2 dot next. Temp1 dot next is equal to temp2 dot next. So simply 4000 will be replaced by 1000. So this link will be disconnected and directly this will be connected to the first one. But here the tail is pointing towards here, right? So tail should also be moved. So simply here we can write tail is equal to temp1. So obviously this tail becomes here. A small correction, right? So here we are just deleting at a particular position, the element at particular position. So here we need to take care about one more thing. If the position which we want to delete is the last element, we need to change the tail also. Right? So don't worry, don't get confused. I think there is a slight confusion regarding this deletion at the position. So I'll write the code, I will execute the code and I will explain you what exactly is being done. So it will be very clear for you. So just to draw the diagram and consider all the cases. So simply you can write this code. Now let's move on to the interpreter and let's execute these three cases. That means deletion at the ending, deletion at the beginning and deletion at the position, specific position. Let's move on to the interpreter.
Hello friends. So just now we have seen the theoretical part of how to delete a node from circular linked list. That is from the beginning, at the end, or from the specific position. So now we'll write the code and I will implement the same thing for the three categories. That means deletion from the beginning, ending and position. First let us see the code in the previous session which we have written. So this is the code for creation and display. I am not using any add functions, right? So already in our previous session we have discussed about how to insert the element or node at the beginning, ending and specific position, right? So here I am just giving directly, I am writing some small set of code. So I have taken for some 4 nodes and I am displaying these nodes. So now the circular linked list elements are these are the elements, right? Now we'll see. So first we'll see how to delete the element at the beginning. So for that we need to write a function similar to our display function in the CLL class file. Okay, right. So I'll write here. So define or a definition delete underscore begin. This is a function I'm writing. So as usual, the first parameter will be the self, and we are not taking any element because directly whatever the node which is available in the beginning, that means a starting, so that will be get deleted. So before that we have seen 2 different cases. One is if it is none,
so it should display that circular linked list is empty, and if it is having a single node, then obviously we need to delete that particular single node. And the third category, if it is having a more than one, then we have to write the code. So we'll write all these three cases, right? So first one, if it is an empty, right, that means self.head will be none. If it is there, just print no element or no node in circular linked list, right? And else, that means if there are nodes, so what about if it is having only single node? So we need to check that self.head is equal to self.tail. That means that particular node itself pointing towards the head and tail, right? So both will be pointing towards the same node. So that's why we are checking if the head and tail are equal. That implies it is the circular linked list is having only one node. So then simply you can put the head as none. That's all. So the node will be get deleted. There will be no link, right? And the third condition, that means if the self.head is not a none and our circular linked list is having more than one node, right? So these two cases are common for all the three categories. That means deletion at the beginning, deletion at the ending, and deletion at the position. So now the actual code will comes. So first let us take a temporary variable pointing towards the head, because so we are just moving the head to the next node. That means if we want to delete the first node, now the head should point to the second node. So we need to do some sort of operations, right? So in order to change the head, so we can take this head to one temporary variable. Now simply initialize the head to the temp.next. Okay, the temp is head and temp both pointing towards the same node, that means the first node. Now what we have to do, so the head should be moved to next node. So that means temp.next should be assigned to head. Now the self.head is pointing towards the second node. Now the first node is temp, so that should be none. That should be none. So temp is equal to none. Simply you can write temp is equal to none. And what about the tail? So tail pointing towards the last node, and the tail dot next will be the address of first node. But here we are deleting the first node. So now the head is at the second node. Now tail dot next must be self dot head. The head should be at the tail. Self dot head, right? Yes, that's it. Simple. So we are just moving the head towards the second node. We are keeping the none for the first node, and we are changing the address of at the tail node, right? At the last node, the last node should hold the address of first node. So that we are assigning. Now we'll check. So I'm executing this one. Oh yes, double is equal to. It's not a assignment operator. It's a comparison, right? Yes. So now we are having the linked list elements. Now I just delete L dot delete, because L is a object created for this particular class. So whatever the methods we are writing inside the class, that should be called with the help of this object. So L dot delete, we have written delete underscore begin. Yes, delete underscore begin, and let us display this one after deletion. Oh, there is some sort of error. Tail is not, yes. So here we need to write self.tail. Yes, see, you can observe. So 10 has been deleted. So after performing this begin, the 10 has been deleted. The 20 will be the first one. And see, you can observe the last element is having the address of the first node. Okay, the last element will be having the address of first node. So once again we'll apply the same thing. Now what should be deleted? 20 should be deleted. You can observe 30 and 40, and 40 is the last one, so that will be pointing towards the first node, that is a 30 again 40, only single element, only single node, and again if you apply, see, circular linked list is empty because everything has been deleted. Everything has been deleted, right? Hope you understood. Very simple thing. Very simple thing. Now we'll see deletion at end. Okay, so we have already seen everything theoretically on board. Just I am implementing this one. Delete underscore end. The one thing is self, and here also the same thing. So first we need to check for an empty node, empty circular linked list. If self dot head is none, that implies simply you can write it here. So no node in circular linked list, right? And after that, simply go with the else part. That means if it is having more than one node, I mean if it is having node, we need to check for a single node, right? If the circular linked list is having the single node, then we need to delete the same node. So I am verifying that self dot head is equal to self dot tail, right? And then if it is there, self dot head is equal to none. That means directly I am assigning a none value to the head, or else that means more than one value. Then we need to delete the last element. Okay, last node. So in order to delete the last node, we have to traverse the head from starting node to the node just before the tail, because we need to update the node which is just before the tail, because we are deleting the tail node, right? For that, just create a temporary variable, assign a head to the temporary variable, because we are just moving the we should not move the head. Okay, the head should point to always the first node, right? So that's why I am creating one temporary variable. Now we can move the temporary variable up to where? So while temp dot next not equal to self dot tail. That means you can observe, if the temp is pointing towards last but one node, that will be holding the address of tail, right? So last but one node is addressing, I mean is storing the address of last node, right? Tail node. So that means we need to repeat the steps until the temp dot next not equal to self dot tail. So what we have to do, until this becomes false, we need to move the temp value to temp dot next. We are doing nothing, just we are moving the temp value from next node, right? We are traversing the temp value, the temp the pointer from starting node to tail before node. Okay, node before the tail. Now after executing this loop, after completion of this particular loop, that the temp is pointing towards the node just before the tail. That means last but one node. Now what we have to change? So simply you can initialize self dot tail is equal to none, because we need to delete the last element. We need to delete the last element. And after removing this one, that means after executing this statement, there is no tail. There is no tail. What happens now? The temp is pointing towards the node just before the tail. So that means whatever the temp is there, that will be the tail. Okay. So self dot So self dot tail is equal to temp. Now what happens? So here the last but one node is still having the address of last node which has been deleted. What we have to do? The last node should store the address of the first one. So what we have to do here? So temp dot next, or simply you can go with the self dot tail dot next. Okay, temp dot next or self dot tail dot next should be head. That's it. That's it. So simply you can observe. See, here we are having the thing. So L dot delete underscore end and L dot display. You can observe. So 40 has been deleted because the 40 is the last node. So it will pointing towards the first node. So 40 will be deleted. So now 30 will be the last element, and again this 30 is pointing towards the first node. Once again, I'll just copy and I'll execute. See, now 30 has been deleted. 20 is the last node. 10 is the last node. And also 10 is the single node. Once again, I'm deleting. So circular linked list is empty. So there is no node. There is no node available in the circular linked list. So that is about deletion at the end. Now the third category, yes, we need to go with the another category. So that is deletion of an element from a particular position. So we need to take two arguments. One is a self default and another one is a position from where we need to remove the element. So first we are checking whether the linked list is empty or not. So if it is empty, self.head will be none. So I'm checking this condition. So simply you can print here. So no node in circular linked list, right? And also again we are also checking for one more condition. If position is equal to 1, so we need not write any sort of code. Simply you can call the function, so delete underscore begin, right? So if we want to delete the first position 1 node at position 1, that implies we are trying to delete the first node. And then the next one, if we are having a more than one node, so we need to take two variables here. One point out towards the head, that means the first element, and another one points towards second element. So second element address will be self.head.next. So we need to traverse these two nodes, temp1 and temp2, till the position. So for that we are just moving I in range from 1 to position -1, right? So just traverse both the nodes. Temp1 is equal to temp1.next and temp2 is equal to temp2.next. So after executing this loop, temp2 will be pointing towards the position, that means where we want to delete. If the position is 3, after completion of this for loop, temp2 points towards the third element and temp1 points towards the second element. And if the position is 5, okay, if you want to delete the fifth element from the circular linked list, the temp2, after executing this for loop, the temp2 is pointing towards the fifth node and temp1 points to the fourth node. So we want to delete the position, the element at the position, right? So temp2 should be deleted. So whatever the address available in temp2.next, that should be present in temp1.next. So temp1.next is equal to temp2.next. And here we need to check one more condition. If the temp2 points towards the last element, if it is a last element, we need to change the tail, right? For example, if you want to delete an element from the, position 5, and if the fifth position is itself is the last node, then by removing the fifth position, so one problem is there is no tail. Okay, so there is no address stored. We need to move that one. So that means we have to do self.tail. Sorry, we need to check the condition, right? If temp2 is equal to self.tail, okay, self.tail, then simply self.tail should be temp1 and temp2 will be none, so it will be deleted. Now let us check here. We need to check whether the code is working. Yes. So execute. There are four elements. So here we'll go with the delete underscore position of 3 or 2. Okay, 2 means 20. So delete underscore position. We are having this delete underscore position l dot delete underscore position. Delete. Oh, indentation is wrong. Yes. So here the indentation is wrong. So I'm sorry. So we need to change all the indentations. And here. So be careful while giving the indentations. So if one indentation is wrong, obviously we'll not get the code. Yes. Right. So execute. Let us take this display function. See, second element has been deleted, 20 has been deleted here. And if you go with the 3, see 30 has been deleted. And if you go with the 4, 40 has been deleted. Right? Afterwards, I'm just deleting at the beginning. Right? So after deleting the 40, I'm deleting beginning. Right? So this was happens. So I am first we are trying to delete the fourth node, which is a last element, right? Afterwards, again we are deleting the beginning element. So that means that 10 we are deleting. So after deleting the 10, 20 will be the first element, right? Now we'll delete the ending element. See, end means the end element is 20. Sorry, 30. 30 is the end element. So 30 will be deleted. Hope you understood this one, right? So here, so only one thing we need to remember: if the position which we are trying to delete is the last element, then we need to change the tail, because the tail will also has been deleted. Hello friends, welcome back to our channel. So in today's session, we'll discuss about one more operation in circular linked list using Python. So in our previous session, we have discussed about different operations like how to create the circular linked list, how to display the nodes of a circular linked list, how to insert a node either at the beginning or ending or at a particular specific position, and also we have seen the deletion operation. That means deleting a node from beginning or ending or from a specific position, right? So in this session we'll go with another operation, that is a searching. So how can we search a given element whether it is available in the given circular linked list or not? So circular linked list, and the operation is searching. So we know that searching means to search for the given element whether it is available in the circular linked list. So directly I am taking the nodes. So as we have discussed in our previous sessions, so if you draw the diagram, it would be very easy to write the code. Okay, so unless you draw the diagram, you need to think more, right? Imagine more. So in order to avoid that, simply we can draw the diagrams. So I am taking some 4 nodes. So the address 1000 for first node, 2000 for the second node, 3000 for the third node and 4000 for the fourth node. And let us take the address of next node. 2000 will be here, so that link will be established. 3000 places in the second node address, so a link, and again here will be a link, and this is the last node. It holds the address of the first node because it is a circular linked list. So there will be a link from last node to first node. And here, as usual, the head points to the first node and tail points to the last node. So this is the circular linked list which we are having. So I am not talking about insertion, deletion, and creation and display. Right? Directly I am using this searching operation. So I will post the links of all the remaining operations in the description. Just go through that and you can analyze that one. Right? Now what we have to do? So we need to take the element. Let us take an element need to be searched. So let us take the element 30. Element 30. So let us go with the last element. Let us go with the last element. Okay. Now what we have to do? So we need to travel from first node to last node by checking this 40 with all the data. So 40 should be compared with the 10, 40 should be compared with 20, 40 should be compared with 30, 40 should be compared with 40. Right? So for that we need to traverse the pointer from first node to last node. So that's why we are just, the first step is initialize the head to some temporary variable. So obviously one temporary variable will be pointing towards the head. Now we need to modify this one because the head should always point towards the first node. So we should not change the head. So in order to traverse this one, what we have to do? So we need to compare. If, okay, anything we can write. So element is equal to some temp dot data. So if it temp is 1000, temp dot data means 10, temp dot next means 2000. So I am writing here. So let us take temp means 1000. Temp dot data means 10. Temp dot next means 2000, right? So you need to know. So what is 1000? Okay, when we will get the 1000, when we will get a 10, when we will get the 2000. So if you want to get the 1000, you need to print temp. If it is a 10, temp dot data. If it is 2000, temp dot next. So you have to compare this element with this 10. So 10 means temp dot data. So if it is true, simply initialize the flag is equal to 1. So take the flag is equal to 0. Right? And simply you can break. That means you need not travel for remaining elements. And if it is false, what we have to do? We need to change the temp to temp dot next. For example, if you consider this one, where the element is 40, so 40 double is equal to temp dot data. That means 40 double is equal to 10. Okay, here temp is nothing but 1000. So element is 40. 40 is equal to 10. False. So if it is false, we have to move this temp towards the second element. So for that, we need to write temp is equal to temp dot next. And simply use a count value, because in order to get the position, count is equal to count plus 1. Okay, just give the count also. Okay, so in order to display the position, right? So this is just for displaying the position. So here you can observe, right? Temp dot next, count plus 1. So temp dot next, so immediately this temp will be pointing here. What happens now? Again we have to repeat the same process. Okay, so element 40 is equal to temp dot data. So 40 double is equal to 20. False. Temp is equal to temp dot next. again it moves here. Okay, again 30 double is equal to temp dot data. 40 double is equal to 30. Okay, 40 double is equal to 40. 30. Temp dot data means 30. So that is also false. Again, temp is equal to temp dot data. So temp dot next. So the temp value will be pointing here. Now we need to stop whenever the temp value reaches the tail. Okay, until that process. That means already we can see the temp has been reached from starting node to ending node. So we have to write the condition while temp dot next, temp is equal to tail. So you can observe here temp is 4000 and tail is 4000. That means both are same. Then you need to stop here. So you need to stop here, right? And one thing, remember, we have not compared this one. We have compared every element till the one element less than the tail. So it comes out of the loop, and here again check the condition. Okay, if check the same condition, element is equal to temp dot data, because after completion of this loop, the temp value points at the tail. So here it becomes not equal to. Whenever it is equal to, the comparison is not done. Okay, the comparison is not done. So up to here the comparison is done, but up to here, whenever the comparison is not done up to here, the search is not successful. We have to compare the element with the last node also. So for that purpose, after coming out from the while, again check for this one, element is equal to temp dot data. If it is yes, so go with the flag is equal to 1. Flag is equal to 1. So that's it. So finally, based upon the flag value, if flag is equal to 1, so print found, element found, else print not found. That's it. Very simple. So we are traveling from starting node towards the end node. So for example, if it is 30, or let us take a 20, right? So initially the temp value is pointing towards the head. So after executing this first one, right? Now while temp not equal to tail, what is the temp value? 1000. What's the tail value? 4000. Not equal. True. So it enters into the loop. Element is equal to temp dot data. Element is 20. 20 is equal to temp dot data 10. Not true. So temp is equal to temp dot next. So temp is equal to temp dot next means 2000. Now the temp value is 2000. So the temp points here, and again it will repeat the loop. Okay, it will repeat the loop. So again you can observe temp. Here the temp is 2000, not equal to tail, not equal to 4000. True. Again the control enters into the loop. Element 20 double is equal to temp dot data. 20. Yes, true. Flag 1 break. So you know that break means automatically it will come out from the loop. Okay, if it is break, automatically it will come out from the loop, and simply, so you can observe here element is equal to temp dot data, right? True. Flag 1, it comes here and found. So it's a very clear, and if you draw the diagram, the logic will be very clear, right? So hope you understood. I will execute the code in the interpreter. So let's move on to the interpreter.
Hello friends, so just now we have seen the theoretical part of search function. So we'll write the search function here. So def search, and just one parameter, that is a self default parameter, and go in prompt for the input. So which element we need to search. So just give the input function. So enter element to be searched in circular linked list. Right. So after getting the X, just start the code. So temp is equal to self dot head. So initialize a head to temp, and initialize a count is equal to 0, and initialize some flag is equal to 0. And now travel from starting node to ending node until the temp not equal to tail. Okay, so what we have to do, we have to compare the x value with temp dot data. That means every element. If it is true, simply initialize flag is equal to 1 and break. So it will come out from the loop. Else simply just shift temp to temp dot next. That means next element. And also count is equal to count plus 1. Right? And come out from the loop, and now check if x is equal to temp dot data, then initialize the flag is equal to 1, right? Then, or simply you can write else. Okay, else x is equal to flag temp dot data, it's a flag is equal to 1, and here you can write if compare this one, flag is equal to 1. That implies, so in any case, so in this case, if it is a flag is equal to 1, the element is found. In this case, the flag is equal to 1, the element is found. So if flag is equal to 1, simply you can say x is found at position count plus 1, right? Else print x is not found in circular linked list. So here we have taken a count plus 1 because here we have initialized a count to 0, so obviously it will be 1. Okay, if for example, if the first element is a successful element, that means the search element is the first node, so if the count is 0, so the count never be incremented, so here it will come break, and here we will get 0 as a position, right? So that's why here we have initialized it with 0, so we have to increment it. So if the element is found, the element position will be count plus 1. Okay, see, you can observe L dot search, we can write here, oh, invalid syntax. Okay, yes, no problem. Else here we'll write if x is equal to temp dot data, then automatically we'll get it, right? Yes. So let us take some 20. So 20 is found at a position 2. So you can observe 20 is in position 2. And for example 10. So 10 is found at a position 1. So let us take this minus. So a little bit confusion. So 10. So 10 is found at position 1. And let us take a 30. 30 is found at position 3. And 40. 40 is position 4. And 50. 50 is at position 5. And 60. So 60 is not found in circle linked list, right? So hope you understood. So if it is flag is equal to 1, automatically it will come out from the loop, and directly it will check for the next one. Okay, so if it is not true, automatically it will check for the last element. So this comparison is for last element. Okay, if the search element is last, then this comparison will be done. This comparison will be successful. Right? So in Python we can write a else part in iterative statements too. Right? So hope you understood this one. So once again I'll execute. So if you want to get a 40, so 40 is found at position 4, 1, 2, 3, 4, fourth position. Right? And it's a 50, so fifth position. Right? So hope you understood this one.
Hello friends, welcome back to our channel. In today's session, we'll discuss about one more data structure, that is a stack. So this is also a linear data structure, and we'll see the implementation of the stack using Python. So far we have discussed about the single linked list, double linked list, and circular linked list. Now we'll see the stack. So we know that a stack is also known as last in, first out. Last in, first out. So whatever the element which has been inserted last, that will be removed first. Okay. So here the stack will be represented in this way, right? So the example for this stack is arranging coins one by one. Okay, arranging the coins one by one, so that we can remove the topmost coin first rather than last coin, right? So if you insert some element, that will be inserted here, and the next element should be inserted at the top of this element. So 20, so 30, so 40. So here this is the top, this is the top. So the main operations of stack are, so one is a push operation and another one is a pop operation. Push and pop. So push operation means insertion and pop operation means deletion. Deletion, right? So the insertion will be done at top. The insertion will be done at top. So if the stack is having these 4 elements, if you are trying to insert one more element, that element will be inserted here itself, not anywhere, right? So at the top of the stack. And deletion, this is also done at top. So that's why here we call it as a last in, first out. So last element which has been inserted should be removed first, right? So here we can implement this stack. So here the implementation. So here implementation can be done in 2 ways. One is using a list, another one using linked list. Linked list. So we can implement this stack using both the ways, by using this list or by using the linked list. So list we have discussed in our earlier sessions, right? So I'll post the link in the description. So we know that list will be in the form of a group of elements enclosed in square braces, and we know that there are number of functions available for the list. So we'll make use of those functions in order to perform this insertion and deletion operation. So coming to this insertion operation, here 2 cases. One is the case 1. Stack is empty. We need to find whether the stack is empty. So if the stack is empty, simply you can use the append function. So it will append the value to the stack. So we'll take some list, empty list, and we will append this element to the list. And case 2, not empty. Stack is not empty, and if you use the append function, automatically it will add after the given element. For example, if you append 10, so the 10 will be appended to the list, and immediately after that, if you append 20, then 20 will be inserted here, but in the stack the 20 should be inserted at the top, not the end. Okay, so here append function will append the element at the end of the list, but here we need to append the value at the beginning. So in order to insert the value at the beginning, not the end, we are going to use an insert function. So we know that insert function will take 2 arguments. One is the position and the element. So here give the position 0, which means the starting index, right? 0 and element. So that automatically the element will be inserted on the 0th element, 0th index. So simple code for insertion. So actually the stack is very simple using the list concept. There is no complicated, no complex code. So very simple, two cases. One is stack is empty, just give the append. If stack is not empty, just use the insert method, so that mainly we are using this insert method to insert the element at the beginning, not the end. Append will add the element at the end. Coming to the deletion process. So here we are having a lot of things, right? Lot of functions. We can use a remove function, del function, okay, pop function, right? So here a pop function will remove the last element. That means 20. But here the pop function should delete the element, the pop operation should delete the element from the top. That means the top of the element should be deleted. So for that purpose, we can use a remove function. Okay, we can use a remove function, or simply you can use a del function. Del list of, simply use a 0. Automatically the first value, that the value which resides at index 0 will be get deleted, that is the top. So always we need to increment this top. So this is just only one statement. We are deleting by using the del function. If you know the element, then we can use a remove function. If you know the element, you can use a remove function. If you know the index, you can remove this one. If you want to delete the end, you can go with the pop, or simply you can also use a pop of 0, which will remove the element available in this 0 index. So you can use either del function or pop function in the deletion operation. So whatever we are doing here, the top should be updated. So either insertion or deletion, okay, push operation or pop operation. So top should be changed. Okay, top should be changed. Simple. This is also not complex. So you can simply assign top is equal to some list of 0. Obviously the list of 0 is the first element. So the first element will be assigned to the top itself. And coming to the display function. Display. Okay, display means just we need to display all the elements of the stack. So display, in order to display, we can use the iterative statements. So for element in list, simply print element. That's it. All the elements of the list, that means a stack, will be printed on the screen. So it's a very simple implementing the stack using list. So this is using list. Stack using list concept. Right? So only two operations, push operation and a pop operation. Push means insertion, pop means deletion. Right? So hope you understood. So let's stop here. Now we will move on to the interpreter. I will show the execution of this stack, the complete stack implementation using list. So let's move on to the interpreter.
Hello friends, so just now we have seen the theoretical part of stack. So we have seen two different operations, push and pop, and how we can insert the element and how we can delete the element. Now we will execute the code, right? So first let us take one list named stack. Stack is equal to, so we can use a list function so that it will create an empty list, and then iterate the loop, because we'll give the push operations and pop operations, right, multiple times. So I'll go with a while 1, so which is an infinite loop, so we can break at particular moment, right, break the loop. So here I'll give the menu for all the operations. So here I'll give enter the option from below. /n gives next line, so 1 for push operation
slash n and 2 for pop operation. I'm just giving the menu, right? So we can enter 1 for push operation and 2 for pop operation, and after that we can go with the third one, 3 for display. Okay, and next you can enter any number, right? Enter any key to exit, any two to exit, right? So this is a menu, just we are displaying the menu. Okay, now based upon this input we have to read the input. So str, I'll go with the input function. So whatever the operation we required, that will be read here. And now if str is equal to 1, that means if 1 is entered, okay, 1 is entered by the user, so I'll go with the print push operation and call the function, right? Push function, call the function. We need to write the function definition later, right? So then else, sorry, elif, again we need to check whether str is equal to 2. That implies, so 2 for pop operation. So pop operation, that means a deletion operation. Again go with the pop function. Next, elif str is equal to 3, then display operation. So use a display function. So we need to write these three functions. Else, that means if user enters any one other than this 1, 2, 3, or simply you can print exit from program and simply you can break. Okay, automatically it will come out from the while. That's it. So this is the menu we can get. Now we need to write a different operation, that means a push, pop and display functions, and we know that in Python we have to write all the functions above the main. That means first we need to start with that one, def push operation. I'll go with the push operation. Push means just insertion. So insertion, we need to take the element first. So n is equal to end input. We need to display, we need to display thing. So enter the element to be inserted into stack, right? So it will prompt for the user to enter the element. So whenever the user enters into n, so first we need to check. So here insertion can be done in two ways, in two different cases. One is the append method, another one is the insert function. So append function should be used only if the stack is empty, because append function will always insert the element at the end of the stack, right, end of the list. So we need to check if length of a stack is equal to 0, then we can use append function, right? So stack dot append of n. Else, that means the second case. So you can go with the stack dot insert function. So 0th index, insert the element in 0th index, and what is the element here? 0, and after that just print the message that element is inserted into stack, right? Just that's it. Okay, so if the element, if the stack is empty, so here we have taken stack, yes, stack as a list. So if the stack is empty, automatically we are using append function, or else you can simply use a insert function itself, no problem. Okay, you can use a insert function itself. And here then go with the pop function. That means we need to delete the element from the stack. So here also we have to check for two cases. One is if the stack is empty, it should display the stack is empty, because we can't delete any element from the empty stack, right? So if length of a stack, is equal to 0, that implies stack is empty. Else, that means if there are more than one element, simply display the element which has been deleted. So what is deleted? Stack of 0. That means the 0th index. That means the topmost element will be deleted here, right? So stack of 0 is deleted from stack. That means the first element, which element has been deleted, that we are printing, and we have to write the operation here. So that is del stack of 0. That means a stack of 0th element will be deleted. Okay, that's it. Two cases. One is a stack is empty, otherwise we can use a del or pop function, pop of 0. Okay, or you can use a pop of 0. So here you can use pop of 0, right? So any statement is no problem. That is all about our pop operation. Now display. So def display operation, that's also very simple. So we can use a iterative statement. So here also we need to check two cases. If the stack is 0, the length of the stack is 0, the stack is empty. So I'll copy the same thing here. And else, that means if the stack contains more than one element, more than 0, that means at least one element, we need to print the elements. So I will display this thing. So elements of a stack are, so for use a iterative statement for element in stack, so just a print the element, right? So print element. So after that, just display the top of the element. Print top of the stack is, so simply it is nothing but 0th index, stack of 0, right? Okay, so this is a display function, simple one. So that's all. This is a implementation of stack using a list. So you can execute this one. So first it will display all the options. So if user enters 1, it will go with the push operation. It will go with the insertion. And if the user enters 2, the pop operation will be get executed. If the user enters 3, display function is executed. And if for any other number other than 1, 2, 3, it will break the loop. It will come out from the loop. Okay. Right, see, execute. So see, you can observe the complete menu, the operations. So I'll go with the 1 push operation. See, 1 push operation, enter the element to be inserted into stack. I'll go with the 10. So again, see, 10 is inserted into stack. Okay, 10 is inserted into stack, and then again enter the option from below. So you can display the stack value, or you can insert more number of elements. I'll go with a 1. Again, I want to insert one more element. So again, enter the element into stack. So 20. Now 20 is inserted into stack. You can observe here. Again, enter the option from below. So go with the 3 display function. Display. So you can observe the element of stack are 20, 10. Right. So first inserted element is 10, and the second inserted element is 20. So 20 is at the top. So you can observe here, top of the stack is 20. That means last inserted can be removed first. So if you want to delete this one, go with the second operation pop. So you can observe pop operation, 20 is deleted from stack. So what is the top value? 20. So 20 will be deleted from the stack. And again, if you display this one, so you can observe the elements of stack are 10, and the top of the stack is also 10. And again, if you apply the second operation, so again 10 is deleted from the stack, and if you want to display, so it will give stack is empty. Display operation, the stack is empty because stack doesn't have any elements, right? And if you give 4, automatically it will exit from the program. It will exit from the program. So in order to give some space, so you can use print. Okay, so that right? So if you go with a 1, so I'll go with the 10, enter the option below. 10 is inserted into a stack, enter the option below. So I'll go with the 1 and 20, 1, 30, 1, 40, 1, 50. So I have inserted totally 5 elements, 10, 20, 30, 40, 50. But if you display the elements will be arranged in the last in first. I mean last inserted will be at the top most. That means 50, 40, 30, 20, 10. So you can observe 3. See, display 50, 40, 30, 20, 10, and top of the stack is 50, right? And go with the second pop operation. 50 is deleted from the stack. Again pop operation, 40 is deleted from the stack, and display, then it will be 30, 20, 10, 10, and the top of the stack is 30, right? And in the display function also you can use a print so that it will be good, right? So hope you understood this one. So this is the different operations of stack, push, pop, and display functions, right? So very simple. We are using the just a append function and insert function, and here we are using some delete and pop. That's it. So here we are using a list concept to implement the stack. Using a list. So in our previous session, we have discussed about the stack implementation. So either stack or queue that can be implemented in 2 ways. One is by using the list concept, another one is by using the linked list concept. So now we will see the queue implementation using list concept. Using list. Right? So we have discussed about this list concept in our previous sessions. So I'll post the link in the description. We'll just go through that one. So list is a sequence of elements of different data types enclosed in a square braces, and this list is having a different methods in order to insert the elements, in order to delete the elements. We are having different methods and functions. All the things we have covered in the previous sessions. So by using that concept, we have to implement the queue. First, we have to know what is a queue and what are the different operations that can be performed on a queue, right? So queue is called as a first in, first out. First in, first out. Okay. So the best example is standing in a queue for a ticket reservation. Standing in a queue to step into the bus or a train. So who stood first, the person will be coming out. Right? So the first in, first out. So standing in a line, the person standing in a line comes with comes as an example for this particular queue. So here the operations of this queue, the first one we call it as a NQ. NQ. So NQ means insertion. NQ means insertion. And one more operation, DQ. DQ. So DQ means deletion. Deletion. So here the insertion will be done on rear end. Rear end. Deletion will be done on front end. So here we call it as a first in, first out. So whatever the element is inserted first, that should be comes out first. So that's why front end is a deletion, rear end is the insertion. Example, so this is the representation for a queue. So if you insert a 10 first, the 10 will be here, and the next 20, next 30, next 40, 50. So this will be the front because 10 is inserted first among all these elements, and this will be the rear. So whatever the element we are inserting, that will be added in this place. So here the insertion will be done, and from here the deletion will be done. So if you want to delete an element, 10 should be deleted first because 10 was inserted first among all these elements. After 10, the front will be pointing towards 20. So if you are deleting the element, 20 should be deleted after deletion of 10, right? So these are the two different operations that can be performed on queue. That means insertion and deletion. So here we are using the list concept. So for insertion, we have one method called append method. So append method will insert the element at the end. Okay, append method will insert the element at the end of the list. So directly we can use this append to insert the elements. And in order to for the deletion, we can use del command of 0th index. Del command of 0th index, or you can also use a pop command with the index 0. So index 0 means this one. Okay, index 0 means the first element. So in the list, the first element will be get deleted. And pop 1, pop 0 means here also it will delete the element. Right? So here, before inserting the element, we need to check whether there are elements or not. Okay, whether there are elements or not. So if there are no elements, we can simply say that, so if friend, or simply you can check the length of q is equal to 0, print q is empty. So simply, if the length of q is equal to 0, that means no elements are there in the queue. That implies, so q is empty. If there are a number of elements, simply you can use a for loop, okay, for element in list, that means a queue. So you can print the element here. So automatically, whatever the elements that are available in the queue, that will be printed on the screen. So that will write in the function, right? Display function. And also the friend should be point towards 0th index, and red should be pointed the last element. So last element index, we know that in the list concept, in the sequence data structures, so the last element index value can be represented as a -1. So here we are having a provision of working with the positive indexes and the negative indexes. So positive index means from the first element, negative index means from the last element. So always -1 points at the last element, right? Index of the last element. So automatically rare should be -1. Rare should be pointing towards the index -1. That means it will point to the last element, right? So just we are applying all these things, and we can write down the menu as we have discussed in our previous stack. We have implemented the previous data structure, that is a stack. So we have taken different options, like 1 is for push, and 2 is for pop, and 3 is for display, and 4 is for exit, right? So like this we have created one menu, and if the user prompts for 1, so it will ask the user to insert the element, and if the user enters the pop function, automatically the control will delete the first element, because the deletion will be done from the front itself, right? So deletion will be done, and 3, as usual, it will display all the elements of the queue, and 4 for exit from the program, right? So similarly here also we are writing the menu. So 1 is for NQ, so which is for insertion, 2 is for DQ, which is from deletion, 3 for display, in order to display all the elements of a queue, and 4 for exit, to exit from the program. Now let's stop here. Hope you understood these operations NQ and DQ, that means insertion and deletion, right? So we'll move on to the interpreter, and I will show you the execution, right? So let's move on to the computer. Hello friends, so just now we have seen the theoretical part of queue using list concept. So now I'll execute the program. So first let us write the menu as we have discussed just now. So first I'll declare a queue with a empty list. So that means a list function. And now, so I'll repeat the loop. Okay, so while 1 or while 2 you can use anything, and just print the menu, enter the option from below, right? So /n, which gives the next line, and 1 for enq operation, and next second one for dq operation, next third one for display, and fourth one exit. Right, now we need to take the input. So let us take it as option, right? Option is equal to, so int of input, so it will prompt for the input, right? So now we have to compare. So if option is equal to 1, so we need to call the enq operation, right? And call the function, simply use a function call enq. It's a function call, right? And again, if one more condition, if option is equal to 2, what we have to do? So we have to call dq operation, and call the function dq, and we need to write the function definitions, right? So first I am writing all the menu, and again if option is equal to 3, simply print display, and function, write down function display, else, that means any other number other than 1, 2, 3, simply you can go with a break, right? Now we need to write the functions. Okay, we need to write the functions. See, first let us start with the enq operation. So def enq, right? What's the enq operation? So we need to read, that means enq means a insert operation. So we need to insert the element. First we have to read the element, then we have to insert. So n is equal to, so int of input, enter the element to be inserted into queue. So automatically it will prompt for the input. So once it was done, so call the function append function. In order to insert, simply you can use a append function, right? So append function, that is a q dot append of n. This append function always appends the value at the end of the list. Next, deletion, dq, that means a deletion. So here the deletion can be done only if the queue is having any elements. So here, before applying the deletion, we need to check whether the queue is empty or not empty, right? For that purpose, we can go with the if length of queue is equal to 0. That implies, so you can write it here, queue is empty, right? So once again, just give this one print to give extra line, and here, sorry, else, that means if the length is not equal to 0, at least it is having any one. Okay, at least it is having any one operation, so any one element. Simply what we have to do, we have to delete the first one. We have to delete the first one. So first one means the index is 0. Okay, index is 0. So print, let us take a q of 0 is the element deleted from q. Deleted from q. Now we need to use a functions like a pop function or a del command. So go with a del command, del q of 0. Automatically it will be deleted, and simply use a print so that an extra line will be printed, right? That's only. So here we are checking two cases. One is if the length is 0, we are just telling q is empty. If it is not 0, just deleting the 0th index element, because the deletion will be done from the front end itself. Okay, now write on the display, the third one. So display function. So in the display, just here also we need to check the two cases. One is if the q is empty, just we want to display the statement that q is empty, right? So q is equal to 0, print q is empty, else what we have to do, we need to print each and every element by using some iteration, right? So because it's a list, so elements of the queue are, go with the iteration statements. So for element in queue, print element, right? And also you can use here end is equal to so and so, and then print the front end rail, right? Print front of the queue is, what is the front? Q of 0. Print rear of the queue is q of 1, sorry, minus 1, right? Again here also you just go with the empty print so that it will be clear, right? And here also go with the empty print. Yes, so you can execute. So the options are below. So if you want to insert the element, now there are no elements, right? So if you try to display the one, so we'll get, see, q is empty. Okay, we are getting q is empty. So here you can use this one. See, just wait. Yes. See, 1, enter the element to be inserted into queue. I'll go with the 10, and again it will it is asking for operations. Again I will go with the first. I need to insert 20. Again 1, I want to insert 30. Again 1, I want to insert 40. Now just go with the 3 display. So you can observe. So elements of the queue are 10, 20, 30, 40. Front of the queue is 10 and rear of the queue is 40. So here you can use a /n so that yes. So here you can observe. So 1, so I'll go with the 10, 1, I'll go with the 20, 1, I'll go with the 30, 1, I'll go with the 40, and now 3. So elements of the queue are, so 10, 20, 30, 40. The front of the queue is 10 and the rear of the queue is 40. Now if you go with the 2, what we have to do, the deletion should be done from the front end, right? So DQ operation. So 10 is the element deleted from queue. So if from the given queue, 10 is the element deleted from a queue, and now if you display here, you can observe the elements of the queue are 20, 30, 40. Now front of the queue is 20 and rear of the queue is 40. Right, and if you are inserting one more element 50, the insertion will be done from at the rear end. So you can observe 50 and display, you can see 20, 30, 40 and 50. Insertion is done on the rear end. Now rear of the queue is 50. That means it points towards the last element, and front is 20. So if you go with the DQ, the first element will be deleted, that is 20 is deleted from the queue. That means the front end, from front the queue, the element will be deleted, right? And see, now if you display the list, I mean display the queue, 30, 40, 50 are the elements available in the queue. 30 will be the front and 50 will be the rear. And if you want to stop the program, just go with the 4, automatically it will exit from the program. It will exit from the program, right? So hope you understood this implementation of queue using list in Python. So this is a very simple and queue using a list concept. And now we are going to discuss about the implementation of stack using linked list. Stack using linked list. So we know the concept of linked list, right? So there will be a node, so which consists of two fields. One is the data and another one is the address of the next node. So there will be a link between one node and another node. So here we need to create a one class called a node. Okay, so here we need to initialize the node, so with a constructor. So in Python, so the values for a class will be initialized using the constructor. So def, I go with the init method, okay, and self. So the one parameter will be the self, and obviously the next one is the data, some data. So then it will be self dot data. Two terms will be there, self dot data, which is nothing but x, and self dot next is equal to none. That means, so whenever a node is created, automatically, so two fields will be there. So x will be stored here and none will be stored here, right? So x will be stored here and none will be stored here, right? After that, we need to create a class for stack, right? So class for stack. So here, what are the default values? What are the initialized values? That is nothing but a top, right? So in stack, there will be a top which points towards the first node. That means the first element. So here again, we can go with the constructor self, and here you need not go with any other values. So simply you can write self dot top is equal to none. That means we are creating a top, okay, which is by default it will be none, right? So initially there will be no nodes in our stack. So in that case, the self dot top will be none. That means top doesn't point towards any other element. So if one element is being inserted into a stack, immediately we need to change the top. Okay, so this is the basic thing, and we know the operations of a stack. So the operations of a stack are push and pop operations. So push means insertion at end. Okay, so being the stack, so always the insertion should be insertion should be at beginning, right? Beginning. Insertion should be always at a beginning, right? And pop means deletion. Deletion, this is also performs from beginning. So the insertion and deletion will be performed from beginning itself. That means the top of the element will be deleted, right? So we need to write these operations inside this class, so that we need to create one object for this class in order to call the operations of a stack. So we'll see majorly three operations. One is a push, pop and display. So we need to display the elements of a stack, right? So first we will see the push, insertion, right? So I'm writing here the insertion. So before inserting, two cases, okay, so case 1, stack is empty, stack is empty. So if the stack is empty, that implies top is none. Okay, the top is none. That means some top value is none, right? If the top is none, that implies top is not pointing towards any of the node. That implies the stack is empty. In such a case, what we have to do, we need to insert an element, right? So let it be new is equal to some node of 10, right? So after executing this statement, so one node will be created with a 10 and none, right? 10 and none. That means what happens here? So whenever this executes this one, so now we need to initialize this node because this is only one node. So we have to point the top to this particular node. So that's why we have to go with self.top is equal to new. So automatically the new is pointing the top, right? Top is assigned to new. Top is assigned to new. And by default, the next value is done, or else you can also write it here. So top.next is equal to none. So this is the first case, wherever the stack is empty, right? Now, second case, see, if our stack is having one element, so let it be 10 and this is none, right? So here case 2, so stack is not empty. Stack is not empty now. So stack is having one element. Now in such case we have to add one more element. That means we have to apply the push operation. So here let us take some new is equal to some node of 20, right? Node of 20. So immediately already the stack is having this one, right? Already the stack is having 10 and none. So whenever this statement executes, one more node will be created, right? So this is a 20 and this is none. See, this is a new node. This is a new node and this is a top. Okay, according to the first case, this is a top and this is a new node after executing this one, 20. Now we need to establish a connection between new and top, right? So what happens here? New.next is equal to top. See, new.next means this place is equal to top. So whatever the value at top, that address will be stored here. See, right, 1000. So immediately a link will be established between this node and this node. Okay, link will be established between this node and this node. Now what happens? Top should be assigned to first one. So top is equal to new. So obviously this top will be pointing towards this one. That's it. A simple code. So whenever you insert one more element, new is equal to node of 30. Again, see, one more link will be, one more node is created, 30, and initially it's none. So see, new dot next is equal to top. So this is a new. So new dot next is equal to top. Top means this one. So let it be, the address is 2000. So this will be replaced with 2000. Immediately link will be established and top is equal to new. So now the top will be assigned to here, right? So like this we can add multiple elements one by one, right? So in all these cases the element is being added at the beginning itself because it's a stack. So stack means all the insertions and deletions should be done at the top. Okay, so always the top is nothing but top dot data. This will be top. Now, so I think you understood about this push operation, insertion. Now you go with the pop, that means a deletion operation. See, so very simple. If you draw the diagram, it would be very easy for you to write the code. You need not mug up the code, right? So coming to the deletion. So here case 1, stack is empty. So if the stack is empty, what we have to do? Right? If the stack is empty, what we have to do? So simply we have to print it. So what's the case? So if top is none, simply you can print stack is empty. Simple. And case 2, stack is having only single element. Stack with single element, that means only one element. Let it be ten and none, and this is a top. Okay, now what we have to do, we need to remove this one. So just you can use, see, top is equal to none. Okay, then we need to use a top is equal to none only when the stack is having only one element. That means if top dot next is none. So if our stack is having only one element, that implies the top dot next will be none. So if the top dot next is none, that implies top is pointing towards only one node. So in such case, simply we can assign top to none. Okay, sorry, none to top. So obviously it will be removed. So this is the second case. That means a stack with a single element, only the single element, right? So if top dot next is none, simply you can assign none to top. Now case 3. Stack with more than one element. Let us take here. So let it be 20 and 1000. So a link will be established here. Let us take one more node, 10 and none, and this is the top. Now we need to remove. That means a pop operation. Pop operation means removing the element which is in top. So we need to remove this one, so that we have to change the top to next element. For this, just assign some temporary variable. Okay, assign the top to the temporary variable, and now you can disconnect the connection, right? Disconnect the connection. So after executing this statement, so temp is also pointing towards the first node. So simply you can write temp dot next. See, top is equal to temp dot next. Top is equal to temp dot next. So automatically the temp dot next. What's the temp dot next? Temp dot next is 1000. So which is the address of this one? So immediately the top will be pointing towards here. Top will be pointing towards here. So simply here you can write temp is equal to none. So automatically this node will be deleted and only one element will be there. So this is a simple code for deleting and the deletion of an element where the stack with more than one element. Simple. Temp is equal to top and top is equal to temp dot next and temp is equal to none. So automatically the first node will be removed and the top will be assigned to the second node, because after deleting the first node, then the first node will be second node, right? So the second node becomes the top of the stack. right? So here in this deletion, 3 cases. One is stack is empty, stack with single element, and stack with more than one element. And the next one, the display operation. So we have successfully done these two operations. So push pop, that means insertions and deletions. Now we need to print the elements of a stack. We need to print the elements of a stack, which is nothing but a display function. So here the display function, so case 1, stack is empty. So if the stack is empty, we need to print it. So when we can say if a top dot next is not, sorry, top is none. Okay, top is none. That implies empty stack. Empty stack. So otherwise, what we have to do? Otherwise, case 2. That means the stack is having a more than elements. Okay, more number of elements. So simply see here. I'll write the notes so that it would be easy for us to write the code. Okay, so without drawing the notes, it would be difficult for me to write the code. 30, 20 and 10, and this is a 2000, so this will be the 2000, and this will be the 3000, and this will be the 1000, and here it is 1000, so link will be established, and this will be none. Okay, and this is a top. What we have to do? So now we are having a more number of elements in the stack, so we need to print each and every element. So for that purpose, we need to print. So we need to traverse this top from first node to the last node. Okay, so we should not move the top, but we have to travel from first node to the last node because we have to display each and every node, right? For that purpose, just assign top to the temporary variable. Now you can move the temp from first node to the last node. The top will be remain same. So here, see what we have to do. So we have to print temp.data. Temp.data. Okay, we need to print temp.data, and immediately after printing temp.data, we have to move this one to the next node. So what is the statement? Temp is equal to temp.next. Now initially the temp is equal to 3000. Immediately temp.data means, see, temp.data means 30 will be printed. Immediately temp is equal to temp.next. So temp is equal to temp.next, temp is 2000. Now temp value is 2000. So immediately 20 is printed. Again temp is equal to temp.data. So temp is equal to temp.data means again 1000, right? 1000. Again a data will be printed. Temp. Next, temp is equal to temp.data. So obviously, sorry, temp is equal to temp.next. Temp.next means none, right? Here temp.next is none. That means we need to repeat this process. So while temp, immediately whenever the temp is equal to none, automatically it will be stopped. Okay, it will be stopped. So we need to write down this code in order to display each and every element of the stack. Here we are checking only two conditions. So one is stack is empty. Another one is just if stack contains more than one element, just we are printing all the elements one by one by using some iterative statements. Right? So hope you understood this one. The push operation, pop operation and display operation. So push pop, here the stack means, so both the insertion and deletion will be performed on top of the stack itself, top of the stack, right? So that's why here we call it as a last in, first out. The last inserted element will be come out first, right? So hope you understood. So let's stop here. Now we can move on to the computer. I'll show you the implementation of the stack using linked list. So let's move on to the system. Hello friends. So just now we have seen the theoretical part of implementing the stack using linked list. Now we'll write the code. So first let us write down the options for this stack operation. So write down the code. So while one, that means a infinite loop. So write down the options here first. So enter the option from below. I'll maximize this one. Yes, okay, right. Now let us write the options. So print. So one for push operation /n, that means it will display in the second line. So that is a second option, so which is pop operation. And next, a new line, go with the third option, which is a display and /n, and the next one, fourth, exit. Right now we need to read the option. So option is equal to, so int of input, so it will prompt for the option. Now we need to write down. So if option is equal to 1, simply print what's the option here, push operation. So simply use some dots so that the display will be very clear. So call the function push operation. So we need to write down the class for stack. So all these operations should be called with the help of stack itself. So stack. So S is the object for stack class. So we need to call this push function with s dot push. Similarly, elif option is equal to 2, then it is a pop operation. And here also you just give the lines and call the function pop and elif, and again the third option is equal to 3, which is nothing but a display. So just give the title display and give the lines, call the function s dot display. So we need to write all these functions in the stack class, and else simply you can use a break so that it will exit the program. Now what we have to do, so we need to write all the functions here. So before writing the functions, we need to initialize the node, right, class node, so which will be having a constructor $init self comma x, which is a node. See, self dot x data is equal to x, and self dot next. So every node is having two fields, data and next. So data is x and next is none. Once again, class stack, we need to create a stack class. So there again give the constructor. So with the top, we need to use a top, right? So about this, why we are using self, why we are using init method, everything I have covered in our previous sessions. So that means object oriented concepts in the where what is a constructor and everything I have covered. So I will post the link in the description, so just go through so that you will be understanding everything, right? So self dot top is equal to none. Initially there will be no node, so that's why none. Now we need to write down the functions. First one is a push function. So push, and here we need to read the input. So x is equal to int of input, enter element to be inserted into stack. So now x is a element, just create a node for that one. So node class, pass the parameter x here, so that a node will be created with the data with given x, and next value is none. Now one thing, so where we have to insert, So we have to insert, uh, I mean, here two cases. One is if the stack is empty, the same node, that means whatever the node we are creating, that will be the top, or else we have to insert the node in the beginning itself. Right now we have to check whether the stack is empty. So if self dot top is none, that means the top is not assigned to any other element. So then simply you can use, so self dot top is equal to new, and again simply the new dot next, or you can use a self dot top dot next is equal to none, right? Else, that means already if the node is available, then what we have to do, so we need to assign new dot next is equal to, that means we have to insert the element at the beginning itself. So beginning will be the new node and the next node will be the present top. So begin new node dot next should be self dot top. Right now the self dot top, a link will be established here. Now we need to assign the new node to self dot top. So self dot top is equal to new. That's it. So push operation has been completed. Then pop operation. So that means a deletion. Deletion will also be done from beginning itself. So here also there are three cases. One is the stack is empty. So first let us check self dot top is none. That implies stack is empty. Stack is empty, right? If that means the second case, that means if the stack is having only one element, that means self dot top dot next is none. Self dot top dot text is none. So simply you can use a print popped element is, what's the popped element? Top. So self dot top dot data. Okay, and now so just use line. Now we need to write the code. That means, so now we need to change the top. So self dot top is nothing but self dot next. Self dot next. So the second node will become the top. That's why self dot next. Sorry. We need to use it. Sorry. It is the only one node. So automatically we can assign the top to none. Self dot top to none, because this is a case if the stack is having only one node. Okay, then simply self dot top will be none. In the third case we need to write the code, right? So else, that means the third case. So what we have to do, we need to make the second node as a first node. For that purpose, just go with the temporary variable, assign the top to temporary variable, and now again the same thing. The deletion is top of data. Then we need to assign the next to top. So self dot top is equal to temp dot next, and assign temp is equal to none. That means deleted, right? So simply the second node is becoming the top and the first node becomes none, because temp is nothing but a first node. So very simple code, right? Now the third operation, that is display, def display function. So so here you can write the two cases. One is if self dot top is none, that implies print stack is empty. Right? So again here you can use lines. And now second case, if the stack is having a more number of elements, so simply you can print elements of the stack R. So assign the top to the temporary variable. So temp is equal to self dot top, and while temp, so until temp becomes none, that means a false. So simply print temp dot data, okay, and temp is equal to temp dot next. Temp dot data, temp is equal to temp dot next, and again come out from the loop and print the top of the stack. What is the top of the stack? So top of the stack is, what is the thing? Self dot top dot data, right? So again just give the lines, so the output will be very nice, right? Now execute, that's all. So push operation, pop operation, and display operation. I think rather than code, the beautification is more number of lines, right? So yeah, execute. Oh sorry, invalid syntax. It's class node. One second. Just a second. Yes, we have created a stack here, class stack, and class node. I think so. Let us close the. Just, I'm not finding any error. Just I am copying this one. I'll close the Jupyter notebook once and I'll restart the thing. I'll restart this thing. Let us check whether it is still getting the error. Yes, so I'll copy this one. So yes, I've copied this one. Still we are getting the same. Okay, here the class C is a small. Okay, yes, C is a small. Yeah, so it displays the operations. So one push operation, I'll push this 10, and again push operation, enter the element to be inserted into stack 20. Again I'll go with the push operation 30. Again I will go with the push operation 40. Now you can give the display 3. See, display 3 elements of the stack are 40, 30, 20, 10. Top of the stack is 40, right? Top of the stack is 40. Now go with the pop operation 2. Pop operation, yeah, I think so. Pop takes a 0 positional arguments but was given 1. So let us check here. So here we have not given the self, right? Yeah, now you can observe here, execute. So I'll go with the 1. So let us insert more number of elements here. So 30 and 40. So display. So top of elements of the stack are 40, 30, 20, 10, and top of the stack is 40. Again go with the pop operation 2. So pop, again we are getting some sort of error. So typo mistakes, line 21, it's a typo mistake. It's none. It's none, right? Once again just go with this one. So 10, 20, 30, 40, 3 display, stack are 40, 30, 21, 2. See, popped element is 40. popped element is 40 because the deletion operation will be done from the top. So topmost element is 40, so popped element is 40. If you display here, we'll get only 3, 30, 20, 10, and the top of the stack is 30. Still, again, second popped element is 30, and you can observe here, and again you go with the 3 display. Now 20 and 10 are the elements. Again, second pop element is 20, again 2 popped element is 10, again 2. See, stack is empty. So still, if you try to delete an element which is not available in the stack, so it will print the stack is empty, right? And if you go with a 4, it's an exit. So this is about implementation of stack using linked list. Hello friends, welcome back to our channel. So in today's session, we'll discuss about the implementation of queues using linked list. So queues, using linked list in Python. So already in our previous session we have discussed about the linked list, circular, double, and stacks. Now we will go with the queues. So we know that queue is a FIFO structure. That means a first in, first out. So whatever the element that enters into the queue first, that will comes out. So here there will be two ends. One is rear end, another one is a front end. So rear and front. So at the rear means back side, right? Back end. So the insertion will be done at rear. The insertion will be done at rear, and the deletion will be done from front, right? So that will be represented in this way. So if one element is entered, so this is the front, and this is the rear, right? So immediately, see, whenever the second element enters, second element will be inserted here, and it will be the rear. And whenever the third element enters, the third element will be here, and the rear will be here. And if you delete the element, the 10 will be deleted. So the 10 will be deleted, and the front will be moved towards the next one. So in such a way, the queue will be executed, right? So two ends will be there, rear and front. Though all the insertion of elements will be done through rear, and deletions will be done through front. Now we will see the implementation in Python. So first, initially we need to take the linked list. In linked list, we will take a node, so which will be having the data and next. So the data will be the normal data, whatever the element we are inserting, that element will be initialized to data, and initially the next will be none. So whenever a node is inserted, immediately, so that will give here, so the element and none, right? So this is the data part, and this is the next part, right? Now we need to initialize front and rear, right? So initialize the front to none, so I'll write here. So initialize the front to none and rear to none. So I'll explain you the concept, and then we'll go with the interpreter. I'll execute the program. Okay, so no, you need not worry for that. So first let us see the insertion. Let us first, we will see the insertion of an element. So we have seen that the insertion will be done at the rear end. So here case 1. So before insertion, if Q is empty, so how can we know that Q is empty? So if front is none or rare is none. Any one of these is true, that implies so Q is empty. Okay, if there are no elements, so both friend and rare will be initialized to none. So if both are none, either one is none, that implies that Q is empty. So if it is empty, we need to create a node, insert a node. Okay, so initialize. So a data to a data and next to none, and simply not a data. So friend is equal to new. So how we will create some new is equal to some node of 10. Node of 10. Immediately the 10 will be displayed here and none will be initialized here. So after executing this statement, new is equal to node of 10, a node will be created, and if Q is empty, this will be the first node. So if it is a first node, we have to initialize the new to friend and rare. So simply rare is equal to new, and you need not go with the next. By default it will be none, right? By default it will be none. And case 2, if Q is not empty, if Q is not empty, that means at least a Q consists of at least one element, what we have to do? So again, go with this one, new is equal to node of 10. So here let it be, the Q is having 10 and none, and one more element, one more node has been created. So after executing this second statement, that is a 20 and none, right? 20 and none. So the value is 1000 and the address is 2000, and here the friend and rare both are pointing towards the first node, right? So both are pointing towards the first node. So now after executing this statement, new is equal to, this is 20. So that should be inserted at the rare end, right? Insertion will be done at rare end. So here it should be. So you need to establish a connection between these two nodes. You have to establish the connection between these two nodes. So what we have to do? So simply rare. So this is a rare. So you can write here rare dot next. Don't write friend dot next, because here it is a single element. So obviously rare dot next or friend dot next both are equal. But if you are having two elements, then friend dot next means this element will be modified, right? So I'll explain. Let me explain this one. So rare dot next is equal to new. So obviously this none will be replaced with 2000. So if 2000 is here, there is a link established between these two nodes. Now what we have to do? Rare is equal to new. So here the rare will be pointing in this place. That's it. So simply rare dot next equal to new and rare is equal to new. For example, if you are trying to insert one more element, so node of 30. So let us take, so this is a 10, this is a 2000, this is a 20, this is a 2000, this is a 1000. Okay, and see, front is this one established, and repeat, there is no connection. See, yes, rare is pointing here. So after having two elements, this is the position, and we are inserting the third element 30. So this is the third element. What we have to do? We have to establish the link between second node and the third node. So initially this is none, right? This is none. Now what we have to do? We are executing this small two lines of code to insert any element if Q is not empty. So rear dot next equal to new. So what's the rear? This one. Rear dot next. What is this one? This one. And this is the new, right? So this is a new 30. So rear dot next. So is equal to new. So automatically the 3000 will be set here. A link will be established here, and rear is equal to new. So the rear will be pointing in this position, right? So hope you understood this one. So a very simple code. So with the two steps. So here we need to check two conditions. One is if queue is empty. If queue is empty, so create a node and initialize both the front and rear to that particular node. And if queue is not empty, simply change the rear dot next to new and rear is equal to new. That's it. Right? So hope you understood this one. Next we will go with the deletion operation. Deletion. So we will take 3 elements and we will see the deletion operation. So here the deletion operation will be performed from the front end. So let us write deletion. Let us take 3 elements. Or we will take the 4 elements. See 10, 20, 30, 40, and the address are 1000, 2000, 3000, 4000, and the address is 2000. So there will be link from 10 to 20. Here it is a 3000. So there will be link from 20 to 30, and here it is a 4000. There is a link between 32 and 40. And this is the last one, so none, and this will be pointing as rear and this will be pointing as front. Now what we have to do? We need to apply the delete operation. So here the deletion will be done from the front end, right? So case 1. Case 1. So case 1 means if stack is empty. Sorry, queue. We are talking about the queue. So if queue is empty. So previously we have checked the condition if queue is empty. When we say the queue is empty, so simply if rear is none or front is none, simply we can say queue is empty. So we can display the queue is empty. Deletion operation can't be performed. So because we can't delete the element from the queue which doesn't have any elements, right? Empty queue. From the empty queue we can't delete the elements. So we can simply display that empty queue. And case 2. So queue with single element, single node, queue with single node. For example, consider this one. So 10 and none. So this will be the front, rear. So if the queue is having the single element, then simply we can initialize that to none. So how can we check? Simply we can check if front is equal to rear. So if both are equal, that implies that is only a single element. If the queue is having only the single element, that is nothing but front and rear are initializing to the same element, right? So if front is equal to rear, simply you can give a front is equal to none. So none will be initialized to front, so automatically this node will be deleted. This node will be deleted. So that is a condition to check to delete the element if queue with single node. Now the third case, queue with multiple nodes. So I am erasing this one. Hope you understood this case 1 and case 2. Empty queue, queue with a single node. Then case 3. Case 3, queue with multiple nodes. So let us take this example, 4 nodes. 4 nodes are there, right? So what we have to do, we need to change the front because the deletion will be done from the front end itself. Okay, so first initialize this front to 10. Initialize this front to 10. You need to change the front value. So obviously after executing this one, so temp will also points towards the first element. Temp is also points towards the first element. Now simply you can change this temp to next element. Okay, temp to next element, or you can change the friend. So friend is equal to friend dot next. Friend is equal to friend dot next. So what is a friend dot next? Friend dot next is 2000. So friend will be moved to 2000. So immediately after executing this one, so the friend will be here. Now what we have to do? The temp should be none. So simply you can write the temp dot next is equal to none. So obviously there will be none here. So this element will be deleted. Or simply you can write temp is equal to none. Temp is equal to none. So this node will be deleted. So if you disconnect, that means here we need to remove the address of the next node. So immediately there will be, the connection will be lost between this element and this element. So for that purpose we are taking temp dot next equal to none. So temp points to the first node. So temp dot next is equal to none means there will be, the address will be removed so that the link will be disconnected. So we have already moved the friend. So after deleting the first node, the friend will be moving towards the second node. So that happens in this case. That happens in this case. Right? So by using this simple code, so we can perform the deletion operation. We can delete the element from the front end. So once again, if you delete this one, now front is here. So once again, if you want to delete, apply the DQ operation. See, temp is equal to front means again the temp value points here. So front is equal to front dot next. Front will be moved to 3000, right? Front will be moved to 3000. So here the front will be there, and here it will be removed. And temp dot next equal to none. Temp dot next is equal to none. So the address will be removed. So automatically the link will be disconnected. Temp is equal to none, and this will be deleted. Now front is here. Once again, if you want to apply the delete operation, the front will becomes here. And if you want to remove the element, it will check for front is equal to rare, the case 2. So front is equal to rare, this is single node, so automatically the front is equal to none. So this node will get deleted. Right? So this is a simple code for deletion operation. So we have written 3 cases. One is a queue is empty, queue with a single node, and queue with multiple nodes. Right? A simple code. So unless you draw the diagram, it would be difficult to imagine this one. So if you draw the diagram with the multiple nodes, then it will be very easy for you to write the code. Only the 3 steps. Only the 3 steps. Right? Now, the last operation, that is a display function. So how can we display the elements? How can we display the elements? Display, right? So simple. Here the we'll take so let us take the case 1. Case 1, queue is empty. So previously we have seen if queue is empty means nothing but friend is none. Simply we can say queue is empty, so we can display the queue is empty. And case 2, so we need to travel from first node to the last node. So we can simply iterate the statements until the friend, or simply, for example, if you consider 2 nodes or 3 nodes in the queue, so 30, and this is a none, and this is a 3000. So the address of this one is 3000 and 20, and here it is a 2000, and here it is a 1000. So this will be the friend, and this will be the rare, right? So we should not change the friend, right? We should not change the friend, but we need to print all the nodes from friend to rare. So in order to travel this control from first node to the last node, so first step we need to do is just initialize the friend to temp so that we can move the temp value. So obviously the temp will be pointing here. So while temp, that means until the temp is available. So we are just moving. Okay, so just print a data. So I will write the syntax. I will while execution. Don't worry. So we need to print each and every element, and we have to move the temp value. Temp is equal to temp dot next. So once a 10 is printed, then temp will be moved to 20, and temp, that means a true. It's not none. Right? It is pointing towards some other one. So temp dot next. Okay, print data. 20 is printed. Temp dot next. Again, temp is here. So while temp, yes, temp is equal to temp dot next. Now temp is none. 30 is printed and temp is none. Then while temp, none. So it will be stop. Hope you understood, right? So temp, see for example, while temp, so temp is nothing but 1000. See, temp is nothing but 1000, right? So immediately print data. So 10 will be printed and temp is equal to temp dot next. So temp is equal to temp dot next, that is 2000. So obviously this temp will be pointing here. Now again while temp, so temp is nothing but 2000, it's not none, so it is true, right? So what it display? It displays the 10, so 20, the data, it will display the data 20, and temp is equal to temp dot next. So here the temp is equal to temp dot next means 3000. So obviously the temp will be pointing here. Temp is pointing here. Now again while temp is equal to 3000, it's not none, so obviously print data. So 30 will be printed here, and again temp is equal to temp dot next. Now the temp becomes, see, none. So while temp, so here the condition fails, then it stops. So the value of Q is 10, 20 and 30. So we are checking only two conditions in this display function. One is if Q is empty and if Q is not empty. So whenever the front or rear is none, that implies the Q is empty. And if it is not none, simply we have to write the code. So we need to travel from first node to the last node, and we need to display all the elements of the queue. So for this we will write the menu. So we'll write some iterative statement and conditional statements, so repeatedly, and we can perform the NQ operations and the DQ operations. So I'll execute the code in the interpreter. So let's move on to the interpreter.
Hello friends, so just now we have seen the theoretical part of implementation of Q. Now I'll write the code and I'll execute and I'll show you. So first let us create a class for the node, so which will be having a two variables. So I'll have to initialize them. So this is a constructor we need to use, and X is the element to create the node. So self dot data will be the X, and self dot next will be none. And also we need to create one more class for the Q, so where we have to write all the operations. Initially write down the constructor and initialize the parameters. So self dot friend is equal to none, and self dot rear is equal to none. And here we need to write down the functions. So one is a NQ, which is an insertion function. So NQ operation. So the first parameter will be the self, and here we need to check whether the Q is empty or not. If it is empty, we have to insert. So first let us take the input. So X is equal to int of input. So enter element to be inserted into Q. So now next create a new node. So new is an object for node. So X will be copied to the data and next will be none. Now if the self dot friend is none, that implies it's an empty queue. So if it is empty queue, we need to initialize the front and rear to the same thing. So front is equal to new, and self dot rear is equal to new. And then if it is having one or more element, simply you can write it self dot rear dot next is equal to new, and change the rear. So self dot rear is equal to new, assign new to rear. So we need to change the rear value. So the insertion will be done at the rear end. That's it, right? And the next, this is the NQ operation, just we have seen.
Next, a DQ, that means a deletion. So deletion operation will be done at the front end, and here we need to check for the three cases. One is if queue is empty. So whenever the queue, when the queue is empty, if self dot friend is none, that implies the queue is empty. Simply you can write here. So print, so queue is empty, and the next case is first node. It is having only first node, right? Only one node. So self dot friend dot next is none, or simply you can compare if front and rear are equal. If front and rear are equal, right? That also you can use. So then simply what we have to do, so we need to pop the element from the front end. So pop element is, so what is the popped element? Self dot friend dot data, right? Then what we have to do? We need to change the friend, right? So self dot friend is equal to none. So we need to delete that. Else, that means if the queue is having a more number of elements, then simply change the change the friend value and make the first node as none. So temp is equal to self dot friend, and simply you can write this one the same thing. So because the popped element will be always the friend dot data, and change the thing, self dot friend is equal to temp dot next. So temp dot next value will be initialized to friend, and then go with the temp is equal to none. That's it. And the third function, display function, so which will display, and here also we need to check two conditions. One is if self dot friend is none, simply queue is empty. So the same thing we need to write here. And else, that means if it is having a more number of elements, so simply you can display one by one. So print elements of queue are, so what are the elements? So while temp, you need to travel. So first we need to initialize the self dot friend to temp, so that we can travel from first node to the last node using the temp value. So while temp, so until the temp is none, this loop will be repeated. So print temp dot data end is equal to, and move the temp to next, temp of next, and write down the front and rear, display the front and rear. So friend of queue is self dot friend dot data, print rear of queue is self dot rear dot data, right? That's it. So we are displaying only the front and rear, and now we need to create an object for queue, so that we need to, I mean, if you want to call these functions enqueue, dequeue, and display, so we need to create an object for the queue class. So I am creating the queue class, and here I am writing the menu, I am writing the loop, right? So print enter option from below, and here I am writing the options. Print 1 for enqueue operation, in the next line 2 for dequeue operation, and in the next line 3 for display, and the next line 4 for exit. And we need to read the input. So option is equal to int of input, so it will prompt for the input, and now we need to check these options. So if the option is equal to 1, simply we can write here NQ operation. We have to perform the NQ operation, right? So call the function. So print, call the function. So Q dot NQ, and elif, if the option is equal to 2, print DQ operation, and call the function DQ function. So Q dot DQ, because Q is a object for Q class, right? And next, elif option is equal to 3, so that's a display function. So print the, call the display function here. So Q dot display, and else if any other value, simply you can go with the break, right? Break. Now see, execute. So I'll go with the NQ operation. So 10, and again NQ operation 20, again NQ operation 30. So let's go with the 3, that means a display operation. So 10, 20, 30. So front of the Q is 10. So here we have given end attribute. So here we will give /n, and we'll stop this one. So go with the 4, and again re-execute the code. So 1. So let us take the input 10. So again NQ 20, again NQ 30. So go with the display operation. So the display operation 10, 20, 30, front is 10 and rear is 30. So go with the 2 DQ operation. So the popped element is 10 because the front is 10. So 10 is removed. Go with the display function. Now the elements are 20 and 30. Front of the Q is 20 and rear of the Q is 30. Again go with the second DQ operation. So popped element is 20. Go with the display operation. So the element is only 30. So front and rear both are pointing towards the same 30. So go with the DQ operation. Popped element is 30. Again go with the display. So you can see the Q is empty because there are no elements. So Q is empty. And if you were again want to delete the element from the empty Q, still we are getting the same result. That is, a Q is empty. So hope you understood this code, simple code. So unless you draw the diagram, it would be difficult to write the code. So particularly in the data structures, just draw the diagram with the nodes. So immediately you can write down the code for all the functions. So hope you understood this NQ, DQ and display operations of Q. Hello friends, welcome back to our channel. So in today's session, we'll discuss about one more concept in our data structures, that is searching algorithms. Searching algorithms. So there are different types of searching algorithms. So first we will go with the linear search algorithm. So linear search. And first, what is meant by this searching? Searching means finding an element whether it is available in an array or a sequence. So in Python we'll call it as a sequence. So unless you use the library NumPy, we are unable to create the arrays directly, right? So that's why we are taking here list concept. So we'll consider list as a sequence, and we are trying to find the element whether it is available in the sequence or not. So the first one is a linear search. So here what we have to do means, so comparing search element with all the elements of a sequence or list, right? So we are considering one sequence, so it will be having a multiple elements. So blindly comparing each and every element of the sequence with the search element. So if you found it, simply we will return the index of that particular value, the position. So to get the position, right? So just comparing each and every element. So for example, here the sequence is having 4 elements 10, 40, 60, 20. Right? 10, 40, 60 and 20. So the search element is some 60. So what is the process? So first iteration, the first step, 60 will be compared with 10. So failed. So second, 60 will be compared with 40. Failed. Next, third, 60 will be compared with 60. Right. So we'll stop iterating here. So this is how we have to implement the linear search. So comparing each and every element. And here one thing we need to remember. So elements of a sequence can be in any order. Because we are not bothering about the order, that means ascending order or descending order or any sorting order, right? Excuse me. Just we are comparing the search element with each and every element, right? So that's why in this linear search the elements of sequence can be in any order. And there is one drawback. So if the search element is 20, so we need to travel. So how many comparisons need to be done? The comparisons can be 1, 2, 3, 4. So 4 comparisons to be done. So in the 4th comparison, the search is successful. So that means in the worst case, if the search element is the last element of a sequence, so we need to compare from the first element towards the last element. So that is a drawback. Okay, so we need to perform all the comparisons. So for example, so here we are having only 4 elements. So if the list is having some 100 elements, what happens? If the search element is at 100th position, so we need to compare, we need to iterate, or we need to compare, so almost 99 elements. So 99 comparisons to be done, and at the 100th comparison, the search will be successful. So this is the drawback. So this was some sort of time taking, right? So, but the process is comparison of search element with all the elements one by one. Right? So let's have a look on the program. So I'll execute the program in the interpreter. Let's move on to the system.
Hello friends, so just now we have seen the theoretical part of linear search, how it will work. Now we'll write the program. So first let us take the input. So let us read the number of elements. Before that we need to use one sequence. I'll use a list concept. So I'm creating an empty list, and we need to take the input. That means now how many number of elements we need to insert into the list. So input, so enter number of elements to be inserted into list. So after that just read all the values, so n values. For that we can use a iterative statement. So I'll use a print enter n values, right? So here I'll iterate from 0, right? For I in range of n, so it means it will iterate from 0 to n minus 1. Okay, so what we have to do, I'm using the append function. So we are having an append function in the list concept. So append function will append the element to the list. So l dot append of, here we need to read the input, right? Input. So all the n elements will be read. Now what we have to do, we need to get the search element. We need to read the search element, right? So s is equal to search element is equal to, so I'm taking the input. So input enter element to be searched, right? So again
what we have to do, we have to compare each and every element with the search elements. For that, again, I am using the iterative statement for I in range of length of L minus 1. So if the search element, or simply you can use L of I. So L of I means first iteration L of 0, second iteration L of 1, third iteration L of 2, etc., etc., is equal to yes. Simply you can find, you can print yes, yes is found at position, what position? I plus 1. So I will be the index, right? So here the index will start from 0. That means if the position is 3, the index will be 2. Okay, if the position of the element is 3, the index of that position is 2, because it will start from 0. So that's why exact position, I am printing the exact position, so I plus 1. And simply you can break, so you need not compare for the remaining elements, you need not compare with the remaining elements. And after coming out from the loop, so if it come out from the for loop, okay, without any successful execution, here you can print yes is not found in list, right? So that's it. Execute. So enter the number of elements. I'll give you 4 elements, so we need to enter 4 values. I'll give a 10, 20, 30, 40. Search element, I'll give 30. Oh, we got some error. Let us check. For in I in range unsupported list int. Okay, so here we need to close the brace here, not there, right? See, 4 elements, so 10, 20, 30, 40, and the search element is 30. So you can see 30 is found at position 3. So it will start comparing from first iteration. And once again we'll go with the 4 elements, so you can take any order, in any order. So 40, 100, so 20 and 30. So I'll go with the 100. So 100 is found at position 2. Coming to the false case, so I'll go with the 4 elements, so 10, 90, 30 and 50. I'll go with, I will search for 100, so which is not found in the list. Okay, after completion of this iteration, if still the control doesn't end, automatically it will execute this else. So if the search is found, automatically break, it will come out from the for loop and it doesn't execute the else, right? Only if it is a break, this is an unconditional break, right? So hope you understood this one. And simply in order to avoid all these things, you can also write directly the iteration, the membership operators, by using the membership operators. So if yes in L, if yes is in L, so you can simply print is found at position. So here we need to find the position. So find the position will be, we can use a index method. So we are having the index method, so we can use the index method to get the position, right? Okay, so I'll go with the 4 elements, so 10, 40, 30, 20 and 50. I'll go with the 30 or 20. So you can see 20 is found at position 2. So you can use directly the membership operator, because we are using Python. So we are directly having the search operators, membership operators. We can use a membership operators, or we can also use the iterative statements as we have discussed it just now, right? So this is the linear search, and one advantage is then elements need not be in a sorted order, and one disadvantage is if the element, the search element is available at the last position, we need to travel from first element towards the last element. Okay, the time taking, the time will be more, right? So hope you understood this one. Hello friends, welcome back to our channel. So in today's session we discuss about one more searching algorithm, that is a binary search. Binary search. So in our previous session we have discussed about the linear search, and we have found that a drawback, if the search element is at the 100th position, so we need to iterate from the first element towards the last element, because just we are comparing each and every element. So the time complexity will be more. So if we take more time, if there are more number of elements in the list. So for example, if the list or a sequence as having only a limited number, that means 10 elements or some 5 elements, then it would be very easy. So it requires only 4 comparisons or 5 comparisons. But if it is 1000 elements, so it requires some 999 comparisons, and at the 1000 comparison, the search will be successful. So in order to avoid that one, so we will go with the binary search. So the first advantage of using this binary search is we can reduce search space. So you did not, even though the search element is successful at the last position, so we need not perform all the iterations, right? So we can reduce the search space. And the next, one condition should be satisfied before applying this binary search, that elements should be in a sorted order. Elements of a sequence should be in sorted order. This is very important. Sorted order. So unless the elements are in sorted order, we can't perform this binary search, because based upon this sorted order, if the elements are in the sorted order, then only we can reduce the search space, and by iterating that one, so we can find the search element. Right. Next. So how it will be done? For example, we are having a sequence, list is equal to some 10, 20, 30, 40, 50. So I will take only 5 elements. And I am writing the index values here 0, 1, 2, 3 and 4. Okay, so these are the index values. So this row is nothing but index, right? So first we have to find the low value and the high value. That means, what is the low value? The starting index with the low value. What is the high value? The index of the last position. Okay, so I take low as 0 because 0 is the starting index, and high value as 4. High value as 4, right? So this we can call it as the length of L minus 1. That is nothing but 4. So if we are having some 10 elements, the high value will be 9. If the list is having some 50 elements, the high will be, so length of L, that means the 50 minus 1, that is the 49. So 49 is the index of the last position. So first we need to find out the low and high value. So then we have to calculate the middle element. What is the middle element? So how we can get the middle element? Middle element is equal to, so low plus high, the low index plus high index 2. So here I am using the floor division operation. So if you use the division operation, we may get the float value, right? So for example, so 9 divided by 2. 9 divided by 2. So 9 divided by 2 means, so we will get here some 4.5. So if it is a floor division, 9 floor division of 2, so it will be 4. So that's why we are using the floor division, particularly in Python. So in other languages we don't have this option. So we'll get only if both the numerator and denominator are integers, we'll get the result in an integer. So directly we can give this one. But here that's not case. In Python 3, so even though the numerator and denominator both are integers, the result will be the accurate. So that's why we are going with the floor division. So here, by calculating the middle value, so we will get the middle index. All these are the indexes, right? So low is index, high is index, and mid is index. So what we had a mid value. Okay, we had a mid value. So what we can do, see, for example, the search key is some 20. Search key is some 20. And here I write the second case, search key is some 40. Search key is some 40. Two cases. So one thing, so here we can compare the mid value. So how can we get the middle element, not the index, middle element? So L of mid will give the element. L of mid will give the element, not the index, right? So if this is equal to the search value, if this is equal to the search value, so this is case 1. Case 1. If this is equal to the search value, so obviously search will be found and we can say that the search element is available in the position mid. Mid is nothing but index value. Case 2. That means if it doesn't match, so three possibilities. If you want to compare two numbers, three possibilities. One is both are equal. Second one, first number is less than the second number. Third one, first number is greater than second number. So we need to find out all these cases. For example, here you can see if this is wrong, if this is failed, so L of mid is greater than yes. That's the case 2. And case 3, L of mid less than yes. So three conditions. So if it is equal, automatically we can stop the procedure. Okay, we can stop the procedure. So you can observe here, we are having a 5 element. If we are calculating the middle element and we are searching. So even though the element is in the third position, for example, so in this case, let it be S is equal to 30. S is equal to 30. What happens here? Mid is equal to, so low 0 plus 4 by 2. 0 plus 4 by 2, which is nothing but 2. So L of 2 is equal to 30. So L of 2 is nothing but 30. So this is successful. So that implies if even though the element is at the third position, we are not comparing the previous elements, right? So which happens in the linear search. So if the element is in the third position, we have to compare the first two elements. Then only we are comparing the third element. But here it is not that case, right? Even though the element is in the middle position, that means the third position. So we are directly checking the third position by finding the mid value. So now the case is if S is equal to 20. If S is equal to 20. So what happens here? So this implies, see, L of 2 is equal to yes. That implies, so 30 is equal to 20. So we are taking 20 here. So this fails. So that must be either second case or third case. That may be either second case or third case. So let us check with the second case. L of 2 is greater than yes. That means 30 greater than 20. 30 greater than 20. Yes, true. This is true. This condition is true here. So see, 30 is greater than search element. The middle element is greater than the search element. So here what we have done, elements of sequence should be in a sorted order. If the search element, if the middle element is greater than search element, middle element is greater than search element, obviously the search element should be on the left hand side of the mid element, right? So for example, you can observe here, this is the middle element. You are saying that middle element is greater than the search element. Obviously, it is in a sorted order. The element should be on the left hand side. So we don't know the element. Obviously, the element will be on the left hand side. So it may be available or it may not be available, but it should be in left hand side. So what we have to do, again we need to change the low value and mid value. So the search space is reduced to the left hand side. So here the low value will be remain same, 0, and the high value will now become, we have already verified with the middle element, so this one. So the high value will be mid minus 1. So that means the search space is reduced in this space. Okay. So in the first iteration, the search space is around 5 elements. In the second iteration, so the search space will be reduced to only 2 elements. So just careful. So here 30 is greater than 20. 30 is the middle element. 20 is the search element. So if the middle element is greater than the search element, obviously the search element will be available on the left hand side of the middle element. Now we will go with the second case. Okay. So after that I will explain this problem. Second case. So if S is 40 now, if S is 40 and L of mid is equal to 40. So L of mid is 30 is equal to 40. So this is false. It will move to the second condition. So that is L of mid greater than yes. That means 30 greater than 40. Again it is false. 30 is not greater than 40. Again it will go with the third one. L of mid less than yes. Less than yes. That means so 30 less than 40. So that implies the middle element is less than search element. Middle element is less than search element. So that implies the search element will be on right hand side of the middle element, right? So simply we can change the, similar to this one, change the low and high. So the low value will be, okay, mid plus 1, because already we have compared with the mid. So low value will be mid plus 1 and high value will be again the length of L minus 1, that is the 4. That's it. Length of L minus 1. Okay. So we need to repeat this process, again find out the mid and again calculate these 4 conditions, these 3 conditions. Okay. So here we need to change the low value, so high value. So high value is equal to the mid minus 1, and in this case we need to change the low value. Low is equal to mid plus 1 and high is equal to some length minus 1. Okay, so this is the cases we need to do. And now we will see an example, right? So let us take an example of this one and we will calculate. See. Let us take search value as some 10. Okay, search value as 10. So let us consider the mid value. So mid element is equal to 0 plus 4 floor division of 2. So the mid value is 2. So we need to compare L of mid is equal to yes. So what happens here? L of mid means L of 2 is equal to yes means 10. S means 10. So L of 2 means 20. 20 is equal to 10, which is false. So we need to check for second case. So what is the second case? L of mid less than yes. So that means L of 2 less than 10. So 20 less than 10. Sorry, L of 2. Yes, 30. It's 30, not 20. Here is also 30. Okay, 30 is less than 10. No. So go with the next one. L of mid. Only 3 conditions. Greater than yes. Only 3 conditions. One is equal to, one is less than, one is greater than. So L of 2 greater than yes. So 30 greater than 10. 30 greater than 10. Yes, correct. That implies the search element, the middle element is greater than 10. So the search space will be less. Right? So here we will be having low is equal to 0 and high is equal to mid minus 1. Mid minus 1. So because already we have compared the middle element, right? So here we have compared mid element. So we have to reduce the search space from 0 to mid minus 1. So again calculate the mid value. So mid value is equal to 0 plus high. Mid minus 1 means mid is 2. 2 minus 1. 1 floor division of 2. So we'll get a mid value as 0. So L of mid, again compare the three conditions. L of mid is equal to L. What is L of mid? 0. L of 0 is equal to 10. L of 0 is 10. So 10 is equal to 10. So true, automatically the search is found. The search element is found. Right? So in this way, we have to iterate the same step. So we need to find the mid value for all the reduced search space. So keep on iterating. So we are reducing the search space. Right? So if there are n, so in the first iteration we will reduce the space to n by 2. In the second iteration we will reduce the space by n by 4, etc. and finally, if you get this one, so we'll do that. Otherwise, so the search will be not found. Right? So hope you understood. So if low is greater than high, simply that implies the element is not there. Okay. So low should be always less than high. The low value should be always less than high. That we know that. Right? So index values, we are starting from low and high is the last index. So if the calculation, by this calculation, if any case, if low is greater than high, that implies, so the element is not available in the list, available in the sequence. So we need to repeat this process, finding out the mid and changing the reducing the search space until the low greater than high. Right? So hope you understood this one. So we'll move on to the interpreter. I'll execute the program and I'll show you. So if still anyone having any doubts, so the doubts will be cleared. So let's move on to the computer. Hello friends. So just now we have seen the theoretical part of binary search. So we'll execute the program. So this can be done in two ways, iterative and recursive. So we'll see the iterative method. So first I'll give the sequence. So list, and we need to take the input. So how many number of elements we need to insert. So input of enter number of elements to be inserted, and after that we need to read all the elements. So I'll go with the loop iterative statement, I in range of n, read all the elements. So I'll use the append function. So append, and here I'll go with the int input. Right? So before that I'll display one message to enter the element. So print enter n elements. Okay, by using this one it will display the message and will prompt for the number of elements. After that, the one condition we have to check before applying the binary searches, it should be in sorted order. So I will go with the function called l.sort, so which will sort all the elements. So sort function is available in the list, right? So once it was done, so we need to find out all the remaining. So that means we need to reduce the search space by finding the middle element. So low it will be always 0 and high will be always the length of L minus 1, and always initially the mid value will be 0, and we need to iterate this thing, means finding the mid value and everything. So until the low value less than or equal to high. That means whenever the low greater than high, the iteration will stop. Right? So we know that the low value should always be less than high or equal to. So if it is greater than, automatically we have to stop the process. So we need to find out the mid value. Mid is equal to low plus high modulo, floor division of 2. And after finding the out of mid, we need to check for the conditions. If L of mid, we need to take the element, right? So some s is equal to int of input enter search element. So we need to read the search element. So L of mid is equal to yes. So simply we can say s is found at position
mid plus 1. So mid will give the index value, mid plus 1 gives the position, as we have discussed in our theoretical session. So if the position is 3, the index value will be 2, and you can break the statement. Okay, you can break. You did not go for the next iterations. And if it is not successful, that implies again we need to check one more condition, L if mid is greater than yes. So what we have to change, so that means the middle element is greater than the search element, so the search element will be available on the left hand side of the middle element. That means we need to change the high value, so high will be mid minus 1. And in the rest of the case, that means if two cases are false, that means middle is equal to yes and the middle greater than yes, both the cases are false. That implies nothing but the middle element is less than the search element. Middle element will be the middle element is the less than search element. That means the search element will be available on the right hand side. So we need to change the low value with mid plus 1. So already we have verified with the middle element, we need to change the mid. So else, that means if nothing, none of the condition is executed, automatically it will come under the else part. So here you can give yes is not found. That's all. Very simple. We need to check the 3 conditions. We have to find the middle value and we have to check the 3 conditions. Execute. So I will go with the 4 elements. I'll give in a random order. So 40, 10 and 30 and 20. So these are not in a sorted order, right? So here I am giving some 20. So you can get 20 is found at position 2. So before going to that, we can print the elements after sorting. So print after sorting, print yes. So I'll go with the 4 again 50, 30, 10, 20. So after sorting 10, 20, 30, 50, and if you go with the 50, so 50 is found at position 4. Very simple. And if I can execute, so 4 elements, so 30, 20, 40, 10, and if you are searching for 50, 50 will be not found. So this is how we can find the binary search, right? Hope you understood. And if you are using the recursion, right? So this we have implemented by using iterations, and if you want to execute the thing by using iterations, okay, simply you can change the code, simple code. So before taking this one, after finding all the things, just call the function. So find out the mid value, remove, find out the middle value here. So low plus high 2 and open braces, and yes, now you can call the function. So binary search of, pass the list, low value, high value, mid value, and the search element. So we need to write down the functions here. So we need to write down the function here. So I'll write down the function here, right? So all the user defined functions should be written in the beginning itself. So def binary search of L, low, high, mid, and yes, 4 parameters. So here we need to write down the code. So whatever the code we have written, the same thing. So low less than or equal to high, find out the mid is equal to, so again low plus high 2, okay, and if L of mid is equal to yes, so simply you can print yes is found at position same, which is a mid plus 1, and yes, and next elif L of mid greater than key, sorry, greater than yes, search element, key means search element, and we need to change the high value. We need to change the high value. So simply you can again call the function. So search. So what is the thing? First L, low, and high will be changed to mid minus 1 and middle element and yes. So we have changed the high value to mid minus 1. So now the search space will be from low to mid minus 1. And the rest of the case we need to change. That means if the middle element is greater than search element, we need to change the low value. So again call the binary, the recursive function search L mid plus 1 to high with a mid and yes. Right? And in this else case, simply print yes is not found. That's it. Execute 4 elements. So I'll give 40, 10, 30, 20. So after sorting this one, so I'll go with the 30. So 30 is found at position 3. So this is by using the recursion. So instead of writing the code, we are just calling the function itself. So here itself we are changing the high value and here we are changing the low value. So once again, so execute 4 elements, 20, 30, 10, 50 and I am searching for 40. So 40 element is not found. Right? So hope you understood. This is the execution by using an iterative process and this is the execution by using the recursive process.